Hello everyone and welcome to the Complete Python course. This course is designed to teach you everything you need to know about the Python programming language. This is going to assume you're a complete beginner, you have no knowledge of Python, and bring you through right from the beginning all the way up to expert and advanced level features. So this course is actually a combination of a bunch of videos that I've created over the past few years. It starts with beginner Python programming, goes to object-oriented programming, then into intermediate and advanced level features. So those are the four main sections of this course. It's kind of split up in those four sections, and within those sections there's a bunch of topics. Now if you want to figure out what section to jump to, or you want to see what's involved in the course, look in the description. There'll be a bunch of different timestamps that show all of the different topics that are covered, and feel free to skip through and go to the ones that you find the most interesting. So with that being said, this video has taken a very long time to compile and create, so I would appreciate it if you guys leave a like, you subscribe, and you consider becoming a channel member if you want to support me on a monthly basis. So with that being said, let's go ahead and get into the full Python course.
Hey guys, so welcome back. Today I'm going to be doing a Python tutorial series. So this is the first episode in the series. It's kind of an introduction showing you how to download Python, how to install it, and then going into data types and variables. So the first important thing to understand about the Python programming language. So don't worry if you've never programmed before. I'm going to be going over everything very slowly and in depth so that you can understand. I recommend that you follow along with everything I'm doing in the tutorial. Pause the video at certain points, rewind if you don't understand. It's important you understand these parts so that we can move forward into more complex ideas. So obviously the first thing that we're going to have to do if we're going to learn Python is we have to install it on our computer. So we're just going to go to the Python website up here, python.org/downloads right here. And all you're going to do is just click download Python 3.6.1. Now, I'm not going to do that because I already have Python installed and downloaded on my computer. But pretty much once you download this, it's going to pop up down here in your downloads folder. Just run the exe. It's very simple, and you'll be running Python in no time. So now pause the video, go ahead and do that, and then we can go to the next steps. Okay. So once you've done that, you're going to notice that you have an application that looks like this. It's called IDLE Python, and then it'll have the version. So I'm using version 3.5. Don't worry if you have a version that is larger than that, so 3.6, or even one that's before that. Most of the things that I do in this will work in all the versions of Python. Okay, so go ahead and run the IDLE. You'll notice the first thing that pops up is the Python shell. As you can see at the top here, the shell. Now, this right here is not where we're going to write all our programs. It's the console, kind of. So here I can type any lines of code. For example, I want to print a name like this, and it'll run right away. So that's not what we're going to do. You can play around with this if you want, but we're going to go to File, and we're going to click New File, and then here we go. So now we have a new document that we're going to be working on and we're going to be programming in. So I'm going to go ahead and I'm going to save this right away as tutorial 1 into my tutorial folder, which I believe is on my desktop. Right here. Yep, right there. Awesome. Okay, so there we go. We've saved it. And now we're ready to learn a little bit about data types. So pretty much Python is a fairly basic language in comparison to a lot of other ones. A lot of things that it does is more simple than other languages, but it is important to understand the basic data types. So there's 4 main data types in Python. There is a few more, but we're just going to talk about these ones right now. The first one is an integer. So that can be a short form int. That stands for integer. Now an integer is any number, so such as 1, 4, 76, any whole number. It's important that it is a whole number. It could be a negative number as well, -5, 0. Those are all integers. Okay, now we have strings. Now the short form for strings is str. Now pretty much a string is anything embedded in quotations. So like this, this is my name, Tim. That is a string. And then we also have something like this. This would be a string. And even like this. This would be a string. So although there is a number in here, since it is between these two quotations here, it is a string. So even if I did another number like that, string. Now it's also important to understand that it doesn't matter if you use the single quotations or the double quotations. Sometimes we use the single quotations because inside of our actual quotations we want to use the double quotations, or maybe if we use the double quotations because we want to use the single quotations inside of our actual string, like that. Okay, so those are just a few examples. Now we have Boolean variables, or data types, sorry. So Boolean data types is something like true and false. So true and false, pretty basic. These are reserved words in Python, meaning that they're highlighted in yellow and that you cannot use them for variable names. That's going to be important later on. Just know that they are important words, true and false, and they do start with capitals. So for example, if I type true like this, it's not highlighting orange, right? So that's because true in Python, the keyword for that starts with a capital, so true and false. Then we have the decimals, which are the float data type, like this. So anything with a decimal floating point, so 1.23, anything like that, any decimal number with a floating decimal point would be a float. Okay. So those are the 4 basic data types. There is a few more that I'll go on to later on, but you just have to understand these ones right now. So now that we know these data types, I'll give a quick little quiz here. So I'm just going to put a few things right here. And then I want you to pause the video and go ahead and try to determine what type of data type these things are. Okay, so go ahead, pause the video, and then I'll go over the answers in a second. Okay, so we'll start with the first one here, hello. It's the same example that I have up here, except in single quotations, so we can see that it is a string data type. Okay, so that is the short form str. Now we have the number 123, that would be the integer data type. We have another number here that has a decimal point, so 3.22. That would be a float. We have the keyword true. This data type is a Boolean data type. Then we have 2 in quotations. This is very important. We don't want to get this mixed up. This is a string. Some people may think that it's an integer because it's 2, but no, it actually is a string because it is inside of the quotations. And then same thing here, 3 inside of the double quotations, again, is a string, not an integer. Okay, so now that we have an idea of the basic data types, I'm going to show you how to create a variable. So pretty much you may have heard of variables before in math or something like that. In math, we tend to use x as a variable. We say x may be 5, x may be 4, anything like that. It's the same thing in Python. Now, declaring a variable in Python is very easy. All you have to do is type the variable name. So in this case, I'm going to use name, and then simply give it a value. So this value, as you may remember, is a string. This is my name, and I'm just storing it in the variable name. Now, if I want to access that variable, I want to see what that variable is, I can print it to the console by simply typing the variable name, which is name. So now we'll see what happens. If I run the program, just going run module, I'm going to use F5 from now on. So that's the thing, and you can see it prints out Tim, just like that. Okay, now say we did that, we have name equals Tim, we printed it to the screen. Now maybe we want to change that variable. Well, it's very easy. Again, all we have to do is just type the value name, and now maybe we're going to change it to Bob. And now we want to see what the new variable is, so we will print it to the screen. We'll print name, click F5 to run that, and we'll see name, and Tim, and then Bob. So like we have here, name equals Tim, print name equals Bob, print name, right? So we've set it like that. Okay, so that's pretty basic. Now you can create variables of different data types. So for example, if we had a variable age, I would use an integer data type, so like 18 for that variable. And then again, if I wanted to print it to the screen, I would type print and then the variable name, like that. Okay, 18, perfect, right? So we printed that to the screen. Again, if the variable names, there's a few restrictions on variable names. So here you just see I've used 3 lowercase letters. Your variable names can contain underscores. They cannot contain dashes. They can only contain underscores, text, and they cannot start with a number, I believe. So if I try to do one name equals 2, for example, I run into an invalid syntax error because we can't name a variable starting with a number. Now I can end it with a number, I believe. Let us try. Yep, so that's fine. It's let us do that. Name equals 1. I could do name underscore person, maybe. Yeah, name underscore person. You see if I run that program, everything's fine there. But I can't put something like a star in my variable name. You see how we've got an invalid syntax there, right? But this is because these symbols represent something else in the Python language. So just know for names, we can use capitals if we'd like. I could use name like that. So run the program. That works fine. But I cannot start it with numbers, so I cannot put a number there. And I cannot contain anything other than underscores, text, and numbers in or at the end of the variable name. Now here's a quiz for you. If I make a variable called name, do another variable called name, are they the same thing? Now that's a good question. Are these two the same thing? No, they are not the same thing. So capitals do matter in Python. The all capitals variable name is different than the variable name. So again, name like this is different than all of those variables there. Okay, so I think I've covered a little bit on variables and data types today. This is the complete basics, just wanting to get everyone caught up. In the next video, we'll go into some more advanced things, maybe operations of variables, adding them together, subtracting, multiplying, Boolean conditions, things like that, okay? So I hope you enjoyed the video today. Stay tuned, and we're going to have another one out tomorrow. And like the video if it was good, and subscribe. So yeah, thank you. Hey guys, so welcome to the second video in the series. If you remember in the last video, we talked about data types and variables. We went briefly into some of the things that Python can do. Today I'm going to be talking about operators, and we're going to be doing some print statements, some input, a few small console applications, and just applying some of the knowledge that we've learned. So pretty much the first thing I want to do is I want to go back and I want to review what we did in the last lesson very quickly. So we talked about variables and data types. So for example, the x variable, we could set it to something equal to 2, like that. A name, we made equal to our name, right? So I make that equal to Tim. So there we go. We have the name right there equal to Tim. We'll start with that, okay? Now, if you remember in the last one, I didn't talk about this, but I used something called print. Now, the print statement pretty much takes an argument. So inside of these brackets, the thing that is inside that brackets is called the argument. So it takes a string argument usually. So I will give it the name. So now you'll see, again, we did this in the last one. Just want to review. I'm clicking F5 simply to run the program. When I go to the console, it simply puts Tim onto the console, just like that, right? Okay, very basic. We already did that. So now let's say, well, we want to do something else. So let's print here. And we're just going to put a string, and we're just going to type this in ourselves. So let's say, hello, comma, what is your name? That's going to print to the console. Now we want to get what the user's name is. Now there's a way to do this in Python. It's very simple. We're going to make a variable name. It makes sense to put the variable name here. Do an equal sign because it's a variable, right? And we're going to type the word input, just like this. Now what's going to happen if I run the program here, I'll show you, is it's going to say, hello, what is your name? And it's going to actually allow me now to type into the console, which I couldn't do before. Now nothing happens after when I click enter because we don't have anything else after that, but it's allowing me to type. Okay, so now, well, we want to print out what the name is that was said. So let's just simply type print and then name. All right. And we have, hello, what is your name? I say, oh, well, my name's Tim. It says Tim. All right. Now, well, we just printed out the name, but maybe we want to go a little more advanced than that. We want to say, well, hello, Tim. How are you doing, Tim? Something like that, right? So I'm going to just put a comma here. I'm going to separate these two things, and I'm going to put in a string. And I'm just going to type what I like to type, so I'm going to say hello with a comma. And then you see that I have this other comma here that is outside of the quotations, meaning it's not a string. It's actually just separating the two arguments in here. And you'll notice what happens now when I print is it goes, hello, what is your name? So I say, oh, well, my name's Tim. It says, hello, Tim, right? So that's pretty straightforward. I hope that's easy to understand. We're just using the input to get an input, and then we're printing it back out to the screen. Okay, so let's go into the next part of this. Now we'll use that again later, but let's talk about operators. So operator, that term may sound familiar to you. In math, we use things called operators. So these four operators hopefully should look familiar to you. This is a plus sign. This is the addition operator. We have the minus sign, which is the subtraction operator, the division sign, which is the, well, division operator, and then the multiplication sign, which is, again, the multiplication operator. So there's a few more operators that we'll talk about, but these are the four basic ones in Python. Now, you remember how I talked to you about data types? This is where this comes in. When we use these operators, it's important that we use them on certain data types. So for example, in math, I could do something like 3 plus 4. Right? So what does 3 plus 4 equal? Well, that is equal to 7. So the computer can actually do that math operation by using that operator to return those values. So let's give an example here quickly. So I have, let's do num1. We're going to use variables here. Remember, I can use a number in the variable as long as it's not at the beginning. And I'm going to give it a value of 45. And then we'll do num2, and we're going to give it a value of 3. Now, if I want to print to the console, let's say num1 plus num2, well, you can guess what that's going to give us. It's going to give us 45 plus 3, I hope, if this is not an error. Yeah, so that gave us 48, right? So, oops, didn't mean to make that full screen. Num1 plus num2 is 48. All right, so now what about minus? Let's try this. 42, basic. We can do multiplication here with the multiplication sign. There we go, 135. And then we'll try again with the division sign just to show you all of them. We get 15.0, like that, okay? So that's pretty straightforward, those four basic operators. Now in Python, there's a few more operators that we want to talk about. Now, for example, in math, we have something called exponents, right? So how do we do exponents in Python? Well, it's actually 2 stars is how you do an exponent. All right, and now maybe there's something called integer division, which I'll get into later, but I'll just show you the operator for it right now. It's 2 slashes. That means, I'll give you an example, a math example here. 64 divided by, let's do 10, would give us, usually in math, a value of 6.4, right? That's if you use one division sign. Sorry, what am I doing times? I mean, divided by would give us 64. I have 6.4. But now if we do 2 division signs here like this, it actually gives us a value of 6. That's because it just, it doesn't worry about the remainder at all. It just tells us how many times 10 can go into 64, and that's all. It can go in 6 times evenly. So it gives us a whole number as our answer. That's called integer division, this double slash like this. Okay, and then we have another operator, which is actually the modulus operator. So this is the percentage sign, and this gives us the remainder. So here, if I do 5 modulus 2, then the remainder of that is actually 1, because 5 divided by 2 is 4, then with a remainder of 1, right? So it's not going to give us the decimal points. It's, again, just going to give us the remainder. If I did 5 divided by 4, again, the remainder is 1. 5 divided by 3, the remainder would be 2, like that. Okay, so that's what the modulus sign gives us. So we'll put modulus here. And then there's probably a few others that I'm forgetting about, but we can go into those later. So now, same thing, let's keep using our number variables here. And now let's introduce a third variable called num3. Now, I want to show you how we can use the variables. So num1, and let's see if you remember what this operator is. So that's the exponent operator. So that means num1, which is going to be our base, which is 45, raised to the power of 4, because we're going to use num2. and we can print num3. Press OK. And you can see we get a pretty large number. That's because of how exponents work. And then same thing here if we want to do maybe integer division. Let's see what we're going to get. We get 11, right? A whole number. And then say we want to do modulus. We get 1. Okay, so now let's tie all of these things together with the operators that we've used, the variables, the prints, and the inputs. So let's start by just doing a little print statement and saying pick a number. Okay, pretty basic. We're going to pick a number, and then we're going to take the inputs. We're going to say num1 again is equal to the input of that. Okay, so we got the input of num1. Now let's say print pick another number. Alright, so now we're going to pick another number, so we're going to do num2 is equal to input, like that. And now what we're going to do is we're going to introduce our third variable, so we'll call it sum, because we're going to add these, is equal to num1 plus num2. And now actually you can't use sum because it's a reserved word, so let's just do in all capitals sum, because remember how we talked about variables, capitals and lowercase are different. And then we're going to print to the console the sum, like that. Okay, so we run the program. It says pick a number. Let's pick a number, let's say 4, and let's do 32. Now what do you think it's going to be? Oh, oops. Okay, so yeah, sum1 equals num1 plus num2. Okay, so this is why I talked about data types. So I'm actually happy this happened. It's because what actually happens when we get the input of something is it gives us the type of a string, which in this case is not what we wanted to do. So you saw there, I'll run it again. It's a good mistake that this happened actually. We have 4 and we have a 3, and it gave us 43. That's just because we added the string 4 to the string 3. So that simply gave us 43. But now we know in actual math that 4 plus 3 equals 7. So if we want to do the integers, we have to actually convert these variables into integers. So in order to do that, remember I showed you the keyword int like this before. We're just going to put brackets around our two variables here, like this, integers. And now hopefully we should get the correct answer when we do 4 and we do 3, and you can see we've got 7. So I didn't mean for that to happen originally, but I'm happy it did because it shows us why data types are important. So when we take the input of something, we're typing it from the keyboard, and that is actually a string. So here we can print again. Don't worry about what I'm doing right now, but I just want to show you the type, which is going to give us, if it's a string, if it's an integer, of num2, just to show you what the type actually is. So we pick a number, we pick 2, and we pick 3. It tells us that 3 is actually a string. So that's why when we added originally 3 and 2, or 2 and 3, or whatever it was, it gave us just them added together. So 2 and 3, rather than what it should be, which is 5. Okay? Now same thing here. If we had a number, and we wanted to convert it into a string, all we would do is we'd type str around the number. So for example, 3. And then that would give us 3, just like that, so a string. So now we've kind of gone over conversion of variables, conversion of numbers, data types, how to get input from the console using the input like this, and some basic operators of Python. So review this. I hope you followed along, and then in the next lesson we'll move into some more advanced operators, and we'll maybe start with conditions. Okay, I hope you enjoyed. Please subscribe, like the video, and I'll see you in the next video. Hey guys, welcome back to the third video in my Python programming tutorial series. Today we're going to be talking about something called conditions. So I hope you remember from the other videos, we talked about input, printing, we did variables, data types, and then we talked about operators. So operators like plus, minus, division, integer division, modulus, right? Multiplication, all those operators. Today we're going to be talking about a few more operators and then getting into conditions. So here in my file right here, I've put down 4 basic comparison operators. So pretty much a comparison is something that's going to return a value of true or false. So here we have, let's say if a real world example is Tim equal to Joe. Well, no, they're not, because Tim obviously is spelled differently than Joe, so that's going to be giving us a value of false. Same thing if we want to go into numbers, we say is 18 is greater than 2. Well, is that true? Yes, it is. So that condition gives us a value of true. It's a very simple concept, but it's something that we have to understand as we go into decisions later on, which will be in the next video. Okay, so these comparison operators, I'll read them off and just kind of give a definition of each of them. So the first one, can you be a less than or a greater than sign? Same thing with the second one, right? So it's just going to compare if something's less than, greater than. Usually these are used for integer values, that data type. We also can use them for strings, but it's a little more complex, and I'm not going to get into that right now, maybe in a more advanced tutorial later on. Now the equivalent operator, so the equal sign here. Now, a lot of people think, well, if I'm comparing something, why wouldn't I just use one equal sign like this? Well, that's a very good question, and a lot of people get mixed up on this. It is actually 2 equal signs. That's because in Python, the 1 equal sign is a declaration operator. So for example, if I put a variable x and I want to set it equal to 4, right? This is what we do with the 1 equal sign. We're setting values, right? So when we did name is equal to Tim, things like that, we're using 1 equal sign. Now, if we're going to check something, we're going to compare them, we have to use 2, because 2 equal signs and 1 equal sign have a very different meaning. So it's important to keep that in mind, that the comparison operator for equivalency is 2 equal signs. Okay, the next one is not equal to. So we have an exclamation mark, and then we have the equal sign, like this, okay? So an example of not equal to, because some people may get confused here, is to say if 4 not equal to 5. Oops, what did I type there? Not equal to 5. Okay, so what do you think this would give us? Just think about it for a second. Well, what it's actually going to return to us is true, because the condition is if 4 is not equal to 5. And here we can see obviously 4 is not equal to 5. So now again, if I give another example, we put 5 here. We say 5 not equal to 5. Well, that would return a value of false, because 5 is indeed equal to 5. Now we can do the same thing with strings. So for example, we have hello. Oops, spelled incorrectly. There we go. And Tim. Now, you can probably guess by yourself that this is going to return true, because Tim is indeed not equal to hello. Okay, it's pretty straightforward, but a lot of people may get mixed up with the not equal to if it's returning true or false. Okay, so those are the 4 basic comparison operators that we're going to use. So we have equal to, not equal to, and then greater than and less than. So greater than and less than, again, we use for numbers. So 1 less than 2, again, that's going to return true, like that, okay? So now we're going to start printing some things to the console and maybe doing a little bit of a quiz here just to see how you guys are going to do. So a Boolean condition, I'm going to store it in a variable. So I'm going to say name, oops, actually we're not going to do that. We're just going to print to the console 2 less than 3. Okay, now you guys guess and tell me what you think is going to be returned to the console. It's either going to be true or false. I'll give you a hint right now. Now it gives us a value of true. That's because this condition, 2 is less than 3, is true. It's equal to 3, right? So now if we switch the sign and we make it greater than, like that, well, you can guess what's going to come up. So we click enter and we get false. That's because this condition returns a value of false. Okay, now we'll do another condition here, all right? Hello equal to hello, okay? And guess yourself what this one's going to return? False, okay? That's because they are spelt differently. Now we're going to do the not equal sign just to show that one as well. Hello not equal to hello, and we'll see that gives us true because they are not the same. Fairly straightforward, but a lot of people do get these things mixed up. Now I'll show you what happens when I try to just do one equal sign like this. See, we get keyword can't be an expression. That's because we're trying to declare a variable here, but we cannot do that, okay? Because we're just using one equal sign here, we need to use two, all right? Okay, so now let's try another example, maybe a more advanced one. This is a little bit of a trick, okay? I want to see if you guys remember from my last tutorial what I talked about. So take a guess right now what you think is going to be returned. Do you think it's going to be true or do you think it's going to be false? Well, it was false, okay? That's because, again, what we talked about in Python, capitals matter, right? So any capital letter is different than a lowercase letter. So something like this, yeah, it's going to return false, all right? It's important to understand that. Okay, so we've very briefly gone into conditions now. I'm going to write a few on the side here. You guys can go ahead, I'll put them in print statements, and test yourself and see if you get them right or not, okay? I'm going to add a few tricks from the other lesson, try to kind of apply some of our knowledge and see if we can get them correct, okay? So just give me a minute here. I'm just going to write a few out. And then we'll go through the answers afterwards. Okay, so you know what? We'll just do these ones for right now, and we'll do a few other examples. Okay, so these are a little more advanced than what I was talking about before, but they are conditions. We have a left side of the condition, and we have a right side of the condition. So I hope you've taken a guess now of what you think these are going to be, because I'm about to print out the answer right now. Okay, so we've gotten true, false, and false. Alright, so for the first one, 2 less than 3. That's an example I already gave. That gives us a value of true because that condition is true. Now we have 2 minus 3 plus 4 greater than 5. So you can do the math there and see that that is going to be false. And then this one, some people may have gotten a little bit confused on because I actually used the words false and true in my condition that's going to return false or true. So I have print false equals true. Well, is false the same thing as true? No, it's not. So obviously we are going to be returned with the value false. Okay, so we've talked a little bit about conditions now. In the next tutorial, we're going to be doing something called decision. So I'll give you a sneak peek on what that is. Something like this, okay? So stay tuned for that. The next episode should be up tomorrow. And yeah, I hope you guys enjoyed the video. Go ahead, like and subscribe, and yeah, share with your friends. Thanks. Bye. Hey guys, welcome back to the 4th video in my Python programming tutorial series. Today we're going to be talking about decisions. So we're going to be using the if, else, and elif statements in Python. So pretty much I gave you a little example last time on what these are, but if condition equals true, then do this. Sorry, not his, do this. Okay, so pretty much the syntax for the basic if statement, which is what we are going to cover first, is like this. So if you remember my last tutorial, I talked about conditions. If you haven't seen that, go back and look at that first because that's going to be an important part of today's lesson and you have to understand that. So if condition is true, then we are going to do this. Now let's just dig into the syntax a little bit here. So you're going to start with the keyword if. Then we're going to put a condition. So the condition could be something like this: if 1 is less than 2, if tree is equal to plant, something like that, okay? Anything that can return a true or false value. You can use variable names. You can say if x is equal to y. Anything like that is condition, and it uses a conditional operator like I talked about in the last video. And then you are going to end your condition with a semicolon, or sorry, not a semicolon like this, with a regular colon, and then you are going to simply click enter and it should tab you in one line. Now it's very important that you have this indentation If you have your code like this, it's not going to work. Python reads the lines because of indentation, so it's very important that you have whatever statements you want to run after the condition returns true indented properly. And this will also be very important as we move further on in different tutorials and we have lots of different indentation levels within the program. Okay, so let's do a real example now instead of this kind of pseudocode here. So we'll start off by just getting some input from the user. So let's say, let's get their age. Okay, so age is equal to input like this. And then just if you put something inside of the input like this, it actually gives a prompt to the user. So we'll say input your age like that. And then we will say if the age is equal to 16, then we will print to the screen, hey, you're 16, like that. Okay. Alright, so let's go ahead and just test it out right away. I know I haven't really explained it, but I just want to show you how this works. Okay, so we have input your age. So I'll say 2 as my age, and we can see that nothing happens, okay? Now I want to show you one more. I hope you've caught this trick already from what I talked about in the last videos, but we'll see. Now you notice here, I'm going to put in 16, and nothing's going to happen. Now the reason for that is because 16 here is different than the 16 that we get from age. If you remember, whenever we're getting a number or anything from the console, we actually get it as a string. So this 16 that we're getting actually looks like this. Now in Python, again, we have different data types, right? So this is an integer data type, while this is a string. So when we're comparing integers and strings, they're different. So we have to convert our age variable into an integer before we can compare it like that, okay? Now we'll try again. Say if int age equals 16, so now we put 16 in and says, hey, you're 16, like that, okay? Perfect. So that's pretty straightforward. Now we can also do some other conditions. So let's do a greater than 16 now, okay? So this is another conditional operator that we talked about before. And yeah, we'll go ahead, we'll try it now. So we'll say 15. Now nothing happened because obviously 15 is not greater than 16. Now if we put in 17, it works. Okay? Great. Alright, and also I just want to show you there's another operator that we didn't talk about last time, a conditional operator, and it's the greater than or equal to and the less than or equal to. So to convert your greater than sign into a greater than or equal to sign, all you have to do is add an equal sign like this, and now anything greater than or equal to 16 will work. Whereas before it had to be strictly greater than 16, and same thing with the less than sign, like that, okay? I just forgot to talk about it in the other video, so I figured I'd put it in here. Alright, great, so let's go into another example then. So let's say, it's great, it's telling us we're 16. Or let's, in this case, we're going to be older than 16, right? So, hey, you're older than 16. But what if we want to message when we are younger than 16? Well, the way to do this is using something called an else statement. So the syntax for this, it simply has to come after an if statement. You can't just leave your own else statement like this. That will not work. It has to be after an if statement is placed, and then all you have to do is put a colon and click enter and make sure the indentation is the same as the indentation for the first if. Okay, so now we're just going to print you are younger than 16. Okay, and we can go ahead, we can try this to see if the else is going to work, and we say, well, we're 15 and you are younger than 16. Great. Okay. So just to explain this a little more, how this really works when we're reading through the code. Well, Python reads code line by line like this. Now when it reaches this if statement, it checks this condition to see if it is true or false. So since this condition was false in the last example, we say if false, it says, okay, so we're not going to run this line of code. We're going to skip to the else statement, and we're going to do this. Okay, so if we had typed anything in that does not return true, so makes this condition not return true, then it would go to this else statement like this, okay? Yeah, and then same thing, say we type in a number 17, and that is greater than 16, it's not going to do the else statement, it's just going to do the if statement, okay? I hope that makes sense. Now we're going to go into another layer, okay? So let's get into a new example here. Let's talk about height for a roller coaster, okay? So for some roller coasters, you have to be taller than a certain height, and you actually can't be too tall, right? So again, we'll get the input from the console, so we'll just say height is equal to input, and we're just going to do this in meters, like 1 meter, 2 meter, 3 meter, just to make it really easy, okay? I know that's not a realistic height, but just for the purpose of this example. So we say height is equal to input. Again, we have to remember that when we're going to check the condition, we have to make sure we put it in the int, because as we get it from the console, it's going to be a string, okay? So we'll say if height is less than 1 meter, we're going to say you cannot ride. So we're going to print to the screen, you cannot ride, okay? Now, we only want to allow the user to ride if their height is in between 1 meter but less than 2 meters, okay? So as you can see, I've introduced a new word here called elif. All right, so this means if this condition up here is false, then we're going to go to this one. We're going to check if this condition is true or false. If it's true, we're going to run whatever's in here. Otherwise, we're going to keep going. So you can have as many elifs as you possibly want in a decision statement like this, okay? You can only have one else though, because else is just the default, so anything you type in that doesn't equal any of these statements, so like if isn't true, elif isn't true, the other elif isn't true, then it'll go to the else statement, okay? So elif, the height is, so if it's less than 1, you can't ride, and if it is greater than 2, you also can't ride. So we're going to say you cannot ride. We're going to say, and we'll say over 2 meters, and then we'll put here, just so we can distinct them, under 1 meter, okay? And then now we're going to add in the else statement like this. We're going to say print you can ride. Okay, so I know I just did a lot there, so we'll go through it quickly. We pretty much have a condition up here. We already talked about the if statement, so if this condition is true, we're going to print this, and we're going to skip everything else. We're not even going to bother reading it because we know that it's not going to be any of those conditions. Okay, so now we do the elif here, right? So we say, well, if this condition's false, we're going to go ahead and we're going to check this condition. So we say, oh, well, this one's true. So then we're going to execute this line of code, which is the print, and we're not going to do this else statement. Now say we go through these two, and they're both false. Okay, so this returned false, and this returned false. Then we're going to go to the else, and we're automatically just going to print whatever is in the else statement like that. Okay, so we'll go ahead, we'll run the program, and we'll try it out. Make sure I haven't made any errors here. Okay, so the input, I didn't give a prompt, so I'm just going to type in the height, a number. All right, so we'll say 1. You can ride. Great. Okay. That is because, again, we have the strictly less than sign. Now, if we wanted it to be, you have to be over 1 foot, we just put an equal sign here, and then same thing here. Okay, so we'll do that, and now I'll show you again. If I put in 1, you cannot ride under 1 meter. Okay, so less than or equal to 1, right? Okay, let's try again now. We'll do it maybe a number greater than 2, so let's say we put 4. It says you cannot ride because you are over 2 meters. And then again, if we do like a decimal number, maybe 1.1. Okay, so we've run into an error there. That's fine, just because we can't convert a floating decimal point into an integer. But yeah, I hope you get the point from that example here. These are just the basic if, elif, and else statements. I'll do one more just to show you here. We could do another elif here, saying, for example, if int height is equal to, remember we do 2 equal signs, right, not 1, then we're going to say print wow you are tall. Okay, so as you can see, we can do infinite elif statements like this, and we can only have one else statement and one if statement at the beginning. Okay, so we'll run this one just to show you one more time how this works. I'll put in 5, so 5. You cannot ride over 2 meters. Okay, so that's because what actually happened here is we went if, we checked this condition. Now it turns out that 5 is greater than 2, so we did this one and we didn't bother reading the rest. Now if I wanted to change this so that it would check the 5 first, all I would have to do is put this elif statement, I'll do it right now, above the other elif statement, like this, and now if I type in 5, it'll work. Wow, you are tall. Okay, so that's it for the if, elif, and else statements. In the next tutorial, we're going to go into something called chained conditionals and do some more advanced examples of this. We're going to do some addition, subtraction, and some more things with other operators. Okay, so I hope you enjoyed. Please don't forget to like and subscribe to the video, and I'll see you again tomorrow in another video. Hey guys, welcome back to another video. This is the 5th video in my Python programming series, and today we're going to be talking about chained conditionals and nested if statements. So pretty much chained conditionals are just adding multiple conditions in one line using words like and, or. Okay, we also have keyword not that we're going to talk about as well. So if you haven't seen the last videos in my series, go ahead and watch those now because they are a prerequisite for this video. Alright, so let's get right ahead and start. So if you remember before, we have something called conditions. So for example, if we have the variable x, I'll set that to 2, and the variable y, which is equal to 3, we could have a condition like x equal y. Now obviously we know from the last video that this is going to give us a value of false. Oops, and I cannot type today, sorry. And that is because 2 is not equal to 3. Pretty straightforward. I hope you have all understood that from the last video. Alright, so what we want to do in this now is we're going to want to check multiple conditions. So we'll put a condition here. So if x is equal to y, and then we can put a word in like this, the and word. Now we'll add another condition. So if x plus y is equal to 5. Okay, so this first condition is going to give us a value of false, so if x is equal to y, because they are not the same. But now x plus y does indeed equal 5, so that is going to give us a value of true. So where I'm highlighting we have true, and then where I'm highlighting now again we have false. So because we have the keyword and, this if statement is not going to run. So I'll put a print here just to show you. We're going to print out true, or let's just say ran, and you'll see when I run the program nothing is going to happen. That is because when we use the and keyword, it means both conditions on either side must be true. So if we change this to something like if y is equal to 3, now that is going to be true, and we'll print out ran. Okay, so that's pretty basic. Now let's do the or keyword. So we'll put or right here, and we'll change this condition back to if y is equal to x. And now take a guess on what you think is going to happen. Well, pretty much with the or keyword, it means either of the conditions have to be true. So if y is equal to x or x plus y is equal to 5, then we are going to run this line. Now since x plus y does equal 5, we have a true here, and again y is not equal to x, so we have a false, and you'll see that the program is going to run. That's because only one of the conditions has to be true for it to run. Okay, so that is the and the or keyword. They are pretty straightforward and pretty basic. Now I'd like to point out that you can actually add as many conditions as you'd like. So now I can have an or, I can have an and, I could have another condition. I could do as many as I'd possibly can imagine and as many as I'd like to do. So now we'll put an else statement in here, and we'll change this just a little bit to use another keyword. We'll just put a sad face here to show that we didn't run it that we ran the else, okay? So now there's something called the not word, okay? So we're going to put not right here around it, and then I will show you what it does. So pretty much not reverses anything that you have inside of the brackets of the not. So in here we have if y is equal to x, or x plus y is equal to 5. So we know again that this gives us a value of true. So now since true is inside of the not, true becomes false. Now we have if false. So obviously that's going to bring us to the else statement, which is going to print the sad face. So I'll show you that that does indeed work. So we have the sad face, right? Now if we change these so that both of these conditions are false, you'll see that we have false, false, which is going to give us an overall value of false. And then we're going to have the not, which is going to change that into a true and will allow us to run it, just like that. Ran. So yeah, so that's how the not, the and, and the or work. And now let's get into nested loops. Or sorry, not nested loops, nested if statements. So we'll do a basic if statement here. If x is equal to 2, if y is equal to 3, and then we'll add our else's like this, and we'll put some print statements in here. Okay, just give me a second while I type out the print statements, and then we will go into what this is going to do. X equals 2, and y equals 3. So you may have guessed already, but pretty much we can actually add as many if statements embedded or nested as we'd like. So I could add another if statement here and just constantly keep checking. Now the reason I showed you chained conditionals is because if I didn't want to go through the hassle of adding all of these nested statements, I could just do an and right here and check for another condition, but sometimes we do want to do nested statements. So we'll say here x equals 2, y does not equal, 3. Okay, so I know I just did that pretty quickly, but let's walk through it now. So we have if x is equal to 2, then we're going to run whatever is in here because it is indented. So now we come in here and we say, well, is y equal to 3? Let's say it is. Now we're going to print out this statement and we're going to be done with this loop, with this bit of code. So we're going to skip down to the end of the program where we have nothing else. So let's say we do another example, x is equal to 2, but y equals 4. So that means we're actually going to run the else, which means now we've got print x is equal to 2, but y does not equal 3. And then the last case is x is not equal to 2, so we don't even bother checking if y is equal to 3. We just go down and we print x does not equal 2. So we'll change around the variables and we'll show you how this works just very quickly. So we can see x is equal to 2 and y is equal to 3. That is because obviously up here 2 and 3. Now if I want to change y and we change it to 4, we get x is equal to 2, but y is not equal to 3. So that means we ran this one in here. Now let's change it so that x is equal to 4 as well. And we can see we get x does not equal 2. Alright, so that's the basics on nested statements and chained conditionals. I hope you found this video helpful. Stay tuned for more videos. We're going to be getting into some more advanced topics, and in the next video we're going to be covering loops. Yeah, so if you liked the video, please subscribe and like, and I'll see you in the next one. Hey guys, welcome back to another video. This is the 6th video in my Python programming series, and today we're going to be talking about for loops. Again, if you missed the other videos in the series, please go back and watch them first, as it's going to be hard to understand if you haven't seen them already. Okay, so let's get right into it. Today we're going to be talking about for loops, and a loop is a new thing now if you're a beginner in Python, and I'll talk about how they work. We're going to start off by just writing one out, getting right into it with the syntax. So for x in range, and then we're going to put a number, which is going to be our starting position. So in this case, I'm going to put 0, and then a stop point, so 10. Okay, and then we're simply going to print out x. Now I know we did this pretty quickly, but let's talk about what this is and the syntax. So a for loop is going to run a certain amount of times. So in this case, we're going to start at 0 and we're going to go to 10. This means the for loop is actually going to run 10 times. So what's going to happen is we are going to have our variable x, which is right here, and every time the for loop runs, x is going to be increased by 1. Now, we can increase it by more if we'd like to by adding another comma here, but by default it is set to 1. Like this, I've just put it in so that you can visualize it. So really we have something, a start, a stop, stop, and an end. Start, stop, step, sorry, my bad. And we'll just put commas here to show you how it works. So you can see we have our 0, that's our starting number, our stop, which is 10, and our step, which is going to be 1. So I know you don't quite understand yet, but you will after I show you a few examples. So we have x is our variable, which is going to be holding the number of what iteration we are through. Now, iteration just means how many times we've already looped through this loop. Okay, so let's do an example here. All right, so we have x, and we've just started running this for loop. Now, right now, x is 0. We're going to print x, we're going to print 0 to the screen, and then we're going to add 1 to x. Now this time we come through the loop, we say, well, is x less than 10? Yes, it is. So now we're going to print x, x is 1, now we're adding 2. Okay, so now x is 2. Is 2 less than 10? Yes, 2 is less than 10, so let's print 2. Okay, and we keep going until eventually we print 9. Then x has 1 added to it, so it becomes 10. Well, 10 is not less than 10, so we're not going to print out 10. All right, I know I just talked a lot there, but let's see it in action. All right, so just like I said, we print out the numbers 0 through 9. Now, this may seem weird because I have the value 10 here, so you'd say, well, why doesn't it print out 10? It's because of the way the loop works. So like I said, really what's happening here is this. Plus equals 1. So pretty much this means we're just adding 1 to the variable x. You can also write it like this, x equals x plus 1, like that, all right? So we print out x, and then we add 1 to x. And we have to be less than 10 for this loop to run. So on the 9th iteration, we have, well, 9 is equal to 9 plus 1, so x is equal to 9 plus 1. We get the value 10. Now again, 10 is not less than 10, so we are not going to print out 10. Yeah, so that's pretty much how a for loop works. It's pretty basic. This is the syntax. We have for and then a variable name. So this doesn't have to be x. We could use anything we'd like to use. I could use hello. I could use any other word. It could be as long as I want, as short as I want. Doesn't matter. Then we have the word in, which is highlighted in orange, and then range. Now the range takes a different amount of arguments. Pretty much an argument is whatever's inside this brackets. So like at the beginning how I showed you, we just did 0 and 10. This means we have a start and we have a stop. So we start at 0 and we go to 10. Now I can actually put one argument in here like this, 10, and that just means that we just have a stop. So by default, Python will say, well, we're just going to start at 0 and we're going to step by 1. Now I haven't showed you the step yet, so we'll do that. So again, we're going to start at 0, we're going to stop at 10, and we're going to step this time by 2. Now what step is how much we add to x every time. So before I showed you we had x equals x plus 1. In this case, since the step is 2, it's going to be by 2, like that, okay? So let's go ahead, let's run this. We have 0, 2, 4, 6, 8, and you notice how we again do not print out 10 because 10 is not less than 10. Okay, again, we'll do another example with the step. Let's put 5 in this time. Now you can guess what's going to happen. 0, 5. It actually only prints out 2 things because we start at 0, so we print 0, and then we add 5, we get 5. Now 5 plus 5 again is not less than 10, so we are not going to print out 10. Okay, so that is the tutorial on the for loop. We're going to do another type of for loop where we're going to use something called a list a little bit later on, but right now we're just using this one. This is the basic one. I encourage you to play around with it yourself. And yeah, so if you liked the video, please go ahead and like it and subscribe, and I will see you again for another video. Thanks, goodbye. Hey guys, welcome back to the 7th video in my Python programming series. Today we're going to be talking about while loops. So in the last video we talked about for loops, and before that we talked a lot about conditions. So it's going to be important to understand those things before we can move on today to this video. So if you haven't seen those videos, go back on my channel and check those out first. Okay, so let's get right into it. Today we're going to be talking about while loops. So let's first of all just put an example down and get the syntax. Okay, so we have while condition, then we are going to do whatever is inside the loop. So it seems simple enough, but they can get fairly complex. So while condition is equal to true. So for example, this condition here, this could be a variable. While that is equal to true, then we're going to do whatever is inside of this loop. So again, we keep talking about conditions. They're very important in Python. We really need to understand them before we can move into more complex topics. Okay, so while condition is equal to true, we're going to do whatever's in this loop. So how does this really work? Well, pretty much what happens is we have the while loop here, we have the condition. So this is true, this means we're going to do this. Now what happens is we actually come back up to the top after we've done this and we say, well, is this condition still true? Well, yes, it is. So that means now we're going to do this again. And we just continuously do this until eventually the condition is equal to false, or we have a keyword appear called break, like this. Now I'll do an example so we can understand this, but this is just the basic syntax. We have while, we have a condition, and then we have a colon followed by an indented block, which will be whatever's going to run. Okay, so let's start off by using a variable. We're going to just call it loop. And we're going to set it equal to true. Now we're going to make our while loop. We're going to say while loop. Now, by just putting a loop here, it defaults to say while loop is equal to false. Putting loop there is the exact same thing as typing this. It's just shorter to put loop instead of doing the equals true. Okay, we're going to get some input from the console. So we're going to say name is equal to input. And then I'm just going to put in here insert something. Okay. And then we're going to put an if statement, which we talked about in another video. So if you haven't seen that, go back and check that out. I'm going to say if name is equal to stop. Then we are going to break out of the loop by typing break, or we could also do this. We could set the condition equal to false. So we set the variable up here equal to false. Now I know I just typed a lot there, so let's talk about what really is going to happen. So we have our condition. We say while loop is equal to true. Right now we set it equal to true up at the top, so it's going to automatically run at least once. Now we get input from the console and store it in the variable name. Now we have a basic if statement here that pretty much says if name is equal to stop, well then we're going to stop the loop and we're going to break out of it. Otherwise, we're going to keep asking the user to insert something until eventually they type stop. So let's see how this all works. Okay, so insert something, I say 1, 2, 3. It didn't like that, it wants me to insert something again, I say we. Okay, what about hello? Keeps going. Okay, now I'm going to type stop. And you see that the program stops running. Okay, so again, I'll show you that we can do this by just setting the variable equal to false. Same thing again, if I type hi, keeps going, I type stop, it's going to stop. And then maybe if we get rid of the variable here, we can also just type in the word break, like that. And same thing again, if I type in some random things and then I type stop, it stops. Okay, so pretty much the way that the break keyword works is by simply saying, okay, are we inside any loops right now? It checks whatever loop you're inside. So right now we're inside the while loop, and it says, okay, well this line has now run. So what we're going to do is we're going to get out of the loop. So it pretty much will now start reading from the next blank line in the file, meaning that it's going to get out of this loop and just continue going down the program. Okay, and that's pretty much it for while loops. We can talk a little bit more about why we would use a while loop instead of using a for loop. The reason we might use a while loop is for something like this. So for example, if you want to ask someone to insert a password, so we have password like this, and we'll just change this variable to password, so pass for short. And now maybe we wanted to check, we wanted to say, well, let's just do password, because pass is a keyword in Python, I forgot about that. Password. And we want to make sure that the password has, for example, at least one letter in it. Well, we're going to keep asking the user to re-input their password until it meets the certain criteria. So for example, it might have to have one capital, it might have to have one letter in it, it may have to have a few numbers, something like that, right? So we would keep asking the user for a password until they gave it to us correctly. Now the reason we wouldn't use a for loop for this is because a for loop, usually we know how long we want to run the for loop for. That's why we put a number in the range. So for example, we put 10 or we put 12. While as a while loop, we don't know how long we're going to run it for. So for example, someone could get the password first try, like they could put it in correctly with the right criteria, or it could take them 30 tries, right? We don't know how long it's going to take them. Okay, so that's it for today's video. If you like the video, please like it and subscribe, and I will see you again tomorrow with a new video. Hey guys, welcome back to the 8th video in my Python programming series. Today we're going to be talking about lists. Now lists can be fairly complex, but they are a very important part of Python and they are very important to understand. So a list is another data type. So before we talked about strings, integers, booleans, and floating decimal points, so floats. And today we're going to talk about lists. So lists again are their own data type. So let's just start off by doing an example right now. So pretty much a list, which is denoted by the square brackets here, is a collection of different data types. It could be the same data types or it can be different data types. So for an example, I'm going to put a apple in here in my list. I'm going to put a comma and I'm going to add another item. So maybe we'll put a pear and then maybe we'll put a number as well. Okay, so we have the list fruits. And in the list, we have 3 items. Now, everything here separated by a comma is known as an item. So for an example, our apple is an item, our pear is an item, and the integer 3 is an item. Now, you can see that they're all different data types, or sorry, there is different data types. We have 2 strings and we have 1 integer value. Now, this is fine. You can store different data types in one list. Okay, so now let's just print the list to the console so we can see what it looks like. Print it out, and you'll see we simply get exactly what we've typed into the IDLE. So we get apple, pear, and 3. Now, if we want to access an individual item in the list, we need to do something a little different. So right now we just printed out the whole list, but say we want to just print out pear. Now what we're going to do is we're going to use the square brackets. So we're going to do the list name, so fruits, and then we're going to put square brackets right beside it, no spaces, and then inside of the square brackets we're going to type in what's known as the indice of that item. So the way indices work in Python is when you create a list, everything is automatically assigned an indice. So in this list we have indices 0 through 2. Now it may seem weird that we start at 0 instead of 1, but that's just the way that computers count and the way that they work. So we have to understand that apple is going to be assigned the integer value of 0, so the indice 0, meaning I would put 0 in here if I wanted to access apple, because that's the first element in our list. And then we have pear, so that's the second element or item. Now that's actually going to be represented by 1 here. So fruits 1 will give us the value of pear, and then fruits 2 will give us the value of 3. Now this is sometimes difficult for some people to understand, but just really try to remember that the first item always is 0. So if you would like to access the second item in your list, you're going to type in 1 into the indice thing here. Okay, so I'm just going to run this and show you how this works. And you see we get pear. Okay, that's because we have the first indice, which represents the second item, which is pear. Okay, now there's some other things we can do with lists as well. So if we want to add something to our list, there's a few ways that we can do it. The first way, which is the only one I'm going to show you right now, is probably the easiest, and simply what we're going to type is fruits followed by the dot. So a dot, a period, and then we're going to type append. Okay, now this means to add to the end of the list. So inside of append, I'm going to put the element or the item that I'd like to add. So say we want to add another fruit. Let's think of another fruit that we could add, maybe a strawberry. Okay, we want to add strawberry into the list. I'm just going to get rid of 3 so it makes more sense. Okay, so right now in our list up here, we have fruits, which is a variable name containing the list that has apple and pear. Now we want to add strawberry to the list. So let's start off by printing the list before we add it. So we'll print off fruits, and then we're going to print fruits one more time after we add this item to the list. And you see we have the first list, which is what we defined originally, and then when we added or appended strawberry to the end of it, it added it in just like this. So that is a way that we are able to add things into a list by using .append. Now there is another way, it's known as the slice operator using something called insert, but we're not going to do that right now. We're going to talk about the slice operator in a later tutorial, so stay tuned for that. Okay, so fruits.append, we've added strawberry. Now if we wanted to add another item, we could do the same thing, and we could do append again, and we could put in another fruit. Maybe we want to put in a blueberry. Okay, just like that. And again, we'll see that it does the same thing. We have apple, pear, and then apple, pear, strawberry, blueberry. Okay. Alright, so that's it for adding to the list. Now, what about changing something in our list? So let's just add right here at the beginning, we'll put in strawberry. So we have 3 items, and now let's say we want to change the middle item in our list to a different fruit. Say we don't like pears, we want to remove it, we want to change that. So what we're going to do is we're simply going to type the name again, so fruits, followed by the square brackets, and then the indice of the item you want to change. So again, remember, if we want to change pear, we're going to use the indice 1, not 2, because this is the way that it works. We're going to use 1, and then we're going to change it to whatever we'd like to change it to. So say I want to change it to blueberry, I can do that like so. And then again, we can print out fruits, and we'll see if it works. Okay, so we get apple, blueberry, and strawberry. That's because we've changed the item at indice 1 into blueberry, and we've replaced that. We replaced pear with blueberry, pretty much. Okay, so that's how that works for list, for changing items. Again, lists are very useful for storing large amounts of information. So this is a very small list, but in many programs we use something called multi-dimensional lists, which I'm going to talk about again in another tutorial. And yeah, so one more thing before we end it here. There's another data type called a tuple. So a tuple, it's kind of a hard word to pronounce, but it's used for coordinates, and it's also used for things like colors and rectangles. It can also be used just to hold information as well, but it's a different type of data type than a list, so we're going to talk about it quickly. Okay, so a tuple pretty much looks like this. So if we set a position, and we set it equal to something like this, not in square brackets, in the regular round brackets, and then we simply put the items in like this. Now we see we get it looks very similar to a list, the way that it works. Again, we can use different data types, so I could put something like hello in here as well, but it does function a little differently. And again, things like colors we would also store in a tuple, so we would use like 255, 255, 255. That's simply white in red, green, blue colors. And again, if we print out the type of the color, you can see that we get a class tuple. Okay, so I'm not going to go too in depth with the tuples here. I just wanted you to understand what they are, because we may be using them in some later tutorials. Okay, so I hope you learned how to use lists and a little bit about tuples today. They're going to be important in the next tutorial. So yeah, I hope you enjoyed. If you did, please like and subscribe, and I will see you in the next video. Hey guys, welcome back. Today we're doing the 9th video in my Python programming series, and today we're going to be talking more more about for loops, so a more advanced type of for loop in terms of iterating through a list. So you may remember a few videos ago we talked about for loops, and I mentioned that there are two main type of for loops that we can use, and the one that we talked about there looked like this. So we had for x in range, and then we had a range like this, and we simply printed out the numbers like this. So we see we got 1 to 10 just like that. Okay. So that was the for loop we talked about there, but the one we're going to be doing today is a little bit different. So I'll leave this here for an example. So the first thing we need to do is we need to make a list, because we're actually going to be iterating through every item or every element in the list. So again, I'm just going to use the same example I used in the other video, fruits, and I'm going to make it equal to, we're going to have apples, pears, and strawberries, just like that. Okay, so we have our fruits here, and now we're going to get right into the syntax for this new for loop. So we're going to do for, and then any variable name we'd like. So in this case, I'm going to use fruit, and then we're going to use the keyword in once again, and then instead of typing range this time, we're going to type the name of the list we want to iterate through. So in this case, it's going to be called fruits, just like that. And now we can print out the fruit, just like that. So pretty much what is going to happen is we have a list with 3 items in it. We have apples, pears, and strawberries. Now we want to print every fruit in that list. So we do that by saying for fruit, in fruits, meaning for every item in fruits, so 1, 2, and 3 items, we simply want to print out that fruit. So this loop is going to run 3 times, and we're just going to print out every fruit inside of the list, just like this. And there you go. We have apples, pears, and strawberries, just like that. So yeah, that's pretty much how you can iterate through a list. And same thing, if I want to add more elements to the list, so at 8, 90, just like that. Again, it'll just simply print out all of the items in the list. Now, why might we do this, you say? Well, there's a few reasons we may want to iterate by item rather than by indice. So the other one, the in range, is known as iterating by indice or by index. Well, this one is known as iterating by item. So there's a few reasons we might want to do this, but the first one is if we only want to print something out if it's a certain value. So we just want to check through all of the items in the list and see if they're a certain value, and if they are, then we're going to print it out, or we're going to do something specific to that item. So in this case, I'm going to say if fruit is equal to, for example, pears, then I want to print out pears. So we'll just print out the fruit. But if it's not equal to pears, so anything else, then I will print out not pears, like that. So this is an example of how we can look through every item in the list and simply check if it is a certain value, and then if it is, we're going to print it to the screen. So we'll try this, and we see we have not pears, pears, and then followed by a few more not pears. So that's a good way to do it, by item. Otherwise, we can still do this using indice. It's just a little more complicated, or not as efficient. So we could do for x in range, and then in this case we'll do 0 and 6, because we have to do it 6 times, because there's 6 items in the list. And then we'll put a colon, and then we'll say the same thing. So except this time we're going to say if fruits followed by the square brackets, and then x, because this is going to be our indice, equals pears, then we want to print fruit, or fruit x. Oops. Otherwise, we'll print not a pear, just like we did in the other loop, not a pear. Okay, so we'll run that. And we see we get it twice just because I had 2 for loops there. So it does work the exact same way, except you can see that This one takes longer to write because we actually have to put the list name followed by the square brackets, whereas in this loop, all we have to do is simply type in fruit because it's automatically going through the list. Another reason too we may want to do that is because in this case, we had to actually see how many items were in the list by counting. And then we had to put that number in, whereas here it'll just stop at the end of the list automatically. Now we could do this, so len, this is a new word, so I'm just showing this now. This means length, and then inside we can put something like a string or a list. So in this case I'm going to put the length of fruits, and that would give us a value of 6, and you'll see if I just get rid of this, that it'll work the same way again by using the length of fruits. Okay, so that is how to iterate through a list by item. I hope you enjoyed. If you did, please leave a like and subscribe, and stay tuned for more videos in this series. Hey guys, welcome back. Today we're going to be doing the 10th video in my Python programming series, and today we're going to be talking about string methods. So a method is simply something you can call on a string by using the delimiter of a period followed by whatever the method is and then brackets like this. Now sometimes we have to put some things inside of the brackets, but most of the time we can just leave them with empty brackets. Okay, so let's get right into an example. We're going to start by talking about the dot strip method. Now what this one does is it pretty much removes all of the leading and trailing white spaces from a word, or from a string, sorry. So we'll start by just making a variable, and we'll make it equal to the input from the console, and we'll just say input something like that. And then we're just going to print out our input. So print out text dot strip. Okay, so again, what strip does is just going to remove all the white spaces before and after the word, and it's best to show you with an example. So you can see if we type a few spaces, so 1, 2, 3, 4, and then I type hello, and then a few more spaces, and I click enter, it simply gives us hello. That's because it had removed all of the spaces from the string. While as if I don't have the dot strip here, so if I get rid of that and we run it and I do some spaces again and I type hello and some more spaces, it's going to give us those spaces as a part of the string. And most of the time, so when we have a string, we want to remove these spaces, so that's why we use dot strip. Did I spell that right? Strip. Yeah, just like that, okay? Alright, so that one's pretty straightforward, just removes these spaces. Now you may want to do this if you're checking if a string is equal to a certain thing and you're getting a user input and they may have accidentally typed a space before or after the word, right? Okay, so now we'll move on to the len. So this one is actually not a method because you don't call it using a dot, using a period followed by the word. It's actually known as a function, which I'll get into later. So this just means that it takes something inside of the brackets. So this stands for length, len, and pretty much what it does is returns the length of a string or of a list. So right now we're going to use a string and we're going to put text in here, and I'll show you again what it does. 1, 2, 3, 4, 5. Remember, although this is a number, since I'm typing it in the console, it actually gives me a string value, so this will work. And it says that the length of this is 5. Again, that one's pretty useful. I used it in the last video to determine how many times we had to iterate through a list because we got the length of the list. Alright, now for dot lower. So pretty much what dot lower does is it turns everything into lower cases in our word. So again, it's best to just show using an example. If I type something like this, with a few lower cases, a few capitals, and I click enter, you see we get everything in lowercase letters. Alright, and now for dot upper, you can probably guess what this one's going to do. It's the exact same thing, except in this case, everything is going to uppercase. So, like this, and you see we get all uppercase letters. Alright, And now for the last string method that I'm going to talk about. Although there is tons of different string methods, there's probably over 40 or 50. I'm going to leave the link down below to all of the string methods on the Python website, so you can go check them out if you'd like to see some more. So this one is called .split. Now this one I'd say is probably one of the most useful methods that I use all the time, and what it does is it actually creates a list out of the string that you give it. So inside of these brackets, you're going to put what's called a delimiter. And what a delimiter is pretty much what you want to split by. So for example, I'm going to put a period in here just so we can get an example. So we have text.split, and inside of the brackets for .split, we have a period. So it's best to just show an example. Oh, invalid syntax. I think I have one too many brackets there. Yes, I do. Okay, so we'll run it. So I input something. I'm going to type hello.tim.by.hi. Just a few random words, and you can see they're all separated by a period or by a dot. Now when I click enter, you see we actually get a list with all of the words, and you notice that we don't actually have a period in this list. That's because the way that .split works is it gets rid of the delimiter. So since the delimiter was a period, it's not going to include the period in this list. Now this may be kind of confusing. We'll do a few more examples to hopefully you can understand. So usually what you do is you would leave these brackets blank, so you wouldn't put anything in them. And by default, Python's going to say, okay, well I guess you want to delimit by a space. So the way that we can do this, again, what will happen is if I type a sentence like, my name is Tim, and I click enter, you see it separates by spaces, and we have no spaces in our list because it removes those spaces. Now you could also delimit by anything you like, so I could do an A, for example. Now if I click F5, and we just type a bunch of letters, and I put an A, and then another A, you see we get the letters, and again there's a space at the end because I typed a space, right? So yeah, okay, so that's how .split works. Now .split's very useful if you want to do certain things with a list. We're going to talk a bit more about it later on, but those are just some basic string methods that we talked about today. Again, there are tons more on the Python website, which I will link down below. If you liked the video, please like and subscribe, and I will see you again later. Hey guys, welcome back to the 11th video in my Python programming series. In today's video, we're going to be talking about the slice operator, which is a cool thing that we can use on lists and strings in Python. So if you remember in the previous video, if we wanted to access an element in our list, we did fruits, so the name of our list here, which I've already got defined as apples, pear, and strawberry, and then we would do the item. So for example, fruits1, and we can print that to the screen. Just to remind us what this did. And we got pear, just like that, because that is the second item, but to reference that we have to use 1, because in computers we start at 0, right? Okay, yeah, and I just wanted to mention, I don't think I did this in the list video, that you can actually do this on strings as well. So say I wanted to access the E there, I would just do text1, and we get the E, because that is the second item in this string, or character. Maybe I wanted to do the 11th one. Then that would give us another E because 11 is right here at the end of like. So yeah. Now what does the slice operator look like? So pretty much the slice operator is these two square brackets, but inside of them you're going to put 2 colons, just like this. Now these colons, in between them we type some words. Or we're going to put some numbers, but in this case I'm just going to show you with words. So we have start, stop, and step. That's what goes where these colons are. Now if I remove this colon, that means I just have a start and a stop, and then if I remove this colon, I just have a start, and that's how we reference what element we want to print out, right? If we had just put a number there. So we'll add the colon back in, and now we're going to use numbers. So the start, stop, and step works exactly the same way as the range function. So you may remember when I did a for loop, we did for x in range. And then inside of the range we did some numbers like this. So we would start at 1, stop at 2, and step by 3 like that, right? So it works the exact same way, except in this case we're going to be using it on lists and on strings, right, without these numbers of the range like this. Okay, so let's just do an example. So let's start at 0 and let's end at this O. So the O is 1, 2, 3, 4, 5. But if I want to actually include the O, I have to put 5 because remember 5 would be this space here. And if we stop on, so let's say 4 here, you'll see what's going to happen. It's not going to print out the O because when we stop, we do not include that number, remember, from the range function. So if we want to have the O, we'll stop at 5, just like that. Hello. Okay, yeah. Now, if we wanted to start just from the beginning, say we didn't know, all we have to do is just put nothing there, and it's going to default start from the beginning, so it'll give us the same thing. And then if we wanted to start from somewhere, so say we want to start at 2, and we just want to go all the way to the end. Now, we don't know how long our string is. We don't want to count all of these things and say, oh, well, let's stop at 17 or whatever number it may be. By just leaving this blank, it'll actually default to stop at the end of the string, and you'll see that. So we get LLO, I like Python, right? It stopped at the end of the string automatically. Okay, so now let's talk about the step feature. So if we want to start at the beginning and we want to stop at the end, we'll just put nothing in between these two colons because it's going to default from the beginning and default to the end. But now we want to skip every other letter. That means we're going to put a 2 here for the step. So that way we're going to get H, L, O, then we're going to skip the space here, we're going to get I, skip the space, get L, and so on. So I'll show you. And you see we get that, a bunch of gibberish like this. Maybe we want to go every third letter. That means we would step by 3 like this. And there we go, we get a few less letters. And same thing, we could do 4, 5, and continually going. Now say we want to start at the third letter, or the fourth, because we're typing 3 here, so L. We want to stop at the end and we want to step by 3, then you can see what's going to happen there. So we get L, I, T, N, right? So a bunch of gibberish. Okay, now this works again, same thing for fruits. I don't have as many items in the fruits list, so that's why I was showing you with text. But if I put the colon in here and we put another colon, let's say we start at 1, so that means we're going to start at pear. And let's just go to the end, and we'll print that out. And again, we get pear and strawberry, so we didn't include the apples because we started at pear, right? So yeah, that's pretty much how the slice operator works. Now there is one other cool thing we can do with the slice operator, and it's called the insert function, or the insert kind of thing with the slice operator. So if you remember, when we wanted to add something to a list, we used .append, right? So I showed you that in my list video. We did fruits.append, and then maybe we want to add blueberries like this. I know that's spelled incorrectly, but there we go. We'll fix that quickly. Blueberries. Okay. And then we can print out fruits once again just to see what it looks like. So if you remember, this just adds it to the end of the list. But say we don't want to add blueberries to the end of the list. We want to add it in between pears. We want to add it in between apples and pear. We want to add it at the beginning. We want to add it somewhere else, right? How would we do that? Well, we can use the slice operator to do that. So instead of using the .append, we'll use the slice operator. So we'll go like this. And this time, we're going to just put 1 colon and then type the indice where we want to insert it. So if we want to insert it at the beginning, we're just going to type 0 and then 0 like this. We do need to do them on both sides. And then an equal sign, and we'll set it equal to whatever we want. In this case, we'll just put B for simplicity. And you'll see we get B at the beginning of our list. Now say we want it in between apples and pear. Well, in that case, we would put 1, and we would put 1 again like this. And we get apples, comma B, comma pear, comma strawberries, just like that. Now, if we want to add it to the end, we would have to find out what number that is. So we do 3, 3. I believe that should work. We'll see. Yeah, so that adds it to the end for us. And then if we want to insert it in between pear and strawberry, we would do 2, 2, like that. And there we go, we get it in between there. So that's how the insert works for the slice operator. I hope you learned how to use the slice operator today. We will be using it a little later in some other videos and doing some more complex things with it. If you liked the video, please like and subscribe, and I will see you again in the next one. Hey guys, welcome back to another video. This is the 12th video in my Python programming series, and today we're going to be talking about functions. So this is a function up here. We're going to talk more about the syntax and what a function does, but it's first important to understand what is a function. Well, if you're in math, you know that a function, pretty much you pass an x value and then it does something to that x value and you get a y value back. Well, it's a similar idea here in Python, except there's different types of functions that can do different things. So the first function I've just written right here, pretty much I've named it add2, and what happens is we give it an x value, and then it simply returns x plus 2. Now this doesn't have to make sense to you right now, I just want to show an example of what a function looks like. So if we wanted to make our own function, what we would type is we'd type def, this stands for definition, and then the function name. So maybe in this case I want to do another math related function, so I'll do subtract 2, and 2 as a word, and then I'm going to put two brackets, and inside of the brackets we're going to put something that's called a parameter. So in this case I can name it anything I want. I'm going to put number in here, and then I'm going to do a colon, click enter. It should tab me in one space, and I'm simply going to return number minus 2. Now I'll talk about what all this really does a little bit later, but I just want to give some examples. So now if we want to call our function, or we want to actually use these functions, we have to do something. We can't just leave it like this. I'll show you if I run this right now, nothing's going to happen. What we actually have to do is we have to do a call statement. So what I can do is I can do add2, and then in here we have a parameter x. But what's actually going to happen is I have to give add2 a number, because we're going to add 2 to that number and it's going to be returned. So let's say 7. Now you'll see what's going to happen here. I'll run it quickly, and nothing prints out to the screen. That's simply because we haven't printed anything. What actually happens is in this add2 call statement, we have it sets x equal to 7, so it comes up here and it says, okay, we're going to add 2 to 7. So we have x here, we add 2, and then we're going to return that back down here. So pretty much we call this function and it returns it right here. Now I have to set this equal to a variable or simply print it out to the screen. So I'll set it equal to a variable right now. So I'll say new number is equal to add2 7. And now if I print out new number like this, we get 9. Okay, so that's how that works. Alright, now what about subtract 2? So we can do the same thing here with 7. So we do subtract 2. We'll leave 7 in here for number, and you'll see we get 5. So that works correctly. Now I can do it again. I could do 12, and we get 10. And maybe I could even change what I want to do in these functions. So this one's called add2, but maybe I wanted to add 2 to x, and then I wanted to square it. So then I would do that. And then if we go back to the add2, so I'm going to put 12 plus 2 squared, which should be 14 squared, which will be a pretty big number, which will give us 196, just like that. So you can kind of see and understand how these functions are working. They have a parameter. This is what that's called up here. So a variable name, I could do x, I could do y, I could do z, doesn't matter. I can do any letter I want, any name I want. It makes sense to call it something that makes sense in terms of the function. So here x works fine, but if I was doing a string, so maybe we want to write another function. Let's do another function here, and we'll do define, and we'll say print string. And now inside of here, I'm just going to put string like that as our parameter name, and then we're simply just going to print the string to the screen. So now what actually happens is instead of setting something equal to a variable, all I have to do is I have to do print string. This is my call statement, and then in here I'm going to give it a string, so I'm just going to type hello, and you'll see if we run the function we get hello, and we didn't print it down here, we just printed it from the function. So I know I've gone kind of fast, but the easiest way to understand the functions are to show examples of them and how they're working. Pretty much there's a parameter. I'm going to give the parameter, I'm in the argument of the call statement. So This, in the definition of the function, is called a parameter, and in the call statement in between the brackets, it's called an argument. So those are just some keywords. Now I can actually use these functions as many times as I want. So I can print string again, and I could print my name is Tim, just like that, and you'll see it should do it twice. Yeah, there we go. So that's why these functions are extremely useful. Because say, for example, I'm writing a big program, and I know that I would need to do a certain thing multiple times. Well, I don't want to have to constantly write it out in the main line of my program here, when I can just have a function that's going to do it for me, and all I have to do is call that function using a simple call statement like this. So we haven't really done many big programs yet where functions make sense, but you'll see when you start programming that you're going to be using a lot of functions to do things, because you're going to be repeating code. Now these are very basic functions. We have subtract to, add to, but you can have like physics functions, for example. If I know I need to find the acceleration of an object, then maybe I would make another function here, and I do define accel. I'll just do it like that, short form, and then I'll put in mass and the force like that. So you see I can actually have more than one parameter. I can have two parameters here, and I'm going to say A is equal to mass times force. I know that's not correct, but we could do something like that, mass times force. And then I could return the variable A. And now if I called my accel function and I printed that to the screen, well, that would give me what the acceleration would be, right? So those are just some examples of why functions are extremely useful. Well, you're going to talk more about functions. I'll do a more advanced tutorial a little later on, but this is just an introduction so that you can hopefully understand how they work. Pretty much you have, if you're writing a function, you have the def keyword, you have the function name, so this case it's highlighted in blue, so I did add to. Then you have brackets, and say, for example, when we did a function, we can actually do one without a parameter. So I could do define do something, and in here I could simply print hi, right? I don't need to have any parameters. That just means when I call this function, so do something, I don't put anything inside of the brackets, right? We just do this, and we see hi, hello, my name is Tim, right? So yeah, it doesn't have to have parameters. It can have multiple parameters. If, for example, in this acceleration function, you have multiple parameters, that means that when you call the function, so I'll do an example here, then you're going to have to put two numbers in, or two strings. So I do 2, 5, like that. And we'll print this to the screen because we don't print it in that function, so we can see what we're getting. So yeah, we get hi, hello, my name is Tim, and then 10, right? So acceleration 2, 5, okay? So yeah, that's just the basics of functions. We're going to talk more about them more in depth later, but just try to understand how they work. And yeah, so if you liked the video, please like and subscribe, and I will see you again later. Hey guys, welcome back. This is the 13th video in my Python programming series, and today we're going to be talking about reading from a file, so specifically a text file, and we're going to be using something called file.io in Python. So the first thing we need to do before we can read from a file is we need to create a file. So I'm just simply going to go and find the directory where my Python tutorials are. So, oops, not here. They are right here in the tutorials folder. And now you see I've got all my Python scripts right here, and all I'm going to do is I'm going to right click and I'm going to click new, and then I'm going to find text document like that. Now I can name it whatever I like. I'm just going to name it file for right now, file.text. Now you may want to populate the text document, so put some words in here. So I'm just going to put a bunch of different words. Hello, Tim, Python, learning, easy, just some random words in my text file. I'm going to save that, and now we can go to reading in the text file. So it is important that when you make the text file, you do have to save it in the same directory as your Python script. So if I were to put the text file here on my desktop, and I have my Python script in the tutorials folder here, it's not going to be able to find the file properly. You would have to do something which is a path joining, which I'm not going to talk about in this video, but maybe in a later one. So make sure that you save your file in the same directory and same folder as where your script is. Okay, so now that we've done that, we're going to read from the file. So the first thing we need to do is we need to create a variable. So we're going to name this file. You can name it whatever you'd like, and you're going to set it equal to the keyword open. And then inside of open, all you're going to do is you're going to type the name of your file, so file.txt, a comma, and then the mode you want to open your file in. So in this case, we want to read it, so we're simply going to put a lowercase r inside of the quotations, just like that. And now that's pretty simple. That's all you have to do in Python to open up the file and to prepare to read it. Now, make sure you do put R in here. If you put nothing, or you put a W, for example, which would be write mode, it's actually going to clear the whole file, which you don't want to happen. You want to leave the contents of the file in there, right? So we need to open it in read mode with this R. That's very important. Now what we're going to do is we're simply going to read all of the things from the file. So we've opened the file. Now we need to read it. So in order to read the file, we have to type a few things. So we can do it in multiple different ways. The first way I'm going to show you is this. So I'm going to make another variable. I'm going to call it f. And this one, we're going to make it equal to file.readLines, like this. Okay? And then we can simply print out f just to show you what's going to happen. You see we get all of the words that are in the file. Now there's an interesting thing here. You may notice that there's a \n attached to all of the words except for the last one. That's because I'm going to open up the text file again and show you. You notice here I didn't actually type \n, but every time we click enter like this, it actually creates something called an escape character, which is that \n. So if we want to read in the file, we're going to have to remove that character afterwards, right? So it's just something to keep in mind that if you have things on different lines, each of the end of the lines is going to have a \n on that line that you don't actually see here in the text document, but Python will read that in. Okay, so we don't need to save that. Yeah, so let's move into the second way to read it properly now. So we have f equals file.readLines. Now we want to remove all of these backslashes, get rid of these ends from our lines. So there's a way we have to do that, and it's by using a for loop. So we're going to do a for loop. I'm just going to say for line in f, because now f has read all of our lines. So we're going to do what's called iterating by item, if you remember from my other videos. So each line, so every item in this f list here that just created by file.readLines, we're going to remove that character and we're going to create a new list. So let's make a new list. We'll call it new list. Just make it a blank list like this, new list. And then here we're going to say, what is it? New list dot append, and if you remember what append does, that simply means add to the end of this new list. And then we're going to add the line, and we're going to use the slice operator to remove that \n. So we're going to simply do the colon and then -1. Now what this does is it will take all of line except for the last character. So -1, I didn't talk about this in the other video, but -1 pretty much just goes to the last character, but does not include the last character when you do -1 like this. So just follow along for now. You don't have to completely understand it, but just put that -1. And now if I print out new list, we'll see what we get. New list, F5, and you see we get rid of all of the \ns. Now we have one issue here. Down here on ease, it should say easy, but we've actually removed the last \n from that string. So if we don't want to do that, now we need to actually add an if statement into our for loop. So inside of the for loop, we're going to type if, and then we'll say line, and we'll put a -1 again to represent the last character in that line, equals \n. And then we'll simply tab this in, because remember, everything in Python needs to be indented properly for it to be read. And now we'll try this and we'll see if this works. And there we go. So we get hello, Tim, Python, and learning. But now we've forgotten one thing. We haven't actually included easy. So now we need to do an else statement. So we have else, and then we'll do new list dot append, and we'll simply append the line just like that. And now we can print it out and we'll see what happens. and we get hello, Tim, Python, learning, and easy. Now there is an easier way to do this. I just wanted to show this example because you may want to do something where you're checking through all of the lines and you want to see if the last character or maybe the first character is equal to a certain item. And depending on what that string is or depending on what it is, you may want to add it to a new list. You may want to do something to it. So I just want to show you a way that we can do that. Pretty much this is iterating through every line in the file. So file here, so F creates a list of every line, and then we go through every line of it, and we see, we say if the end of it has this \n, then we're going to remove the \n. Otherwise, we'll just add that line into our list, right? Okay, so now the easier way that we can do this is actually with something that's called the strip string method. So in my other video, I talked about this strip method that removes the spaces. But what we can actually do with this is we can remove, we can remove the \n with the strip method as well. So all we have to do here now, it's a lot simpler, is to do a new list dot append, and then inside of here, we're simply going to type line dot strip. And now this will automatically remove those \n's, and we'll see if this works. There we go. So we get everything, and you can see it's a lot simpler, and we don't even have to do the if statement for the easy, like that. So that pretty much is how you read a file in using Python. There are some other ways to do this, but this is the most basic and easiest way to understand. We've also talked about how to remove that, it's called an escape character at the end of the string, that \n. And in the next video, we're going to talk about writing to a file. I hope you learned something. If you did, please like and subscribe, and I will see you again in another video. Hey guys, and welcome back. Today this is the 14th video in my Python programming series, and we are going to be talking about writing to a file. So in the last video we talked about reading from a file, and now we are going to be writing to it. So the first thing we need to do is create a file. So we already have a file created here called file.txt. I did that in the last video, and inside we have nothing. So I'm just going to put the word hello in here so that we can test something out later. Okay, now it is again important that you have this file in the same directory as your script. So tutorial 14, which is the script I'm using right now, is in the same directory. That's important, otherwise Python will not be able to read that file properly. Okay, so now we're going to do the same thing we did in the last video. We're going to do file is equal to open the file name, so in this case file.txt. Oops, that has to be the lowercase, my bad. File.txt, and the mode. So in the last one we used R, but in this case we're going to use W, and that stands for write. Now there's one thing we need to do which I forgot to do in the last video, and that is close the file. So we do need to actually close the file so that it saves our changes, which I forgot to do in the last video, and it's very important that we do that. So my apologies, but here we go, file.close. And again, if we had changed this name to anything else, then we would do that name.close because the file is contained in the variable file, like that. Okay, so now we want to write to the file. So all we have to do is type the variable name, so file, and then .write, which is very simple. And inside here, I'll put a new word. I'm going to put Python, like that. Now before we run it, let's notice what is inside of our file.txt. So in here, we have the word hello. Now I'm going to run the script. And nothing happens here, obviously, because we just wrote to the file. But when we open the file again, you see now it says Python. Now what actually happened was we removed the word that was in there before, so hello, and we overwrote it with Python. So what happens in this mode here, W, is it actually clears the entire file, and then it writes what you want to write to it. So if you have this W here, it is going to clear the entire file. Now there's a way to get around this, but I'm not going to be showing that in this video today. Okay, so let's write something else to our file. So file.write, and then I am learning how to write to a file, just like that. And again, we'll run the script, and we'll open the text file. And you see we get everything here on the same line. So that's okay, but you may want this to be on different lines. So how would we do that? Well, if you remember from the last video, there was something called an escape character that we got when we read in the file. We had that little \n attached. Now that's the same thing we need to do when we're writing to the file if we want things to go on a different line. So on this line here, I'm going to type the backslash and then the n. And now what's going to happen is it's going to have this escape character, which is going to tell Python we need to move to the next line. And then it is going to type this right here. So we can show what's going to happen here. We go F5. And then if we open up the file once again, you see Python, and then I am learning how to write to a file. So that happened again because we use that backslash n, the escape character. Now same thing, we could use this in between a line. So if we want to write a large thing and we want it on different lines, then we can put the escape character in there like that. Same thing, open the file again and we'll see what happens. And we see we get it on a different line. So that's how you can write things to a different line. Now this has been a pretty short video today, but that's really all it is to writing something to a file in Python. Now in the next video I'm going to show how we can write and read to a file at the same time, so that would involve not wiping the entire file when we open it. But if you learned something today, please like and subscribe, and I will see you again in another video. Hey guys, and welcome back. Today this is the 15th video in my Python programming series, and we are going to be talking about some more methods that we can use on strings and on lists. These methods are, I'm going to put them in a comment so that I remember, is the .find and the .count method. And now these can be used on strings and on lists. So let's go right ahead and give an example. So the .find method, this is a very useful method in Python. It's not in a lot of other languages, so it is specific to Python. So what we can do is we're going to make a variable, we're going to call it string. Now we can set this equal to whatever we want. So let's just say hello for this case for simplicity. And then we're simply going to print string, oops if I spelt it correctly, string .find, and then inside of the .find brackets here, so the argument for this method, we are going to put in what we want to find. So we want to see if we can find the indice of any of these letters here. So if I put in L, you'll see what happens is I get 2. And that's because there's an L, the first L in the string is found at the indice of 2, just like that. Now you may be confused right now, I haven't completely explained it, but that's fine. So as you can see, we have 2 L's in the string, right? Now when I put in this L in the brackets, it gives me a value of 2. Now that is where the first L is found in the string. If I put in O, for example, you'll see it gives me 4. And there's only one O in the string, so it gives me the value of where that O is, which is the 4th indice of the string, the 4th index. If I put in H, you see we get 0. And now notice what happens if I put in a number or a letter that's not actually in the string. So I'll put in 7, for example, the string 7. And you see we actually get -1. That's because if Python does not find that inside of the string, it's going to tell you that it's -1. So rather than 0, it gives you -1. Just like that. So this is useful because maybe we want to check in a password, for example, if it contains a certain element. So maybe if there's a dash in there, we don't want them to be able to use that password. Or maybe we're not allowing a certain character, or we need a certain character to be in a password or a string. This is where .find is useful, and it'll tell us if that's in the string or not. Now there's actually another useful string method here that is .count. Now it does a similar thing, except instead of finding the index of the letter, it counts how many of them there are in the string. So now we're going to go to .count. So we'll go .count like this. And again, inside of the brackets, we're just going to put a string. So let's do L. And you see if we F5 here, we get the value of 2. That's because obviously there are 2 L's in our string. Now I'm just going to type a bunch of random letters and show you that this does work for all kinds of things. So if I type in A, for example, we'll see how many A's I typed. We have 6 A's in that string. Now let's try a Z. I know I didn't use Z here, I'm pretty sure at least. Oops, that's my bad. We've forgotten a parentheses there. Sorry. Okay. And we get 0, right? So instead of -1, it counts and it says, well, there are 0 of them in the string, so we're going to return 0. Again, we can use this to find if there's a certain character in the string. So if we say you can only have a maximum of 3 numbers in your string, well, we could count and we could say if there whatever, how many numbers, right? The dot find is different than this because it actually tells us where that is. So if I do dot find again, and now maybe I put in an A. Well, we know there's 6 A's in the string, but which A is this one going to give us? So it says 5 because that is the first place that an A occurred in the string. So we see here at the 5th indice or index, that's where the first A is. It's not going to give us the A's from back here. If we wanted to find the A's back here, we would have to use a for loop, and we'd have to loop through the string in different parts of the string to find where all the A's were. Again, yeah, so that's how you use .find and .count. It's very useful if you want to check certain things. So I'll show you an example here. If we wanted to check a string, how we would use the .count method or the .find method. So I'm going to say if string .count, and I don't want to allow any, let's say, underscores in my string, is greater than 0. So that just means if it's, I guess we could also say not equal to 0. So if it contains at least one of these underscores, then we're not going to allow it. So we're going to print to the screen not good, just like that, okay, just to show how this works. Now here, instead of actually having a preset string, we're just going to get input from the console, so we can do this a few times and see. So input will say please type something as the prompt, like that. And otherwise, so an else statement here, if it doesn't contain any underscores, we will print good, like that. Okay, so now I'm gonna type hello. That was our first string, and oh, what happened there? Good, so we get good. Sorry, I don't know, something glitched in the program there. We'll rerun it. I'm not sure what happened there. F5, please type something. I type hello. There we go. Now we get good. I'm not sure what happened in the other one. Okay, so now let's do it again, and this time we're going to include an underscore. So we'll do underscore underscore hello. It's going to say not good because it counted these underscores and said, well, there is more than 0 underscores, so it's not good. And then same thing if we put an underscore in the middle of the word, or we put a ton of underscores, so H-E-L-O, whatever, just like that. Not good because there's underscores in the word, just like that. And yeah, that's pretty much how the .find and the .count methods work. There's a ton of uses for these, and it's really useful that they have this method, because in a lot of other programming languages, they don't have this .count and .find, so it makes it a lot harder if you're trying to find how many things are in a string, or if you're trying to find the index of a letter. So I hope you learned something. I hope you enjoyed. If you did, please like and subscribe, and I will see you again tomorrow for another video. Hey guys, welcome back. This is the 16th video in my Python programming series, and today we're going to be talking about Python modules and import statements. So this is something new that I haven't talked about yet, but Python is a modular programming language, meaning that we can use multiple files together to create one program, and you'll understand what I mean later in the video when I show some examples. But yeah, so pretty much in Python, at the beginning of all your Python scripts, what you typically do is you write something like this. It says import, and you can see this highlights in orangey yellow, meaning that it is a keyword in Python. Now there are many built-in modules, or what they called, in Python that contain a list of functions and classes that we can use in our Python script. So for example, the math module, import math. This allows me to do things like .square root, or the square root function, which I believe is like this, and then you can put something inside of it. So yeah, there's plenty of cool things like that. There's another module, it's called Pygame. We're going to be doing this later. I'm going to be talking about game development with Python. If you want to see that, leave a comment down below and I'll get it started soon. And then we have import. We could also import something called OS, and this gives us opportunity to do things like file paths and lots of different things like that. We can import images. We can import tons of different things into our files in Python. So we're just going to use the math module today for demonstration purposes. But pretty much what happens is there's a bunch of built-in modules in Python. So this one is known as a built-in module, math. When you download and install Python, it pretty much you download that module. The Pygame module that I was talking about is not a built-in module. That means you actually have to go to the internet, you have to find it, and install it on your computer before you can import it into your Python program. And now what's really cool about Python is that it's an open source language, meaning that you can actually create your own modules, and they contain functions, classes, and you can use them in many of your different programs, or you can also send them to a friend maybe, or post them online for other people to be able to use. So let's get right into it, and let's do some things here. So if we want to use this math module, we have to first start by typing math. So the name of our module here, okay, so math. And then afterwards, we're going to do the name of a function or a class in that that math module. So you see a bunch of things pop up there in that little box. So if I do the dot again and wait a second, it should pop up. Yeah, so there we go. And you see we have cosine, sine, tangent, all that stuff, degrees, factorial, all these things inside of our math module. So these are new things that we wouldn't be able to use before. So I'll show you if we do math.py and I print that to the screen, well, we should get an endless number of digits like this, math.py. Is it running? There we go. So it just had to print a bunch of numbers. So math.py, it didn't print all of them. I think it only went to 10 decimal points. So yeah, and then I'll show you if I comment out this this import math, what'll happen if I try to do this. We get an error because, well, math is not defined. We didn't import it at the top of our program. So we'll uncomment this now. Now I can do things like math.degrees. Degrees simply turn something that is in radians into degrees. So if I did math.py in here, for example, and we print that to the screen, we get 180 degrees like that. They also have the math.radians, I believe, which does the opposite. So it turns a degree into a radian. So if we did 60 degrees here, like that, and we get 1.047, which is about pi over 3 radians, like that. So yeah, there's lots of cool things that we can do with these modules. Now I'll actually show you an example of how we can use our own modules and how we can import our own modules into our function. So I'm going to just start by typing import. I'm going to type my module, just like this, okay? Now I haven't actually created this module yet. We're going to do that in just a second. Now I'm going to go and I'm going to find the directory that my main script is in. So it's in tutorials up here. I've got this open, and remember how we had the file in here as well, because it has to be in the same directory. So I'm going to create a new file in that directory. So file, new file. I'm going to save this one as my module. Now spelling is very important. Again, capitals do matter, and it has to be in the same directory as our main script, which it is, like that. Now inside of this module, I'm going to write a very basic function. If you haven't seen that video yet, go check that out first. We just talked about some basic functions and what they do and the use of them. So I'm going to define, I'm just going to call it my func, like this. It's going to take a parameter called x, and all it's going to do is return x plus 5. So very basic function like that, but just for demonstration purposes here, okay? And now I have my module imported like this. So I can actually use my module. So I'm going to do print my module dot my func, because that's the name of my function. And then inside I need to give it a number. So what number do we want to use? Maybe we'll use 6. And we print this out. And you see we get 11. So by simply, all I did was create a new file, put it inside of my same directory as this script here, and easy enough, we were able to use it. Now I can actually create multiple functions in here. So I can define another func like this. That'll be the name. This one will take x again. And inside here, I'm going to return x integer division 5. And then again, we could use that one. So instead of my func, we'll use another func like this. And let's just type in a big number like that and see what we get. There we go. So again, it's working perfectly fine. So that's how modular programming, is what it's called, works in Python. Now obviously, if you're going to be doing modular programming, it's usually for larger programs and bigger programs where you want multiple files to keep things organized. Say maybe if you're doing a flight simulator, you may have one module that includes all of your physics functions. So you know that when you need to do physics, you're going to import your physics function, and then you can, or module, sorry, and then you can use the functions from there. And the great thing about this is that these modules are reusable. In other Python files, I can import them and I can reuse these functions. I don't have to constantly rewrite them inside of my script like this. So this has been a very basic tutorial, just an introduction to modular programming. I showed the math module a little bit. If you want to learn about some of the built-in modules in Python, then just go ahead and go to their website and you can see a bunch of the different ones that they have. Another one that we may be using later is called OS, so the statement for that is just import OS. And if you want to get started with game development, you can look into Pygame, which is this cool thing that I'm going to be doing a tutorial series on later. So yeah, that's been the video for today. We talked a little bit about modular programming. If you enjoyed, please like and subscribe, and I will see you again tomorrow with more content. Hey guys, and welcome back to another YouTube video. This is the 17th video in my Python programming series, and today we're going to be talking about functions, more advanced functions, and something called optional parameters. So let's just give a quick refresher of what a function is. I'm just going to write one very quickly. I did do another video on basic functions, so if you haven't seen that yet, go check that one out first. Now here we've defined what we're going to call the function func. And then inside of these brackets, we put something called parameters, if you remember that from the other video. So in this case, I'm just going to put x as my only parameter. And then I'm simply going to print x to the screen just like that. So a very, very basic function, but it's just to give you a quick refresher of what it does. Now, when we wanted to call our function, all we had to do was write our function name and then put a brackets, or the brackets like this. And then inside of our brackets, if we had a parameter set, we had to give it that parameter. So we could do 3, we could do hello. Let's just do hello in this case. And we'll click F5, and we get hello on the screen, just like that. Now we can change this again to maybe Tim, which is my name, just like that. And we get Tim printed to the screen. Very basic, very easy, just like that. Okay, so that's pretty much what a function is. Now, what we're going to be talking about today is more in depth on these parameters. So you remember we could give it multiple parameters. So we could do x, and we could do maybe text like this. So we had x and text, and then we could print x to the screen, and maybe we'll say if text is equal to, let's say 1, so the string 1, then maybe we'll print text is 1. Otherwise, so else, we will print text is not 1, just like that. Very easy. Okay, so now what we have to do when we call the function is we have to give it another parameter. In this case, I'm going to give it 2, and we'll see what happens. We get Tim, and then texter, I misspelled that, my bad, is not 1. Now if I change this parameter to 1, again, we'll see that we get text is 1. Now, again, that's just another example, but in some cases when we call a function and we have many parameters, or maybe we don't have many, but we don't want to constantly be rewriting these parameters. We want to have something called the default value for our parameters. So x, maybe we always want to give our function the value of x, but in text here, we always want it to be set to something unless we otherwise specify. So in this case, I'm going to say text, and then the equal sign, I'm going to put 2, just like that. Now, here I'm going to remove the 1, and you'll see what will happen here. We'll just run it to show you, and then we'll go in what's actually happening. So we get Tim, and then text is not 1. So what actually happened here is, since I didn't specify a value for text, so I didn't do a comma and write something else here, it defaulted to the value of 2. Now we can prove that by just simply printing out text and showing you that it is actually 2. So we have Tim and 2, just like that. If I wanted to change this value now, all I would have to do is simply put a comma here in the function and change it to whatever I want. So in this case, I'll do 67. And if we print it again, you'll see we get 67. So that's how the optional parameter works. Now, all you have to do to set an optional parameter is simply type an equal sign after your parameter. So if I have x, and I'll set it equal to 3, like that. Now when I call the function, I actually don't have to give it any parameters, because it already has the optional parameter of 3 and of 2, which are going to be the default values if I don't write anything in my function argument here, so inside of these brackets. And you'll see again we get 3 and 2 because those are the default values. Now there is one tricky thing that you have to understand about these optional parameters. Say you wanted to have x stay at the default value, so you wanted it to be 3, and you didn't want to type 3 in the brackets like that, but you wanted to change the text optional parameter to something like 7 or 8 or maybe another string. Well, you can't actually do that. In order to change this text optional parameter, you would have to also set a value for x here. So if I try to, I'll say I just want to set the text to 3, so I'll do like 3 here. It's actually not going to change, sorry, what do you call it? I'll change it to something else so we can see it better. 5, let's do 5. It's actually not going to change that second variable, right? It's going to change the first one automatically because that's just the order in which they're defined. So if you have more than one optional parameter, you will have to set a value for the one before in order to change the one afterwards, like this. So that's the only tricky part about these optional parameters. Other than that, they're extremely useful. Again, you would use them if you're constantly using a function and you don't want to have to keep writing in parameters. You only want to give it a parameter in a very specific case. Then you would have that optional parameter already set, so you don't have to keep typing a certain word, or you don't have to keep giving it a value like that. So this has been a shorter video, but this is the video on how to do an optional parameter. They look just like this. They're very simple and pretty basic. And I hope you learned something today. If you did, please like and subscribe. And I will see you again in another video. Hey guys, welcome back to another video. This is the 18th video in my Python programming series, and today we're going to be talking about something called a try and except block of code. So just like we talked about the if, else, and elif block of code, and like we talked about the for loop, which is a block of code, and like functions, which are blocks of code, we're going to be talking about the try and except. So in Python, we use try and except as our keywords. In other languages, you may have heard of try and catch statements. This is the same thing, except in Python, instead of catch, we use except. Okay, so let's talk about what a try and except statement is. Sometimes in Python, you want to do an operation or you want to try something, but you don't know if it's really going to work or not. There's some different variables that may come in. Sometimes it may work, sometimes it may not work. Usually this depends on user input or what the user is doing in the program. So a good example of this is maybe if we're validating a form. So we'll do an example here. We'll say text is equal to input, like this, and then we'll say username. Okay. Now, in typical usernames, you're only allowed certain characters. Maybe you can't do a comma, you couldn't do a star, certain things like that, right? Maybe we only want it to be text, or we only want it to be numbers. We just want to validate this. We could use a huge if statement to do this, but instead, there's something called a try and except that we can use. So in this case, I want my username to only be numbers. So I don't want it to be a string at all. I want it to only be numbers. So what I'm going to do is I'm going to make a new variable here, and I'm going to call it number. And all I'm going to do is I'm going to try to int the text like this, okay? So if you remember, what the int does is that simply converts our string into an integer. And then I'm going to print that to the screen, so I'm going to print number to the screen. Now, what happens right here is, if I try to type in a word like this, you see we get an error. It says there's an invalid literal for int with base 10. Now, you don't have to understand what this error is. Pretty much all this means is that we can't convert hello into a number because there is really no number there. How does it know what number to make that into, right? So in this case, we would use a try and except block, because if the user types in something that's invalid, well, we want them to type in something else. We don't want the program to crash like it just did there. So here I'm going to put a try like this, followed by a colon, and then I'm going to indent these two blocks right here. So that means we're going to try this block of code. Okay, and then underneath here, I'm going to type except, just like that, followed by a colon. Now there is a more advanced way to do this. We can accept a specific type of error, but I'm not going to talk about that in this video. This is just a very basic try and except block. And then under here, I'm going to type what I want to happen if this block of code doesn't run, meaning this block of code returns an error, and we can't actually execute it. So in this case, I'm just going to do, I'll just print to the screen, invalid username, because remember, we're only going to have our username contain numbers. Alright, so now if I run the program, and I try to type in something that is not a string, so that is not a number, like this, it'll just say invalid username, rather than crashing the program, which is what happened before. And if I do try to type in something that is valid, so maybe I type 1, 2, 3, 4, it just gives me that username back, right? So it works like that. So that's pretty much how the try and except works. Again, this is a very basic example, and that's what I try to do in my videos, just give you the basics, and then you can try to apply it to some projects you're doing, and some more advanced things. So again, what happens is it tries this block of code. If that block of code doesn't run or an error happens, instead of simply crashing the program and giving us that red message, it's going to go to this except block and it's going to do whatever's in here. Now in this except block, again, we could ask them to type in a new username, we could display another message, we could maybe close the program on them. We could do whatever we want to do in this except block, and it's extremely useful. So yeah, that's pretty much how the try and except works. If you learned something, please like and subscribe, and I will see you again in another video. Hey guys, welcome back to another video. This is the 19th video in my Python programming series, and today we're going to be talking about a fairly complex topic some people find kind of confusing in their programs. It's very useful to understand, and it's global versus local variables. So global pretty much means everywhere, can be used in anything, and local means specific to a certain block of code or to a certain class. So let's just dive in right away with an example. So in our program, we have things called variables. Again, we've talked about them before. So I'm just going to say var up here equals 9. We'll say our true, this is lowercase here, is just equal to true. Or actually, let's call it loop instead, just not to confuse anyone. So loop is equal to true. And then maybe let's make a function. We're just going to call this function func. We'll give it a parameter of x. And we're just going to say if x is equal to, 5, then return true. And we'll set a variable up at the top of this function, and we'll just call it new var is equal to 7. Or, yeah, 7. Let's do that. And then instead of returning true, we'll actually return new var. My bad. New var, just like that. Okay. So here we have 3 variables. We have the variable var, which is equal to 9, the variable loop, which is equal to true, and then the variable new var, which is inside of our function, and that's equal to 7. And then the parameter x, which again can kind of be considered a variable, but it is more specifically a parameter. So I just want to show you right away what tries to happen if I print out the variable new var. So outside of my function, in its own line, I'm just going to say print new var, like that. We click F5, and we get an error here. It says the name new var is not defined. But how can that be possible? We just made new var right here in our function. Well, this is where we get into local versus global variables. So the variable new var is actually known to be a local variable to the function func. So that means the only thing that's able to access the variable, change the variable, and use the variable new var is the function func. So again, if I put the print statement inside of my function and then I call my function, it will work. So here, if I type func now and I'll give it value of 2, then new var does print to the screen and we don't get an error. So that is how the local variable works. So again, it's the same thing in any other type of function. So if I write another function, I do define other func. This one I won't give it a parameter, and I'll just say new var is equal to 5, like that, so different than 7. And then this function will print new var. Well, do we think it's going to print out 7, or do we think it's going to print out 5? So we'll show you like this. If we run, take 0 positional arguments, other func. Oh, my bad, there's a 2 in there, sorry. It prints out 5, right? So it doesn't look at this variable here, it looks at the local variable in here called new var. Now same thing if I put new var up here outside of all of these functions and I set it equal to 23. And then I click F5 here to run, it's still going to print out 5. That's because these functions, they can see these variables up here, but if there's a variable already declared inside of their function, they're going to use that one instead. I know it's kind of confusing. I'm going to talk a little bit more about how this works. I just wanted to give some examples to start off. Okay, so now we'll talk about global variables. So local variables are ones that are declared usually inside of a function. So that means outside of the function. So again, if we tried to print new var out here, and I got rid of this up here, we get the error like we got before, right? It says it's not defined. So what about global variables? Well, these global variables are ones that anything in the program can see. So var and loop would be known as global variables. In here, if I try to print out our variable var, and then I'll just call that function by doing func, and I'll give it a value of 2 once again, it will be able to see var, and it does print it to the screen as 9. That is because this is global. It's not defined inside of a function or inside of a class, and classes we'll talk about later. Don't worry about that. Same thing if we try to print out loop. So if I change this to loop, again, it should work. We get true printed out to the screen, just like that. So now there's the issue with changing variables inside of a function. So typically you want to avoid this. You don't want to be dependent on these global variables up here to make your functions work. This is because if you remember in my other video I talked about modular programming where we can reuse functions. Well, if I have a variable defined up here and my function is referencing that variable, meaning it requires that variable to work, then if I try to use this function in another one of my programs, it's not going to function properly, because that loop variable or that global variable that I try to use is not going to be defined in that other program, right? So let's do an example here of how we can actually change a global variable. So if I go here and I say loop is equal to 7, so I call my function and it's going to set loop equal to 7, and then I try to print out the variable loop. Well, what do you think is going to print to the screen? Give me a guess. It's either going to be 7 or it's either going to be true. What do you think, right? So I'm printing it underneath after I call this function. Let's see. We get true. Now, even though we, what looks like, changed the variable in this function, instead of actually changing this global variable, instead we created a new variable which is local to the function called loop. If we want to change this variable, we have to use something called the global keyword. So in Python, what we have to do is at the top of our function, we just type the word global, followed by the variable name that we want to change. So in this case, I'm going to say loop. Now, if we run this program, we print out 7. That's because this tells our function that we're going to look outside of the function here for the variable. If it exists, then we're going to change it, just like we did there. So I know this has been kind of confusing. I've kind of jumped around. Try to play around with these things and see if you're getting errors, see if you can figure out what's going to print to the screen here. If you want to change a global variable, so one that you define at the top of your program here or outside of your functions, then you must type the global keyword inside of your function followed by the name here. Again, if I try to change the variable down here, so not inside of a function, it will work. So if I do loop is equal to false, then, oh, we get 7 again just because I called it up here, so I won't call this function this time. If I say loop is equal to false, then we will get false because it's not inside of a function, so it is able to see and change this variable. So really, using the global keyword, it's just inside of functions, and just remember that if you do create a variable inside of your function, it's local to your function, meaning that unless you type this global keyword first, and then followed by the name of that variable, everything outside of the function will not be able to see that variable. So if you liked this video and you learned something, please like and subscribe, and I will see you again in another video.
Hey guys, and welcome back to another YouTube video. So in this video, I'm actually starting a new series on classes and objects in Python. Now I'm going to start off fairly simple and just explain to you kind of what is a class, what is an object, how can we create our own, and in future videos I'm going to get a lot more advanced and show you some really cool things that you can do with classes and objects that not only make your life a lot easier, but are really cool in my opinion. And I didn't even know you could do them until I was kind of searching around before making this video. So make sure if you guys are interested in bringing your programming kind of to the next level and stepping out of the basics of Python and moving into more of an intermediate to advanced topic, that you guys watch through the series because you're going to learn a lot and you're going to have a fundamental understanding of Python that you never understood before if you can understand the topics I'm going to talk about. Okay, so let's start by talking about objects. What is an object? Well, in Python, an object is pretty much anything. And you can see on my screen here, I have two variables, x equals 5, y equals string. Now, to us, without any understanding of objects and classes, this just looks like x is equal to an integer, that's 5, and y is a string, and that string value is string. Now, I just want to show you quickly, and you might have seen that you can do this before. If I print out the type of x, and we'll just do the same thing here with y, run our program, you see we get class int and class string. Now, this is pretty trivial, you figured this was going to happen, but what does this class actually mean here? Well, pretty much whenever you create a new object in Python, so whenever you create a variable or something like that, it automatically creates an instance of an object. Now, x, the way that you can also read this is x is equal to an instance of the int class and its value is 5, whereas y is equal to an instance of the str class and its value is string. Now, these classes allow us to have built-in functionality in Python. Now, you might take for granted the fact that we can do something like x plus 7, right? And obviously, we know we're going to get 12 when we do that. Or if we do like x minus 6 or x divided by 4. But someone actually coded this functionality into Python, and you just can't see it when you're coding here because it's kind of underneath. And I'm going to actually show you a way that you can look at this built-in code, okay? So just know that anytime you create a variable and anytime you kind of use any functions, like for example, if you use, I don't know, say like h is equal to, what's something we can do, like int y, okay? I know that's not going to work, but whenever you use functions like this, someone already coded these functions for you, and they're typically built into a class of a certain type. When you do something like y.strip, you just take for granted the fact that you can use this .strip method, and this is called a method, but someone actually built this in, and the reason you can use this is because it's a method on the class of str. If I tried to do something like x.strip, well, clearly that's not going to work because x is not a string object. So just understand that whenever you create anything in Python, it is actually an object without you really knowing it or not, okay? So now I'm going to show you, I'm just going to run this in debug mode so I can print some stuff out to the screen, okay? So I got console and Python console, okay? So I'm using PyCharm, but this works perfectly fine with regular IDLE in Python, okay? So if I type this help function and I pick a class, and I'm going to pick int like this, okay? I type help on int. You can see it prints me all this stuff. Now, what does this actually mean? Well, once we get to the top, you can see it says class int of type object, or inherit from object. So pretty much whenever we create an integer, and the way we create an integer in Python is simply by just saying like x equals 5, x equals 470, whatever like that, it automatically defaults this x is a type int. And you can see here that actually tells us exactly how this class works. And this is really useful if you don't know documentation. You can just type help on something and it'll read out all the class and everything for you. So convert a number string to an integer, return 0 if no arguments are given. That's what happens when you call the int function. And when you give a base, well, then it tells you what it does there, okay? Now it says methods defined here. Well, these are actually all the methods that you can use on the class integer. So if you have ABS, you have add, and, bool, ceil, div mod, equal to, float, floor, florative, and I'm going to show you what all of these actually mean and why they have the underscores on them later on, okay? So just wait for that. But you can see that there's a ton of different methods and a ton of functionality already built into this integer class size of string, and you can just keep going 2 bytes, and there's a ton. And then class methods defined here, we're going to talk about what those are later. Now I want to show you if I do the same thing on string, so I say help on str like this, then we get the same thing except for string. And this one is going to be, what do you call it, a little bit longer because there's more things you can do with string. But you can see we have class string and it inherits from object, and we'll talk about what all this means later. Just follow along for now. Create a new string object from a given object if encoding, and so on, okay? And then it goes down here, add, contains, equal, and you can go through all of the different methods that it has. Now obviously this is the same for Boolean values and for, what do you call it, floats and all other data types in Python. Now if any of you've ever seen Turtle before, you know that if you create, for example, import turtle, okay? Wow, I can't type today. And you create like Tim equals turtle dot turtle like this. What you're actually doing is creating a new instance of a turtle object. So in this turtle module, there's a class named turtle, and when you call this what's known as a constructor, you're actually creating a new turtle object, and you're just naming it Tim, or storing it in the variable Tim, okay? So what else should we talk about with objects here? Yeah, so let's talk about the difference between methods and, what do you call it, functions quickly. So a function, everyone here should know, is created with the define key, okay, or like define keyword. So I say define func, give it a value x, and we'll simply return x plus 1. Now we know to call this function, what we can do is we can simply say like print and then func of 5. And we know that that should give us a value of 6, right? Because it just simply adds 1 to what we're giving. And this is a function, there's no question about it, okay? Now a class is actually what you call with the dot operator. So this, or sorry, not a class, a method. So this dot right here, turtle.turtle, is a method that creates a new turtle object. And I'll show you what I mean here. So if I do something like print y dot upper, well, this upper right here is not a function, it's actually known as a method, and it only applies to the class str. So I'll just print this quickly to show you. We get string in all capitals, okay? If I tried to do something like x.upper, and I click the play button here, well, x has no method upper, and you can see int object has no attribute upper, okay? And that's because, well, x is an object of type int, and remember when we typed help on int, well, we didn't see any upper method there, so we actually can't use that. And that's why we can only use methods on their correct data types, right? So if you create a float and you do like, I don't know, like f equals like 5.5, then obviously if we try to do f.upper here, this is going to crash as well because, well, float object has no attribute upper, right? It doesn't have that class, or that method, sorry, in it. Okay, so a method is anything you're calling on an object itself, right? And a function is something that's going to take an object and apply an operation to it, right? So you can see here that 5 is passed into the function. We don't have to do like x.function. We just pass it in there, and then it returns us a value. Now methods can return us values as well. This one is returning us a value of all capital string. It's just different how we actually call those things, and they are very similar, just the difference is the way that one of them you call on an object and one of them you have to just call and then pass an object through. And sometimes these methods can take objects as well. For example, let's see if I do x dot or f dot replace, I think that's a thing, or I'm gonna have to do y dot replace, y dot replace like this, okay? And then I'm gonna pass it a, I don't know, what should we pass it? Let's pass it a s, and we'll replace it with a blank string. Okay, so we're passing a object of type string, and we're passing another object of type string, and that's what this method takes, as well as we have to call it on the instance, right? So string. So if I call this, we get string and 6 because it simply replaced s with quotations. Okay, so I think I'm gonna cut the video here. I hope you have a little bit of an understanding of what an object is, because in the next video we're gonna create our own objects and our own classes, and we're gonna talk about that. It just was fundamental that you guys understood this before moving on to the next video. Okay, so that's been it for this video. If you guys liked, please make sure you leave a like and subscribe, and I will see you again in the next one. Hey guys, and welcome back to the second video in this object and class tutorial series. In this video, we're going to be going over creating your own objects and your own classes and what that looks like in Python. So just go ahead and delete this code from the last video and start fresh. So if you guys remember in the last video, we talked all about objects, we talked about methods, and that's all cool. We kind of already understood a lot of that stuff. Like, we've used those methods, it makes sense how they work. But now, how do we create our own? And this is the whole goal of this tutorial series, to create your own classes and your own objects and add functionality to your program. So to create a new class, and this is going to be a new like data type, something like that, we'll talk about that in a second, you just simply type class and then whatever you want the name of your class to be. So in Python they have int, string, list, whatever. Okay, we're going to create a class and I'm just going to call it dog. Now you probably have seen this example before if you do anything with like classes or objects, because people like to use animals, but it's a really good example. So this is now creating a new class of dog. Now what we have to do whenever we create a class is we have to add some methods into it. So remember, I talked about methods are things that you call on the actual class itself. So I'm just going to type define underscore underscore init underscore underscore, and we're going to talk about what this does in a second. And make sure you don't forget this self keyword. This object keyword you can leave out if you want. I just like to type it because I don't know, it's just a habit, right? Because we have class dog define init, and I'm going to make one more method and we're going to call it speak. Okay, and make sure you don't forget this self keyword. We're going to talk about what all this does in a second. Okay, pass, and in here I'm going to say pass. All right, so we've now just created our own class. It does not do anything, but we've created our own class. So what we actually do here is we're creating, well, a new class. It's equal to dog. It inherits from object. Don't worry about that. And this is what's known as the constructor method. Now this underscore underscore init underscore underscore needs to be in most of your classes. Okay, so if you guys want anything to happen initially when you first create a class, you need to make this a init class. And what happens is when we create a new object, and the way we can do this is by doing something like, I don't know, Tim equals dog, like that, this method is automatically going to fire. It's automatically going to go off. We don't have to say Tim dot underscore underscore init underscore underscore. We don't have to do that. Whenever we create a new object of type dog, this is automatically going to happen. So for example, if every time I created a new object of dog, I wanted to print out nice, you made a dog, like this, then every time that we do this, so if we say like Fred equals dog as well, then it's going to print this to the screen. And I can prove this to you by simply running. Okay, so he says, nice, you made a dog. Nice, you made a dog. All right. We didn't have to call this init. It just automatically happened whenever we created this dog. So let's talk more about this init and what we can do with it. So in classes, there's things called attributes and methods. All right. Methods are anything that you create using define. Okay. And they look just like functions, except you have to call them using an object. And like we talked about in the last video, and attributes are kind of like variables that belong to a certain object. So to create a attribute, you need to use this self keyword. All right. What this self keyword actually stands for is it stands for the instance that you're calling. So Tim is known as an instance of type dog or of class dog. Now Fred is another instance of type dog. Now I'm just going to do this and then hopefully you guys can understand how this kind of works because it is somewhat difficult to explain. Okay, so now what we're saying is we've created this initialization, all right, and we have now that it takes a name, okay? So what that actually means is we have to now type a name into our initialization. So whenever we create a dog, we have to give it a name. So in here, I'm going to give it a name, Tim, And in here, I'm going to give it a name, Fred. All right. And don't worry if you guys are confused. I'm going to explain this all in depth in a second. Okay. And I'm just going to do this so that we can actually see what our name is. Print, hi, I am, comma, self dot name. And we'll talk about what self does in a second. Okay. Let's do Tim dot speak and Fred dot speak as well. Okay. So let's print this. And it says, hi, I'm Tim. Hi, I'm Fred. Okay. So how does this work? So in this initialization, this fires automatically when we create dog. Okay, so by calling this, we're automatically calling init. So if we put a parameter in init, so name, that means that we now have to pass a parameter when we create our dog. And just like a function, we can create multiple parameters. We can do like name, age, color, kind. We can do as many as we want, okay? And that works fine. Now, what does this self do? So this self actually represents the instance, right? So if I call dog equals Tim, or dog Tim, whatever, and I set that equal to Tim, well, Tim is what's being passed into this self parameter here. And notice how we have two parameters, but we only pass one thing. That's because self always needs to be here, except in like really specific cases that we're going to talk about later. So when we call self.name, we're saying that Tim.name is equal to whatever name we put in here. And that's the same thing with Fred, right? So when we call it on Fred, then we say, well, Fred.name is equal to Fred. All right. If we didn't do that and we said something like name equals name, if I tried to print self.name, that would just crash. It wouldn't work because we don't know which instance has what name. Okay, so this self means it kind of means like belongs to the instance that you're calling it on. I'm trying to explain this as good as I can because you really need to understand this. So I'm going to do another parameter here too. Okay, so self.age equals age. All right, and let's just print this out. And I am self.age years old. All right. Okay, so let's print this out and see what we get. I'm missing one. Age, sorry, I gotta put age in here. 55, 3. Okay. So now if I print this, say, hi, I'm Tim and I'm 55 years old. Hi, I am Fred and I'm 3 years old. Okay. So each of these are instances of class dog, and they each have a name and an age, and you're able to call the speak method on them. Now, what this speak method does is notice how when I call speak, it automatically takes self because it has to know what instance I'm calling it on. And that way it's able to access the name and the age. Now in here, you can actually change the name and the age. So I'm going to create a new method. I'm going to say change underscore age like this. Okay. And notice how it takes self no matter what, it automatically types it in for me. And here I'm going to do age. All right. Now what I can do is I can say self.age is equal to age. And if I call, let's see here, Tim.change age, and I give it something like 5. Now if I speak, you can see that we get, hi, I'm Tim and I'm 5 years old. And then we say, hi, I'm Fred and I am 3 years old. Now, obviously, you guys can create as many methods as you want. You can call them whatever you want. Just make sure whenever you create them, they first of all have self because we have to know what instance we're calling it on so that we can access those attributes. All right. And you can change these attributes however you like within those methods. Now, I will show you what else you can do. Okay. So say you wanted to access Tim's age. And you didn't want to print out like, hi, I am all this. You didn't want to speak. You just want to know what his age is. Well, what you can actually do is you can simply print tim.age. And now you can see, if I run the program, we get 5 down at the bottom. And you can do the same thing with name. So tim.name, and it gives us Tim like that. So we're actually able to access the attributes of our object from just simply calling whatever that attribute is. And in this case, it's name. So whenever you want something to be like public to the instance so like they can see it throughout all the methods, you need to do self dot and then whatever you want to call it. So I could say like self dot, I don't know, let's say li. It's going to stand for list. You could have a list of like 1, 3, 4. And now if I call tim.li, you can see we get 1, 3, 4. And obviously if I call Fred.li, well, this is going to work as well. We get 1, 3, 4. Now the main benefit of classes is that you can create things, you can create multiple objects of a class. So if I wanted to store like the name, the age, and a list for 300 dog objects. If I wasn't using classes, what I would have to do is I'd have to do like dog1 name equals Tim, and then I'd have to do dog1 age equals 5, and then I'd do dog2 age equals Fred, and you'd have to continually keep doing that with a ton of variables, and obviously you don't want that. So these classes allow you to create infinite amount of objects of that type class and have all of these properties and attributes apply to them. Okay, so what else should we talk about here? Maybe creating new attributes. Okay, so attributes are anything that have this like self.name, self.age, self.li, whatever, and methods are with these define keys. Okay, so if I create a new one and I say define and add, what do you call it? Weight. Okay, say add weight. I'm gonna give it a weight, and then we can say self.weight is equal to weight. And what this does now is it creates a new instance attribute that is going to be applied to this dog class. Now you see it's giving us an error here. It says instance attribute weight defined outside of init. That's because it wants us to define that inside of this initialization, but it's fine. You can actually do it out here. So now if I do tim dot add weight, I give it a weight of like 70, okay? And I'll print tim.weight like here. Let's see what we get. We get 70. Okay, now what if I try to print fred.weight? Well, let's see what happens. We get Fred has no attribute weight, or dog object has no attribute weight, and that's because we have not yet added this by calling add weight on our instance Fred. Okay, so I think I'm going to cut the video off here. Hopefully you guys have a basic understanding of how classes worked. It is kind of difficult to explain it. If you guys have any questions, leave them down below, because I feel like I might have butchered the explanation on some of it. Other than that, in the next video, we're going to go over, I think, inheritance and creating some more advanced methods and talking about how those work. Okay, so if you guys enjoyed, please make sure you leave a like and subscribe, and I'll see you again in the next one. Hey guys, and welcome to the third video in my Python object and class tutorial series. Now in today's video, I'm going to be going over inheritance, and this is an extremely important and a little bit more complicated topic dealing with inheriting attributes and methods from other objects. I just want to start off by quickly saying though, if you guys are finding the videos a bit too slow for you, and I'm kind of explaining things a lot of time, the reason I do that is because I'm not sure the level of person that's going to be watching the video, and I want to make sure that the people that will understand quickly can get the information within like the first few minutes, and then the people that really need some extra reinforcement have that opportunity to watch through the entire like 11 or 12 minutes and have it explained to them multiple times. So if you guys are finding it's a bit too slow and you want to move faster, just fast forward the video or skip to the next one if you guys are done with whatever I've been talking about, because like in the last video, for example, I watched it back and I kind of explained the same thing a few times. That's just for the people that need a bit of extra help, and that's kind of what I aim to do with a lot of my videos, so that people that need help can, you know, grab that if they want to. Okay, so let's get started, and I'm just going to modify this dog class, just delete li, we'll get rid of change age and add weight, and we're just going to have name, age, so on like that. Okay, and we can get rid of all this stuff down here. Now what I'm actually going to do is I'm going to create a new class, and I'm going to call this cat. Okay, now cat is going to have very similar attributes as dog. In fact, let's just copy them over. Okay, so we'll paste them like here. We have name, age, hi I am, whatever. Okay, now I'm just going to add one thing, and in this case I'm going to add, let's see, color. Okay, so self.color is equal to color. Okay, now this cat object is obviously going to work the same as dog. I don't think I need to show you. Now, just take note of what I just did. I just copied all of the stuff from here into cat. Now, if you know anything about programming, you know that programmers don't like to copy and paste, and that you really shouldn't be copying and pasting code. So Python has actually come up with a solution to what I just did that allows us to not have to do that, and that is called inheritance. So I'm going to delete all this, and I'm going to go back into cat, and I'm going to type dog here. Now what this little bracket up here means is it means parent. So whenever you're talking about inheritance, you always have a parent or a superclass, and then you have a child or a like derived class. Okay, and there's a bunch of different words for them. They're not really that important. Just know parent and child. It's the most basic. Okay, so in this case, cat is going to inherit from dog. which means dog is the parent class and cat is the child class, and it is derived, so it's taken from dog. So that means if I do class dog, and if all I do in here is just type one thing, so I type init underscore underscore, and in here I'm just going to put name, age, and color, and I'm just going to do something that's going to look confusing. I'm going to explain it after, okay? Super dot underscore underscore init underscore underscore underscore, and I give it name, age, and I say self dot color equals color, and then I create a new object of cat. So I'm just gonna say Tim equals cat, give it a name, age, and color. So in this case we'll do Tim, age 5, color blue cat. I know, okay? So we do that, we press play, no errors, okay? I'm just gonna show you. If I do tim.speak, what do you think is gonna happen? Take a guess. It says, hi, I'm Tim and I'm 5 years old. Now, how the heck does all this work, and what did you just do? I know, that's probably the question you're asking. Probably fix that to say color. So the way this works is when you inherit from another object or another class, sorry, you actually inherit all of the properties and attributes and methods of that class. So when I do tim.speak, you can see, well, Tim is an object of type cat, and cat, well, I don't see speak here. How does that work? Well, since the speak method belongs already in the dog class, and we're inheriting from the dog class, it is actually carried on to the cat class, and we're able to use it like that. Okay, so tim.speak. Now, what I did here with this super.init, I know this looks confusing, but pretty much in the initialization of cat, which is unique to cat because it has this added parameter color, I simply called the initialization of dog first, which means that when I gave it name and I gave it age, it automatically added self.name and self.age to my cat object of Tim. You see how here I didn't type self.name equals name, I didn't type self.age equals age. All I did was call the constructor method, or the initialization method, of the superclass, and the superclass simply means dog. And it did that for me. Now, in this example, it seems like, well, why in the world would you want to do that? That doesn't make sense. There's not that many lines, whatever. If you have really long methods and really long classes, it makes a lot of sense to inherit. So in this example, it's hard to show, but in long ones, you do want to inherit. Now, I want to show you that you can add and overload things from the parent class. So for example, the parent class has speak. I'm going to add one more method in here. I'm going to say define, let's just say talk, okay? And in here, it's going to say print bark, because it's a dog, okay? Now, obviously, in our cat class, if we want to talk, we don't want to bark, right? And that's what's going to happen right now. If we do tim.talk, it's just going to say bark. So if we wanted to change this, we can actually overload this or override this method. So if I do define talk in here, I can print, and in here, no, I'm not going to do bark, I'm going to do meow, okay? Like that, a little exclamation point. So now if I do tim.talk, like this, you can see that we get meow instead of bark. And that goes for anything in inherited classes, okay? So anything that we do in here is going to override whatever is happening in this dog class. So say we wanted to change speak, we could say define speak in here, and then whatever we put in this speak method would overwrite what's in here. Now, that's not to say that it's going to change if you create a dog object. So if I do, like, I don't know, let's say Jim is equal to dog, give it a name, give it Jim clearly, age, this is an old dog, we're going to give it 70, okay? And we do Jim.talk, well, we're still going to get, if I spell Jim correctly, bark, right? So we get bark and meow. So we don't actually change anything in this class. We just say that, well, if you create a class or if you create a cat object, then it's going to have this talk method which overrides the talk method that we created in dog. And this is the same if you do something with like these attributes. So if I do like self.name and I just statically type in a name, like I type tech, okay? Then when we do tim.speak, now you would think that it's going to get hello, I am Tim, because that was the name, right? And I am 5 years old, but instead we're going to get tech. So it says, hi, I am tech and I am 5 years old. And that is because although we set name up here to be equal to whatever name we type in as a argument, we are changing it to tech, and that overrides whatever happens in this dog class, okay? So I hope that makes sense. Now, what else can we override from those classes? Well, we can inherit like multiple times. We can inherit different classes from upper class. I'm going to talk about the way you would want to do an inheritance. Okay, so the way you typically want to inherit is you want to have one really general class that kind of applies, that's a bit smaller, that applies to like a bunch of different classes. So I'm going to delete these, and I'm just going to type out them and show you an example of what I mean by a general class. So if I created a class and I called it vehicle, like that, okay? Is that how you spell vehicle? I don't care. We're just going to leave it like that, okay? And then I created an initialization in here, okay? And the initialization is going to take like price, gas, and color, okay? I know these are random, but just follow along. Self.price equals price, self.gas equals gas, and self.color equals color, okay? Now I'm just going to give it a method. I'm going to call it define fill up tank, like this, okay? And what's going to say is self.gas equals, and we're just going to say that each gas tank has a maximum of 100, okay? We'll say define empty tank, and this is just going to say self.gas equals 0, and then we're going to say define gas left, and this is simply going to return self.gas, okay? And the reason I have this is because, well, in all vehicles, we're probably going to want to have gas, right? All of our vehicles are going to have gas if they're not electric, obviously, and we're not going to deal with that for now. So fill up tank, empty tank, and gas left is probably something we want to know for all of our different vehicles. Now, for example, if I create another class and I say class car, okay, and car is going to inherit from vehicle, like that, okay, and all we're going to do for the init is we're just going to call the vehicle init. So how we do that is we do super dot underscore underscore init underscore underscore, and obviously this needs now a price, gas, and a color. So we're going to pass it price, gas, and color, like that, and then that's our initialization. And in car, all we're going to have is we're going to have a method, and it's going to call, let's add one more thing here, speed, okay? Self.speed equals speed, okay? And then here as a method, let's just have like beep, okay? And all this is going to do is simply print beep beep, okay? Now I know these aren't great examples, but just follow along. So what we have now is we have the vehicle class, okay? And it has these things that do with gas, and obviously gas is going to work for all of our different types of vehicles. And then we create a car class that inherits from vehicle, and in here all it does is it has an extra attribute called speed, and it has a method called beep. Now if I create another class, and instead of car I want to do truck. Now truck is not going to say beep beep, it's going to say honk honk, like that, okay? And instead of having self.speed, we're going to have self.tires, okay, equals tires, because that's a property that we're going to care about for our trucks, because sometimes they do like 6 tires, 18, you know what I mean? That's what I mean by truck, okay? So you can see that we have a really general class vehicle that simply has a color, a gas, and a price. And obviously within our truck and car class, we're going to care about those attributes, so price, gas, color. But in truck, we care about tires, and when we click beep, we want to say honk honk. And for car, we care about the speed that the car can go, and when we call beep, we want to print beep beep, okay? So that is an example of where you would use inheritance. I know this is a really small example. A lot of the classes you're going to end up building are going to be like massive and inherit from like other classes, and you're going to have like large files full of classes, but this is the best example I can kind of give you of when inheritance would be useful. And same thing if I wanted to do like define motorcycle, then you could do the same thing there. And for wheels, you do like self.wheels equals 2, like stuff like that, okay? So I think I'm going to end the video here. Hopefully you guys have an idea of how inheritance works. One quick thing, if I wanted to, I could inherit from car as well. So if something is inheriting from something, you can also inherit from it. So that would mean that now truck has all the attributes of car and all the attributes of vehicle, because, well, car has the attributes of vehicle. So since car has it, we're inheriting from car, truck is going to get it as well. Just wanted to add that in before we end. Anyways, make sure you guys leave a like and subscribe, and I will see you again in the next video. Hey guys, and welcome back to another Object and Classes tutorial video. In today's video, I'm going to be going overloading default Python methods and why these are extremely useful. Now, if you don't know what I'm talking about, just stick around for 1 second and I will explain it. So first of all, I just want to talk about what I've already coded here. I just have a very basic point class, and you can see that our point object has 3 kind of attributes, an x, y, and then our coordinates, which is self.x and self.y. We have a very basic method that can simply move us by x and by y when we type it in. Okay, I've created 4 points down here, and these are what we're going to use to kind of test out some examples that I'm about to create. So in Python, remember in my first video, I was talking about the fact that if you create integer objects, so for example, I say like I equals 5 and like z equals 5. If I wanted to add these together, all I simply have to do is, well, put a plus sign, right? And Python knows that this plus sign means, okay, add these 2 things together. Now, how does it know this, and how does it know what to do? Well, with integers, it's pretty straightforward, but what if we start doing things like strings, right? If you do s, and then you go like 6, 7, 8, how does Python know how to add these 2 strings together? Well, it would make sense to just append it on top, but someone actually had to code this functionality in, and that's exactly what we're going to be doing in this video, except with our custom point object, okay? And you'll see what I mean in just a second. So pretty much, what we want to eventually do at the end of this video is be able to add, multiply, subtract, and compare points without having to reference their attributes outside of the class. So right now, if I do p1 plus p2, our program's going to crash because it doesn't know what that means. But by the end of this video, we're going to be able to do that, okay? So that's what I'm going to show you right now. So in Python, there's a bunch of default kind of operations and methods that you can apply on classes, and by default, they're not defined, right? On our point class, if we try to add 2 things right now, that doesn't make sense. So what we're going to do is add that method. So to do this, to add the add operation, you're just going to do define underscore underscore add, okay? And then in here, you need to give another point object. So what happens when I try to add a point and another point object? Well, whatever, we're going to return a new point, okay, that is simply equal to self.x plus p.x and then self.y plus p.y. So what this is doing is, since we're passing another point object, so when we do like p1 plus p2, p2 becomes p and p1 becomes self. So we're going to grab the coordinates of p1, add them to p2, and return that in a new point object, okay? Now, the same works for subtract, multiply, and division, and for a few others as well. So I'm just simply going to copy this, okay, and paste it one more time. And instead of add now, you could probably guess, I'm going to put sub. And what this is going to do is allow us to subtract points. So it's going to be the exact same, except now we're simply going to subtract the coordinates. Now with multiplication, this one is simply define underscore underscore mul underscore underscore, and this is going to allow us to use the asterisk or the star to multiply 2 different point objects. So same thing, it takes a point. And in this case, when we multiply points, I could return a new point with multiplied coordinates, but the way it actually works, if you know anything about vectors, is we're simply going to return the scalar product, which means you multiply the first 2 x coordinates, get a value, in this case we would get 9, and then you actually add it to the y coordinates multiplied together. So in this case we'd have 9, plus 8, and that would give us 17. We're not returning a new point object, it's a scalar or like just a number value, okay? So what we're going to do here is we're going to return self.x multiplied by p.x plus self.y multiplied by p.y. And those are the 3 that I'm going to stick with right now, and I'm going to show you a bunch more that we can use to compare point objects using greater than, equal than sign in just a second. So I want to test if this is working. So let's create a new point. I'm going to say 0.5 is equal to p1 plus p2. And I'm going to say 0.6 is equal to p4 minus p1, okay? And then we'll even go as far as creating p7 and multiplying p2 and p3 just to make sure everything's working. So now I'm simply going to print to the screen p5, p6, and p7, and let's see what we get. So you can see here I get main point object, and 9. Now, the way that this worked, and the reason that we're not actually getting a coordinate value, is because I have to show you another method that we can use so that this was actually going to give us something meaningful. Because right now, when we print out our point objects, right, because 0.5 is a new point object because when we add 0.1 and 0.2, we are returned, a new point object, right? So if we want to make this meaningful and not just show us the address in memory where the point is stored, which it currently is right now, we need to add another method, and this one is called str, okay? And what this is going to do is this is going to be called every time we try to convert our point object into a string. So when we try to print our point object, it automatically looks for str, and if it doesn't find it, it gives us this kind of gibberish right here. But if it does find it, it's simply going to, well, use the value that we returned. So in this case, we want to return, I think we'd want to return from string, probably the self.coordinates, right? So I want it to look something like this. We have brackets, and then plus str, and then self.x plus a comma plus str self.y and plus, and then another bracket like this, okay? So now if I try to print 0.5, 0.6, and 0.7, you can see what we get. And there we go. So now instead of getting that gibberish, we get 6, 6, -3, and -3. Now keep in mind, you can make this anything you want, but you do have to return a string value here for this to work. Okay, so the next methods we're going to talk about, I'm just going to put them above string here just for good practice, is going to be comparing 2 points. So this is great. Now we can add, we can subtract, we can multiply, but what if we want to compare? So what if we want to see if 0.1 is greater than 0.2, or if 0.3 is greater than 0.4? Well, how do we do that? We first have to determine how are we going to compare points. Are we simply going to compare the x's and the y's? Or are we going to find like the magnitude of a point? Like what are we going to do to compare which is larger? In my case, I want to find the length of a point from the origin. So in this case, the way this would work, I think I can just bring up a little grid program here and just draw it for you quickly. So if you have an origin like this, okay, I'm just using my mouse right now, and you had a point here and a point here. Well, from the origin, this would have a distance. And from the origin, this would have a distance. Obviously, this could be like a distance of 7. This could be a distance of 2, and 7 would win, right? Because we don't really care about the negatives. If you had something all the way over here with a larger distance, then, well, we would want that to win, right? So that's the way that we're going to compare them, and I'll talk about that and how we do that in 1 second. So to compare, we have 4 major comparisons, I think, that we can do. Anyways, I'll type them and we'll see. So one of them is greater than, and that is GT, okay? And then you can do self, and you also need another point object like this. Another one is greater than or equal to, and greater than or equal to is simply GE, okay? And then same thing, we need P. We have less than, so define, and you can probably guess, LS, or sorry, LT, what am I saying? Less than. And then we also have less than or equal to, so LE, like that. And we have one more, and this is simply equal to. So this is if we do the double equal sign, then it's going to give us a comparison. Now in these methods, we need to return a true or a false value. So in greater than, remember the way I said I wanted to compare them is to get like the magnitude of the point from the origin. So I'm just going to add a method in here. I'm just going to call it, let's do length maybe. Okay. And then in here, I'm simply, actually we don't need to take anything. We're just going to return the math.sqrt, and I'm going to import math right up here. And this is simply how you get the length from the origin, okay, of self.x to the power of 2 plus, what am I doing, self.y to the exponent 2. And this is going to give us the length, okay? So import length. So when I'm doing greater than, I want to see if return self.x, or what am I saying, self.length is greater than p.length, like this, okay? And I believe we do actually need these square brackets here. So all this is going to do is it's a Boolean condition. It says, well, if the length of our self is greater than the other length, well, then we're simply greater than. So let's just copy this and put it in here. And in this case, we're just going to do greater than or equal sign, because this is greater than or equal to. We'll copy this again, change this around to less than, and one more time, and this is now just going to be less than or equal to. Now, if we're seeing if two things are equal to each other, well, that's pretty easy as well. All we can do is simply take this, or actually the way we're going to do this is just see if the coordinates are the same, because if we try doing the math.square root and we get like a large decimal number, sometimes decimals kind of mess up in Python and they don't get the same precision. So let's just return if self.x equals p.x and self.y equals p.y, because that would mean that they are at the same point, right? Okay, so let's do some comparisons now. So let's just simply print if p1 equals p2, and then we'll print if p1 is greater than p2, and we can print if p4 is less than or equal to p3, okay, and just test these out. Okay, so we get false, true, and true, and you guys are welcome to mess around with these and kind of figure those out for yourself. So I will show you, I'm not going to go through all of the methods because there's a lot of ones that you can overload, but I'll show you how you can have a look at all of the different methods. Okay, so I'm just going to pull up a web page here that has like a large list of all of the kind of built-in methods that you can override, or like, what do you call it, overload. There is a way in Python to like see all of them and print them to the screen, but I completely forget the command, so I apologize. If one of you guys knows that command, please let me know in the comments, because I've been looking for it and I can't find it. But anyways, you can see here there's a ton, like I think there's like 100 or something of built-in ones that you can use, like add, sub, mul, div, true div, floor div. You can read through here and see what they all do. Some useful ones I will mention is probably len. I probably should have talked about that one, but it's if you call the len function on something. So actually I'll show you len really quickly just because I feel like I should have talked about it. So instead of doing length here, I could have just done define underscore len underscore, and what this would have done now is if I call like len of p1, it's just going to return whatever value I have here, so math.square root. Okay, that's like a really useful one too, so I don't know why I didn't talk about that, but anyways, so I'll go back to this page for 1 second. You can see real numbers, slice can be useful if you're dealing with kind of like list objects that you're creating. Items and slices, you can go through all of these and kind of read them yourself. I'm not going to talk about all of them because I'm sure these you guys probably won't end up using very much. The ones that are very important are the ones I talked about. So yeah, so you can see built-ins, like there's something you can do with like dir built-ins to see them all. And yeah, I'll leave this link in the description in case any of you guys are interested in having a look at these, but there is some way in Python. Again, if you know that way, please let me know. Okay guys, so that's been it for this video. In the next video, I'm going to be talking about static and class methods, and then in the future video, I'm going to be talking about private and public classes in Python. So if you guys enjoyed the video, please make sure you leave a like and subscribe, and I'll see you again in the next. Hey guys, and welcome back to the 5th video in my Python objects and classes tutorial series. In today's video, I'm going to be talking about class methods, static methods, and class variables. Now, these are very important and very useful, especially if you're coding large projects with multiple different classes, and they are fairly complex, but I'm going to try my best to explain them right now. So pretty much you can see here I've already set up a class, and I've already actually coded all the methods and class variables and all the stuff we're going to deal with, and I'm just going to go through and talk about it because it just saves a bit of time and makes things a bit easier. So first of all, let's talk about class variables. Now, to create a regular variable within a class, you can see that we have something like self.name equals name, and we've been over this, we know how this works. Now, when you create a class variable, typically you do this at the top of the class, and you just simply write like a variable, just not inside of one of your methods. So you can see up here I have a list, says dogs equals, and then a list. If I wanted to have something like x, I could say like x equals 5 or x equals 5, and I could put that at the top of my class, and then to reference that you have to be inside of the class. So this sometimes is useful if you want to have variables that every object in your class is going to need to use, and you don't want to have to do like self.x equals x within your initialization, and it's just better practice to put variables that are going to be like statically used inside of the class, if that kind of makes sense. So the way that you reference these variables is the same as you would reference an attribute within your regular class. So you can see here, like I do self.name equals name to create a new variable, self.name. When I want to reference it later, I would have to type self.name, right? It's the same way to reference these class variables. So you can't, or I guess you could, but you wouldn't want to have the same name as this like in here. And if you did that, it would just overwrite this. So you'll see what I mean in just a second. But anyways, what I'm essentially doing here inside of my initialization is I'm appending every single dog object that we create into the list dogs. Now this list dogs begins to the class dog, not to the actual instance of dog. So Tim and Jim, if I reference dogs and I print that out, will be the same value. It doesn't change dogs, or like dogs is not specific to Tim and it's not specific to Jim. It's specific to the entire class for every dog object. So it's the same for all that. And XC, like 5, is going to be the same for obviously Tim and Jim and all other dog objects. I hope that kind of makes sense. We'll walk through it in just a second. Okay, so let's just first of all just print and figure out like what's the point of this class variable. Like what can we do with this? Well, first of all, the good thing about class variables is if you want to access them, you don't have to have an instance of the dog object to do so. So to see this, typically like if I wanted to call, so if I remove this class method, I remove the static method, you want to call a method on a dog object, you'd have to do the name of the dogs like Tim and then dot bark, or Tim dot I don't know, whatever else that we have, like dot add weight, whatever you want to do, okay? But in this case, we can just actually call it on the name of the class. So if I do dog dot, and then you can see it's already coming up here, dot dogs, like this, we should be able to print this to the screen. And you can see that we do end up being able to print this to the screen with a dog object and another dog object. So the main difference here with class variables is that you can call them with, you can still call, like I could still do tim.dogs, but I can also call them with the actual name of the class. And that's what makes it useful. So you don't have to have an instance to call that, what do you call it, variable, if that makes sense. And I guess that's all I'm going to explain kind of for class variables, because they're not that complicated. And if you play around with them, you should be able to figure them out. Okay, so next we're going to talk about static and class methods. Now you can see here I have at static method and at class method. These are known as decorators, and you put these above your method, like directly above them like this, if you want to indicate that they are going to be a special type of method, and that's what these two methods are. So I'll first start talking about class methods, because we kind of already have touched on it with class variables. So the way that a class method works is that you can actually call it on simply the name of the class. So you can see inside of here, my parameters, I only have one thing, and it's called CLS. It's not called self, it's called CLS. And what this means is the name of the class. So if I remove Tim and Jim, so I guess I can just comment that out like that, whatever, then what I can do is I can say dog dot, and then what do you call it, num dogs, like this, and this will actually work. And you can see that I'm not calling it on an instance or like of the dog class or like a object of dog class. I'm just simply calling it on the class. So if I do this, you can see that it gives me 0 and that works, right? Now again, you can call it on, what do you call it? Like you can call it on an instance, like if you say Tim equals dog and name Tim, I can still call it on Tim and this is still going to work fine. It's just that you don't need to do that, right? You can do it by just calling with the name. Now static methods are a little bit different. They actually don't need the class to be called. So it doesn't pass in the class, so that means that you can't reference anything within the class. So the whole point of having this class passed in when you call this method is so that you can use class variables and you can use other methods inside the class. So for example, if within numDogs I wanted to use a static method, or I wanted to call an initialization, or I wanted to do something that revolved around the dog class, I would need the class name, right? So that's why it's passed through. But with static methods, we only pass whatever parameters we want. So we don't have to have a self, we don't have to have a class, and we don't even have to have any parameters. But in this case, I'm giving one parameter, n. So I'm going to show you how this works. So I've completely removed any instances of dog in my program. There's no objects, we're not printing anything, whatever, okay? What I'm going to do now is I'm going to call bark without passing through any object or any class name, and you can see how this works. So what I have to do this is it has to know obviously where bark is, right? So it's inside the dog class, so I have to start by typing dog, but then I can type bark like this and give it a number. And you can see here I just wrote a little comment, barks end time. So if I run this, you can see we get bark, 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 bark. Now notice that with inside this bar class, I don't do anything. Like I don't touch any attributes, I don't touch any class methods, and there's actually no way for me to do that. So if I were to try to say I wanted to get the value of the length of dogs, right, with inside this static method, well, I would be unable to do that because I don't have self, right? Self is, it's not working. I don't have a class. So how am I going to be able to call a class variable or another class method? I actually can't do that. So the point of static methods is when you're just going to be using them as a function, but you want to organize them within a class. So a really good use of static methods, for example, is say you were created like a class and you called it math. Okay, in here, instead of having like an initialization and all this stuff, you just had a bunch of static methods. Now, why do you put them in this math class? Why not just create them as functions? Well, the thing is, you want to be able to import modules within Python. You guys have probably seen this before, right? You can import other files that you've created into like main files. So when you create a bunch of like math methods or whatever, what you do is you'd say class math, and then you just say like at static method, and then you define and you'd say like add like this, okay? And you say like x and x2, and then you could return x plus x2. And that way you don't have to create an instance of math. You don't have to say like m equals math, right? You can just say math.add, give it 2 values, and it will return it to you. And you can do math.subtract, and you can organize all like the functions that you wanted to use within that class. And then class methods, right, are more used for like if you want to access class variables without having to pass in an object, because it's just going to automatically pass whatever the class name is that you're giving it. I hope that that makes sense. Now these, I'll touch on these really quickly in case I didn't really talk about them. These are known as decorators. I know it's kind of a weird name, but pretty much this just denotes the fact that you are creating a class method and you are creating a static method, because otherwise it's probably going to get mad at you and tell you that you need to type in self, or you need to type in like another parameter or something like that. So by doing this, not only is it a visual representation for anyone that's reading your code, but you're also just telling Python that this is going to be a static method, this is going to be a class method. Obviously you can have as many static methods as you want, as many class methods as you want, and they're actually really useful. So anyways, I'm going to wrap up the video here. If you guys have any questions about any of this stuff, make sure you leave a comment down below. And in the next video, I'm going to be talking about public and private classes in Python. Anyways, if you guys enjoyed the video, please make sure you leave a like and subscribe, and I will see you again in the next one. Hey guys, and welcome to the 5th and final video in my Python classes and objects tutorial series. So in today's video, I'm going to be talking about public and private classes and how to import your own classes from other files into like a main file. You'll kind of see what that really means as we move along. So the first thing to talk about, I guess, would be what is the difference between public and private. So I've brought an example here. I've just kind of written this random example in Python to try to illustrate this to you. So in other programming languages, there's things known as private and public classes. Now, private classes typically can only be used within the same file or within like a certain scope, where public classes are accessed or can be accessed by everyone. So private kind of means within something, like it's not accessible outside of that, whereas public means it's accessible everywhere. Now I have just a definition I found on Google that I'm just going to read because it's the best way to kind of explain it, and I can talk about it after. So in terms of Java, and we'll talk about this in a second, public versus private class, and this is the same for most languages, means this. So public is a Java keyword which declares a member's access as public. Public members are visible to all their classes. This means that any other class can access a public field or method. Further, other classes can modify public fields unless the field is declared as final. Okay, so what does that all mean, and why did I just give you an example in Java? Well, in Python, there's actually no such thing as private or public classes. There is conventions that we use to declare like a pseudo like private or like a public class, but there's not really anything restricting us from using private classes. So hopefully I can explain this, but pretty much this first class up here is private. And what makes this private is the fact that we have one underscore at the beginning of the class name. Now in Python or in Java, for example, when you create a class, you would do like, you could do something like this, like public static class, and then that would mean that it's a public class. You could say like private class. Now in Python, we don't have those. So the way that we define this just as a convention, is you start with one underscore and then the class name. Now to create a public method or like attribute of a class, it's the same thing, you just use one underscore. So for example, you can see I have two display methods here. One is a private method as it has an underscore, and the other one is public as it doesn't have an underscore. Again, like I've said, it doesn't actually matter. Like you can still use this the regular way you'd use a method by calling dot underscore display, but by putting this underscore here, you're essentially telling other programmers and even maybe yourself later on in the future not to use this. And you're saying this is private, I don't want you to use it. Obviously, if they decide to use it, that's their decision, but it's just telling you like, don't mess with this, don't use this, it's private for a reason. And typically when you private things, that's because you don't want other classes to be able to use it and like mess with the class or do anything like that. So same thing here, when you create an entire class as private, that means everything within the class is also private. So I'm going to go over to this file now, and you can see I have one file mod and one file tutorial1. Now mod is this one that we just went through, tutorial1 is a new file. And you can see that I'm actually importing mod, so I'm importing this file. Now when I do that, what that does is imports all of the classes and functions that are within this file. So for example, if you wanted to organize your program, you would have a bunch of different files that contain a lot of different classes, and you would import them by simply typing this at the beginning of like your main script. This way you can keep everything organized, clean, and neat. And then you can see from mod, I'm importing not private. So the way that this works in terms of importing individual classes is you type the name of the Python file, in this case mod, and then the name of the class or function that you wanted to import. And in this case, I want to import not private, so I can simply do that. Now, say I remove this line, I say import from mod import not private. I'm still able to access not private, just in a different way. And you can see now this goes red. The way I would now do this is I'd say mod dot not private, because it's saying we're looking within the mod file for the class or function not private. But it's just easier to do it this way so that you don't have to type mod dot before all that stuff. Okay, so I'm just going to show you this working, I guess. I have this not private class. You can see we have two displays, and when I run it, we get hi. Now, I also want to show you the fact that although I told you that this class is private and that this method is private, that we can still actually use them. So if I simply do test._display, you can see that this now works perfectly fine, and it gives us hello. So I just felt like I had to make this video, although it's not really an important aspect in Python, just because if you guys are going to be learning different programming languages, you have to understand the difference between private and public classes. It's very difficult to illustrate within Python because there's nothing that's truly public or private, but just know that if you ever run across some classes that have underscores at the beginning of the name or underscores before method names, for example, like .init, then that means that they are typically private or want to be private at least, so you should probably not mess with them and not use them. That goes for you as well. If you are programming and you want to create stuff that you don't want people to kind of mess with, just put an underscore before the name. It's just a typical convention in Python to do that, to create a private or public class. Anyways, that's been it for this video and for the series. I hope that you guys did enjoy the series and you did learn a lot. If you did, please consider subscribing and hitting that like button, as it would mean a lot to me. Hey guys, and welcome back to another YouTube video. So in today's video, I'm going to be starting a new tutorial series on intermediate programming with Python. So that being said, a prerequisite for these videos is going to be that you know a little bit about Python, you know the basics, you know if statements, for loops, lists, so on, as I'm not going to be reteaching and touching on a lot of those aspects, which I'm going to consider trivial now. I'm going to be teaching some more advanced topics, so if you guys are interested in that, make sure you watch until the end of the series and you go through all the videos, as a lot of the stuff I'm going to do is going to add on as we keep going on videos. So something I showed in the previous video, I'm going to add on to it in the next one, and these videos are going to be a really good way to enhance your programming knowledge and to learn a lot more about Python. That being said, a lot of the stuff I'm going to show here is specific to Python and probably will not work in other programming languages. That being said, let's go ahead and get started with our first video, and this one is going to be optional parameters. Now, this is probably one of the simplest topics that I'm going to cover in this series, but I figured it would be a good starting point. So let's just go ahead and go over what a parameter is. So you should already know this, but just to catch some of you guys up, I have a function here. I've defined, I call it func. it returns x to the power of 2, and our parameter in this case would be x. Anything in this bracket is a parameter. Note you can have multiple parameters, so I can have x, y, z, and so on. Now what we want to do is we want to create something called an optional parameter. Now again, sorry, the argument here, so when I call my function, I say call equals func5. Our argument 5 is passed into the parameter x. X is used here, and then if I run my program, so I'm running it here. Oops, just have to drag my console over. It's on a different window right now. Oh, and I've accidentally opened up something else now, haven't I? 1 second, guys. Sorry about that. Okay, I have my console, which is here. It prints 25 to the screen, like expected. Okay, so now we want to create something called an optional parameter. So the whole point of an optional parameter is so that we don't always have to keep typing in parameters, especially if we have more than one that we have to type in. It can get tedious. So the way that we can do this, and it's actually really simple and it's extremely useful, and I'll show you in a different example later, is simply beside your parameter, so in this case x, just put an equal sign and then put what you want its default value to be. So in this case, I'm just going to put 1. Okay. So now what happens is if I call my function and I don't give it a value for x, it's simply going to use 1. So we can show that. So again, I'll run the program and I get 1 because 1 to the power of 2, well, is 1. And I didn't put anything in here and I didn't get an error. Now note if I get rid of this equals 1 and I try to call, we get an error because it's missing a potential argument x, right? So let's put that back, x equals 1. Now what happens if I do put something in the brackets here of my function call? So for example, I put something like 5. When I run the program now, we get 25. So if you ever put anything in your function instead of the default instead of just leaving it blank in this case, then it's going to overwrite this default parameter and it's going to make x equal to 5 instead of 1. Now you might say, well, why is this useful? I'm going to show you an example in just a second, but I want to show how you can use multiple optional parameters and how you can mix them with non-optional parameters. So let's just rewrite this function. And in this case, I'm going to take 2 parameters. I'm just going to say like word and occurrence, or let's say frequency, like this. Okay. And now all I'm going to do in this function is I'm simply going to print to the screen word multiplied by frequency, like that. Okay. And then here in my function call, my word I'm going to say is Tim and frequency 5. Now this should just print to the screen when I do this, and it does. We get Tim, 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 Tim. Now what if I wanted to make the frequency an optional parameter? So all we have to do here is I'm going to change my frequency to be a default of 1. So that means now I have a parameter that's not optional, which is word, and a parameter that is optional, frequency. So when I run the program by just putting in my needed parameter, I get Tim and just 1 time, because that's the default value of frequency. Again, we don't get an error like you might expect. And then same thing, if I want to change the frequency, so maybe I want to make the frequency 10, all I do is I type in a number for frequency, so corresponding, and then when I run the program, I get Tim and then 10 times, like that. Now what happens if I do something like this and I put 10 here instead of frequency? Well, you'll see what happens. We get 10 because 10 now is word and frequency is 1, and 10 times 1, well, is equal to 10. Okay, so now let's go to multiple optional parameters. So now I'm going to say add and frequency, and I want add to also be an optional parameter. So in this case, I'm going to say add is equal to 5, frequency is equal to 1. Okay, so what I'm going to do now is I'm just going to say word is times frequency plus add, like that. And now in this case, same thing. I'll just do a word. In this case, I'll say like, hello. So our default value for add is 5. Our default frequency for frequency is 1. So we should have 5 plus 1, which is 6 multiplied by word. So we should get hello 6 times, and we do. And now again, I can put in a value for add. So in this case, I'm going to say add is equal to 0. Frequency is still going to be 1. So now I get just 1 time to the screen, hello. So the way it works is when you have optional parameters is, say I wanted to type in a value for frequency, but I wanted to leave add as the default value. I'm not actually able to do that because of the order in which I've set these parameters. So if I wanted add to still be 5, but I wanted to change frequency, I would have to put 5 for add, and then I could put a value for frequency like 3 or something like that, okay? And again, if we show this, add is going to stay at 5, frequency is going to be 3, so we should get hello 8 times, in which we do. Now, if I wanted to change that around, and I wanted to say, okay, well, I want add to always be defaulted to a value like 5, and I'm hardly going to change that, but frequency is going to be something I change a lot when I use my function, then we would just flip these around. So we'd say frequency equals 1, add equals 5, like that. So now this is going to go to frequency, and this is going to go to add, like so. I hope that makes sense. So now I'm just going to go down, and I'm going to show some better examples to why this is kind of more useful. So I've just created this class here called car, all right? And I have, you can see a bunch of parameters. So I have 5 up here, not including self, and then just 1 here in its method called display. Now these optional parameters can be used inside of methods, as methods really are just functions that apply to a class, right? So I'll show you right now how this class kind of works. I've just created a new object called whip. It's a new car object, and we have Ford Fusion 2012 new. And these are the parameters that it takes, right? So it takes the make, the model, year, condition, and kilometers. All of these are required. I need to type these in no matter what. The next one that I have, my method, is display. And what this is going to do is simply just print out to the screen one of 2 messages. If show all is equal to true, it's going to print out everything, including the condition and the kilometers of the car. If not, it's just going to print out the make, model, and year of the car. So let's watch this run on the screen. So this car is a Ford Fusion from 2012. It is new and has 0 kilometers, like so. So you can see that this is working well. Now, what if I wanted to say, I want condition and I want kilometers to both be optional parameters? So typically when you buy a car, most people buy new cars. So I'm going to say the condition is going to be defaulted to new, and kilometers is going to be equal to 0, because if you're buying a new car, well then kilometers should be equal to 0. So only if I want to, I'm going to change that. So now same thing here. If I go like this and I run the program, we should get the same thing. So this car is a Ford Fusion from 2012. It is new and has 0 kilometers. And indeed we do. We didn't need to type in those parameters because again, they were optional. Next one I'm going to show you is down here in display. Same thing, I can set this equal to something like true. So show all equals true. And now when I call my display, it automatically shows all unless I specify otherwise by typing in false, like so. And then we get this car is a Ford Fusion from 2012. Now this is really useful if you have a lot of different parameters. It is especially useful when you're typing and working with classes, so that's why I wanted to show you this example. I hope that you guys are able to implement this in your programming. Anyways, that's been it for this video. Make sure you guys stay tuned for the next one, which should be coming out in just a few days. Hey guys, and welcome back to another YouTube video. In today's video, the second video in my intermediate Python tutorials, I'm going to be going over static and class methods. So pretty much these are just different things you can use within a class, and I'm going to explain what they do and why they're useful. So without further ado, let's go ahead and get started. So because these two things, methods, obviously a part of a class, use a class, we need to first create a class. So in this instance, I'm just going to make a class. I'm going to call it person. It is of class object. And then I'm just going to start off by making my initialization method here. Give it self. I'm also going to give it name and age. And we move to the next line. So let's just assign our variables here. Self.name equals name. And self.age is equal to age. Okay, the next method I'm going to make, this one is going to be called getPopulation. Look at this. I type self. Actually, here I'm going to type CLS, and I'm going to get into what this does in a little bit. And I'm going to return CLS.population. And now I just remembered that I actually forgot to make this up here. I'm going to make a class variable where I'm just going to say population is equal to 50, like so. Okay, one more method. This one I'm going to call define, and then is adult. And then in here, I'm just going to put age. I'm going to say return age greater than equal to 18. Okay, I'm also going to make one more method down here just to show you the difference between a bunch of these, and I'm just going to call it define display. Okay, and this one's going to take self, and that's actually all we need. We're just going to print to the screen in this one. We're going to say self.name, and then comma is, and then comma self.age, comma years old. So this should, if I did this right, it's going to say whatever this person's name is, and then their age, years old. So for me, 18 years old. So now let's create a new instance of this class down here. So I'm just going to call this one new person. I'm going to set it equal to a person whose name is Tim and whose age is 18, like so. And now I'm just going to go through this class and kind of go through what we've actually done here. So pretty much what I've started off by doing is I've created a class variable population equals 50. I've done my constructor method, which is just going to initialize my variable's name and age. And then I've created two methods in here which actually aren't done, and they're called getPopulation and isAdult. Now the name of this video is class methods and static methods. So one of this is a class method and the other one is a static method. Go ahead and guess which one you think is which. So I'm going to tell you right now, the first one is actually a class method, and this one here is a static method. And the way that we denote these in Python is by putting something called a decorator above these methods. So it's just an @ sign and then the name. So in that case, static method, or class method, in this case, static method. Now, what is a class method and what is a static method? And the best way to explain these is to use an example. So pretty much a class method means that you can call it on any instance of a class. So you don't need to have, for example, I don't know what to say. You don't have to have an object already created of that class. You can just call it on the class. So for here, for example, I've done something like new person, and it typically, if I didn't have any other any static methods or class method, I would just say like new person dot display or new person dot get population. What this class method allows us to do is do something like this. So we can do person dot get population. Now, person is simply the name of our class. It's not the name of an object of that class. So new person is an object of class person, whereas person is just the name of the class. And if I do that and I print this to the screen, so I print person dot get population, assuming I have no errors here. Oh, it says it's because I haven't put the little brackets here, my bad. Dot get population, it pops up to the screen and it gives us the value of 50. And again, we didn't have to create an object to use that method because it is a class method. I hope that makes sense. I'll try to explain it maybe one more time really quickly. Pretty much, you don't need to create an object of the class to use any methods that are decorated as class method. Now, also in class method, all that's passed to the class method is, well, the class. Because it's not actually an object, we don't need this self parameter here like we need in our initialization method and in any other regular methods that we have. We just need one variable. We can call it whatever we want. In this case, I call it CLS, which is going to store, well, what class you're getting pretty well. And then we can add any other parameters that we want. So I can add X, I can add Y, infinitely many after that. We just need to make sure that we have at least one in there, because for example, if I remove this CLS like that, it's going to say take 0 positional argument, but 1 was given, because the class name is automatically sent into this method when we call it. Okay, the next type of method is static method. And this one is similar to class method, except it can be called without using that class, I want to say. So it doesn't take a self parameter and it doesn't take a class parameter. So you don't actually need anything in here. In this case, I have age just because I want to be able to compare age, but it doesn't need any parameters. If I did something like this, it would work fine. So the way we denote that again is with the @ static method just above where the method is defined. And to use this method, I can do something like person dot is adult, and then in here, if I put something like 5, we're going to get back the value of false, which you can see here. If I do a value like 21, we get a value of true. Now, why is this useful? What's different than class method? Static method is just used when you don't need self and you don't, again, need that actual object. And it's just a good organizational way of storing a bunch of methods. So for example, if you had like, I don't know, maybe a math class that you created, and you wanted to have a few math objects, and then you wanted a bunch of static methods that were all stored under that math. So for example, when you use the math module in Python, you use math.round or math.so on. That's an example of possibly a static method or just a function within the math class. You want to organize all your static methods within that class. So you would call like whatever the class name is, math, and then dot the method, and then you give it an argument and it'll return that and work fine. I hope that kind of makes sense. It is hard to explain if you don't have like a lot of good use cases for it. Class method, it just takes the actual class and then it can access anything within the class that's public to the class. So here you see I do cls.population, and population is a variable defined up here. This static method, it can't access this population variable because it doesn't have access to the class name, right? It's not past that information. So it can only use the parameters that you pass it. It can't use any that are defined within the class. And that's really the best way I can kind of explain it to you guys. And a good way to understand how to use this and why they're useful is to use them in your own use cases. So again, static method, you can call just by calling the name of the class and then that method, given whatever parameters. It doesn't need any parameters. If I do something like this, and I'll just put like 5 greater than or equal to 18, this still works. You don't need any parameters, whereas a class method, you need one parameter at least at minimum, which is going to be that class name, and it has access to anything within the class. So any variables you define, or other static methods within this class method, you could call another static method, and so on. So yeah, I hope that makes sense to you guys. It is kind of hard to explain the static and class methods, but they are really useful, especially if you're trying to organize things. And when you get further on with object-oriented programming in Python, you definitely notice that you will use these a lot. Anyways, that's been it for this video. Please make sure you guys leave a like on the video and subscribe, and I will see you again in the next one. Hey guys, and welcome back to another YouTube video. In today's video, this is the third video in our intermediate Python tutorials, and I'm going to be going over the map function. So pretty much the map function is an extremely useful tool that allows us to, well, apply a function to a list and then create a new list with those new values. And you'll understand what I mean as I go through an example here. So before I even start using the map function, I want to just present us with a problem that the map function can solve, and this is kind of the best way to understand it. So I'm going to create a list. I'm just going to call it li of integers up to 10 like this, so 9 and 10. Okay, and now I'm going to create a function, and I'm just going to call it func, and it's simply going to take one parameter x, and all we're going to do is we're going to return x to the exponent x. Very simple. Okay. Now, what this problem is, it's very simple. I want to be able to apply this function x to every value in the list here, so 1 to 10, and then have that stored in a new list. So intuitively, the way that you would want to do this, or the way that you would try to do this at least, is you'd make something like new list is equal to this. You'd write a for loop, you'd say for x in li, and then you'd say new list dot append, and then you would put, well, func and x like that. And then if you printed out your new list, you would get that value. I don't know why print is showing up in a different color now, but anyways, and there we go. So we get 1, 4, 27, and so on and so forth. Okay, so now what we want to do is use the map function to do this faster. So this is a very valid way to do this. This works fine, but I can actually shorten all 4 of these lines into one by using the map function. So let's go ahead and do that now. So I'm going to start by typing, actually we're just going to print because I want to print first starting with. I'm going to do list like that, and I'll tell you why in a second. I'm going to write my map function like so. And now your map function takes 2 arguments. So it takes a function and it takes a list. So let's give it our function, which in this case is going to be called func. And then let's give it our list. So I actually don't need these double brackets here, excuse me. let's give it our list, which in this case is li. So let's talk about what this really is doing right now. So the map function takes a function, which is func, so the name of our function, and it takes a list, which is li. What it's going to do is it's going to apply this function to every element in the list. And we can watch this happen. We run the program, and you see we get the exact same value as we did before. And that's extremely useful in Python, because there's a lot of times you want to apply a function or even possibly multiple functions onto onto a list or every element of the list, and you don't want to have to type out that whole for loop. Yes, you can do that, it works fine, but the map function is just a shortcut to be able to do that. So let me just show you now maybe a few other examples that we can use. So like using this map function, there's another way that we can create this, and it's totally preference which one you want to use. I like using map just because it's kind of cool. You can also use something called list comprehension, and this is something I would have shown in some of my previous Python tutorials, like from way back, like years ago on my channel, but I'll go over it quickly now. And the way that this works is you can do the same thing. So you can say func x for x in li. Now this is actually going to give us the exact same value as what we have up here with this map function li, for example, because what we're going to do is we're going to say we're going to take this right here, so whatever this expression is, and we're going to do it for every value of x in the list. So that's exactly what this map function does, and it's just going to turn it into a list because we put our square brackets here. So if I print this out, see we get again the same value, and that's how list comprehension works. Now for list comprehension, you can also add like an expression in here. So I can do something like if, let's say x modulus 2 equals 0, and now it's only going to do this or put this into the list if x is divisible by 2. Syntax error. Oh, I forgot my square bracket here, my bad. Don't know how I even got rid of that. Let's run that. Oh, it's because that is why. All right, excuse me on that. Okay, so now we get 4, 2, 5, 6. So it's only doing it for the even numbers of x. So yeah, those are two really cool ways to kind of change a list or modify them, apply a function to them in Python. Say, obviously, you might want to use a function that's more advanced than this. This is just for a basic example. And if you wanted to apply maybe 2 functions to it, you could have x be changed here, and then you could return like function 2 of x to the x here, and then that would put that value obviously in the map. So again, map takes 2 parameters, a function and a list, and it will apply the function to every value in that list. I hope this has been useful for you guys. If you did enjoy the video, please make sure you leave a like and subscribe. And I'm going to be moving on to some more complicated and other examples using map and other functions in the next video. So make sure you stay tuned for that. Hey guys, and welcome to the 4th video in my intermediate Python tutorials. And in today's video, I'm going to be going over the filter function. So this one is very similar to what I did in the last video, which is the map function, but obviously it has a few differences. But the filter and map function are nice to learn back to back because they can be used together, and a lot of people do use them together when they're making programs. So I'm just going to go ahead and start off by typing out 2 functions here that we're going to be using in our examples. So I'm just going to make one function called add7, which is simply going to return 7, and I'm going to make another one which is called isOdd, and it's just going to return if the number is an odd number. So the way we do that again is x modulus 2 does not equal 0, like that. Okay, pretty straightforward. Now I'm just going to make a new list. In this case, I'm just going to go 1, 2, 3, 4, 5, 6, 7, 8, and 9, and then we'll even add a 10 in there. And now I'm going to go over what the filter function does. So I want to assign our a new variable here, create a new one. I'm just going to call this b, and I'm going to make it equal to list filter, which is the name of our function, just like this. And now filter function actually takes the same arguments that our map function did in the last video. It takes a function and it takes an iterable list. So it can take a string as well, but typically we just pass it a list, something that's iterable and that you can go over. So what I'm going to put in here for our first function is I'm going to put isOdd, and then I'm going to give a list a. Now the way filter function works is if this value, so it's gonna do the same thing the map function does. It's gonna pass every element in our iterable item, in this case the list, to the function is odd. So it's gonna start with 1. It's gonna pass 1 in there. It's gonna say 1 modulus 2 does not equal 0, which is true. So it's gonna give us a true value, and then that's gonna be added to the B list because this function returned a true value. Now say we put 2 in here, and we go and we say 2 is x, 2 modulus 2. Well, that does equal 0, so we get a false value returned here. Now 2 is not added to the list. This is essentially filtering out elements based on a predefined function. So obviously you can make your function that you want to check a lot longer and a lot more extensive, so you're filtering out more items, but this is extremely useful when you're solving problems. So rather than going through a for loop and checking every single item, like we might have done with the map function to add things into a list, we can just simply call filter, give it the function that we want to filter based on, and then a list, and it's going to return that new list. So let's just go ahead and run the program here and make sure that everything's working fine. So I'm just going to print out A to the screen, and I'm going to print out B, and we can see that B has essentially filtered out all of the elements that were even. So we get 2, 6, 8, 10, they are all gone. So now I want to show you how we can implement this with our map function. Why is this useful? What can we use the map function for? So I'm making another list here, and I'm going to call it C, and this time I'm just going to do list map, and then inside a map I'm going to do filter, but before filter I'm just going to apply another function. So in this case I'm going to do add 7, and then in filter here I'm actually just going to change this to B because I'm going to type the same thing. Now let's go over what I just did here. So essentially what's going to happen now is we're using the map function, which if you don't know, go back and watch the previous video, and we're going to apply this new list B, which has been filtered. So we filtered out this original list. Now we have 1, 3, 5, 7, 9 so far, and based on that list we're going to add 7 to every element in that list. Now again, if you wanted to save a line, I could just get rid of B here, and I could simply paste that in here, removing list like that, and this would work fine. So let's go ahead and see what actually happens here. Again, we're just taking this new filtered list, and now we're applying another function to it, in this case add 7. So let's make sure that this is indeed working. I haven't made a mistake here. So we'll print A again, and I will print C, and you can see that we do indeed get that. So our 1 adds 7, we get 8, our 3 adds 7, we get 10, 5, 7, and so on. You can see how this works. Now these are extremely straightforward examples, but if you're doing a list and for example you wanted to filter out any elements that contained a certain digit or that met a certain criteria, then you could create a more advanced filter function to filter based off of that had a whole bunch of criteria, and then it's going to return a true or false value. So I'll show you here. If I do something like just return true, and I don't return a condition per se, then every element in my list is going to be sent through because nothing's going to be filtered out. So again, if I print C here, all of our elements are here. So we have 10 elements because we're always returning true. Same thing if I always return false, then none of our elements are going to be printed because, well, it's always false. So the way to think about it is, I'll uncomment out this for a second, is what this filter function does is it's going to apply a function that gives us a true or false value to every element in the list. If when that element is applied to that function we get a true value, then it's going to be created in that new list, which filter returns to us like that. Now again, yeah, this is really useful for solving problems, and I just want to show you what happens if I do something like return 1, and I'll print C to the screen here. You can see we get every element out of here. So pretty much the way is, in Python, something is said to be true as long as it's not 0 if it's a number. So like if I pass something like high, well, if you say is high true, technically high is true. Again, if I print C, we're still going to get every element. Although I didn't pass the value true, high technically evaluates to a true value in Python. The only thing that's not going to evaluate to a true value is something like 0. So now if I print C, you can see we get an empty list. Just wanted to add that in at the end there, teach you something you might not have known there. So anyways, that's been it for the filter function. In the next video, I'm going to tie these all together with something called lambdas, and what they look like is that. You can see it highlights here as a keyword, and pretty much this is a kind of function that we can use so we don't have to keep creating all these other ones at the beginning of our program, and they're extremely useful and they're really cool. So make sure you guys stay tuned for the next video, and I'm going to be explaining how we can use those with lists, maps, and on their own. Anyways, if you guys enjoyed, please make sure you leave a like and subscribe, and I will see you again in the next video. Hey guys, and welcome back to the 5th video in my advanced Python programming tutorials. In today's video, I'm going to be going over Lambda. I think that's the way you say it, at least. Excuse me if I'm going to say it wrong this whole video, which pretty much stands for an anonymous function. Now, these are extremely useful, and they don't take up very much space in your program, which is really good, and I'm going to show you exactly how they work and what they do. So I first want to just start off by defining a regular function. Again, this is one example I've been using a lot. I'm just going to say define func, say like return x plus 5. That's what our function is going to do. It's simply going to add 5 to the number, whatever we give it. So right, if I print something like func of 2, we should get 7. There we go, and we get 7 to the screen. Now, for an extremely basic function like this, oftentimes you don't want to have to write a function definition and take up like 2 lines of code like this. It's easier to write it in a different way, and it looks like more smooth, maybe more slick in your program, and I'm going to show you how to do that. So that's one way that we can do it, by making a function like that. Another way, and this is using Lambda, is to do something like this. So the name of our function, I'm going to say func, say func2 is equal to, and then we're going to type our keyword Lambda like this. You can see it highlights in orange, just like our definition key here for our function. We're going to give it a parameter or multiple parameters. I think you can use multiple parameters at least. And then we're simply going to state what it returns. So the way this works is you type Lambda, the parameter, or multiple parameters, which we're going to try in a second, a colon, and then whatever value you're going to return. So the thing with Lambda is it's used when you have one one expression in your function. So something like this. So again, I could do return x plus 5 over 4. Like I could do a whole expression. As long as that expression fits on one line, then that's perfectly fine to return. And I'll show you how this works. So if I say print func2, and I just give it a number like 9, there we go. We get 14 and 7. So it works just like a regular function, and it kind of just looks like a variable. So we're saying function2 is equal to an anonymous function. That's what Lambda stands for, anonymous function, with the parameter x, and it's simply going to return x plus 5. Now these are really useful for using with the map function and the filter function, which I'm going to show you later, so you don't have to constantly create a new function up at the top of your program. And you can also use them inside of other functions. So let's start by doing that. We're going to say func2. I'm simply just going to copy it and paste it into my other function, and then I'm going to return func2 of x plus 85. Let's try that. And now if I call my function, we can see that we get 92 like so. Now this again is really useful because you want to oftentimes create another function or use something multiple times within a function, but you might not want to like write a new one up here like func2. You just want it to be only used within that function, and in that case you would use Lambda, as it keeps it all contained, and at the top of your function you can write a bunch of other mini functions that you can then use multiple times within your program. It's hard to see the use case for it in small examples like this, but they are extremely useful, especially in like more in-depth code, longer code. So now I'm going to show you with multiple parameters. So I believe, and I'm not sure, but we'll see if we can do this. So we're going to try, I'm going to make func3 is equal to lambda x, y, and then we're simply just going to return x plus y. So let's just see if we call func3, and let's give it a value like 5 and 5, and we'll print that to the screen as well. Let's see. There we go. So that does work as well. So you can give this an infinite amount of parameters, just like you'd be able to do something like this in our function. And you can also, I believe, do optional parameters. So I can do something like y equals 4. And then if I put 5, we should be getting a value of 9 here. And there we are. So you can use optional parameters. You can do everything that you'd be able to do with a regular function, except you can just return one expression like that. Okay, so let's now use this with our map function and our filter function. So in earlier videos, I used the map function, and to recall what that does, I'm just going to create a list quickly. Say a equals 1, 2, 3, 4, 5, 6, 7, 8, 9. Oops, 9 and 10, like that. And I'm now just going to say, let's say, new list equals list map. And then we're going to have a function. In this case, I'll just write func for now. And then we give it a list, right? Like a. So what I want to do now is I actually want to just put a function in here without having to create a new one up here. Like I don't want to define func. So this is a perfect example of where we can use lambda. We don't even have to make a variable like equal to the function anymore. We can just type lambda right in here. So lambda, and then we'll say x, and we'll say x plus 5. So now we again should simply just be adding 5 to each of the elements in A, and then print. So we'll just print new list to the screen now, and see if this is indeed working. And there you go. We can see we started at 1, so 6 all the way up to 15, like so. Again, that saves us now having to make a function at the top of our program that we're only going to use for one specific case, which is this map function. And again, we also don't have to create like func equals lambda up here, but you can if you want. If you're going to use it in a different case, you can just type it right in the same line as your map function, or as your with your filter function. So this works the same with the filter function. I'll do filter like so. It's going to be our function, I guess. Yeah, I believe this works with the filter function. Oh, yes, it does. Okay. So what this is going to do now is we're just going to return x modulus 2 equals 0. So again, now given x, we're going to see if it's divisible by 2. If it is, we return true. We add that element to the list. Otherwise, we will not. We check now. We get 2, 4, 6, 8, 10, and there we go. So you can see why lambda is extremely useful. It's really cool, especially if you want to create a lot of mini functions, or you want to create functions within functions to keep everything nice and organized. And it's a nice trick to be able to use in Python. So with that being said, that's been the end of the video today. If you guys did enjoy and you did learn something, please make sure you leave a like and subscribe to the channel, and I will see you again in the next tutorial. Hey guys, and welcome back to another YouTube video. So this is the 6th video in my Python intermediate tutorials, and in today's video I'm going to be talking about collections, and more specifically counter, which is a part of the collections module. So what is the collections module? Pretty much it's a built-in module in Python that's going to allow us to have different kinds of data types so that we can store information, sort through information, and do some cool things. These are extremely useful. The second I found out about them, I started using them all the time, because a lot of the stuff that would usually take you a few for loops or a few lines, you can do in 1 line or 2 lines with these new collection types. So I just want to first off and start by saying that in Python, it has something called containers. So containers are pretty much a data type or an object that's going to store multiple objects. So it's like a container, like a list is an example of a container, a set is an example of a container, a dictionary, and a tuple as well. These are the 4 main ones with Python, and in the collections module, they introduce 5 new ones, which are similar to these, but they all have their own methods and cool things you can do with them. So the one I'm going to talk about today is counter, but the other ones are listed here: Deque, named tuple, ordered dictionary, and default dictionary. You can kind of get an idea of what some of them are by reading them, but let's get into the counter one for right now. Okay, so first thing we need to do whenever we're using collections is we need to import it. So this first line up here is unnecessary, but I just did that to show you. And we're going to import counter from collections so we can reference it directly without doing collections.counter. Okay, so I'm just going to start by creating a new counter. So I'm going to say C equals counter. Now, when you create a new counter, what goes in here as the arguments can just be any I want to say like collection data type or any container. So for example, you put a dictionary, set, tuple, you can put a list, and you can also do something which is weird with these keywords. I'll show you that in a second. So for example, I could create a counter like this by just putting a string, and it's going to count all the letters in the string and return them to me, and I'll show you that in a second. I could create another counter where in here I have a list. So it's like A, B, C, and we'll just do one more, C, like that. And I could put a dictionary, so I could do something like this. I'll just make a small one so we don't take too long. Oops, like that, B2. And you can also put these keywords, which is what I was talking about. And it's kind of cool because you don't have to type out or like use a for loop to create a list like this. I could do something like, oops, cats equals 4, dogs equals 7, like that. And I can continue on with keywords, and I don't have to actually put the quotation marks around these. I can just name them exactly what they are. So let's just go ahead and start printing some of these to the screen to see what actually happens when I create a new counter object, and what does that look like in Python. So we'll just print all these, just give us an idea of what they really are. Okay, so there we go. So it says we have a counter object. It is its own object. It's not like a list or dictionary. It's its own thing. It says A, we have 2. I believe this is an L, we have 2, G1, D1. And then same thing here, A, B, C, dogs, cats. So you can see it looks like a dictionary in terms of it has a key value pair, but it works a little bit differently. So now if we want to reference a specific item, which is typically what we want to do from our counter, we can just put the square brackets and put the name of that item or the key. So in this case, I'm going to put cats, and you can see now we get 4, as that's a direct value related to cats. And something cool with this counter, and a reason why I use it specifically, is I can put an item in here that doesn't exist in the counter. It doesn't have a key set, and that will actually not return an error like might happen with the dictionary. So for example, I put a key like, I don't know, let's see, pet. Then it just gives me 0 instead of returning an error. So if I were to do this with a dictionary, let's say D equals like, I don't know, cat 2, and then I tried to do D pet like this and get the value, we get an error because the key pet does not exist in our dictionary. Okay, so let's move on to some more methods and why these are extremely useful. So we can see here one of the methods that we can use is we can actually just list all of the elements out, and this is useful if you want to like sum something. So let's just say list and then c.elements like that. And what this is going to do, if I print it to the screen, is it's simply just going to print out all of the elements in our counter. So we say cats, 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 dogs, 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 like that. And since here we said cats equals 4, dogs equals 7, then it prints it out like in a made list with that many indices, which can sometimes be useful. I'm just going to change this to be named D so that we can now print out the one like this with A1, B2. And you can see we get A, B, B, like so. If I do the same thing, I'll change this to E. We print it again. Then again, we get another list that just has all of the elements in it. So that's one useful method, c.elements. Another useful element, or method, sorry, is most common. Now this one by far is probably one of the most useful ones. And you can simply just type this. So the name of your counter object, and then dot most underscore common, and then in the brackets here, you're gonna put how many elements you want. So if you wanted to find the number 1 most common element, you'd put 1. If you wanted to find 2, you put 2. So let's print this to the screen and see what we get. So, and you can see we get the most common elements are A and C, and it actually also returns us a count of those elements as well. So it says A, which occurs 2 times, and C, which occurs 2 times, and that's returned to us in a tuple, or tuple, however you want to call it, which is really useful. Okay, so now another one we're going to use, I'm just going to copy something I have open here just to save us a bit of time in terms of creating counter objects. So I'm going to delete all this, and I'm going to make one counter, which is equal to A or C, and then I'm just making a list, which is D, and it's A, B, B, C, like this. Okay, so you can actually do something as well with these counter objects. You can subtract counts from them from using other iterable objects, or you can add like the count of objects to them. So one method is called subtract, like this, and it does pretty much exactly what it says. So we're going to take this counter object. This has to be called on a counter object, by the way. It says with these counts, and we're going to subtract whatever the counts are from D of similar items. So we have 1A, 2 B's, and a C. So if I do this, and I print this to the screen, we should, let's do a quick calculation here, get A is equal to 3, B is equal to 0, C is 0, and D is still -2. None. Oh, it's because I didn't convert this to a list. Sorry about that. Let's do this maybe. None type object is not iterable. Alright, just give me a second, guys. There is a way that we can. Oh, it's because we're doing this. So c.subtract doesn't actually return anything. We just have to print C after we call that method. Okay, so there we go. And we do get what we had there. Okay, so yeah, C is -1 because 0 minus 1 gives us -1. And there we are. So it is working exactly like it should be. Okay, the next one is update. So I'll run this now, c.update, and this is the exact same thing as subtract, except it's simply just going to add the counts of whatever iterable object you give it. So in this case, I'm going to put D. And note here that I'm using a list, but I could be using like a dictionary, could be using another counter object, I could be using a set, a tuple, whatever you want to say there. It's still going to like work for update. So let's see here, and oh, I didn't print C. Let's do that. And there we go. So we went originally, so we changed our counter by subtracting, and then we just updated it by adding, so it should be the same as our original counter, which it is. Okay, so that's working well. The next one that I'm going to talk about now is clear. This one does pretty much what it states. So if you see here, we do c.clear, and then I'll print C to the screen. And all it's going to do is just remove all of the counts. So we now have an empty counter object that we can use to count something else, to add to subtract, so on. Okay, so that's it for the methods pretty well. There's one or two more, but I don't find them very useful, so I'm not going to show them right now. But there's something cool that you can do with these counters, and there's a few operations that are applied to them. So you can actually add counters using the plus sign. So you do like this, C plus D. You can do C minus D. You can subtract them, you can add them. And then the two operations which you wouldn't necessarily know intuitively is you can do something called intersection and union of counters. So let's just first show what happens when I add these two counters together. So C plus D, oops, and this needs to be a counter now, because this isn't going to work if it's a list. There we go, so make that a counter, and I'll print C minus D, and then we'll print another one after that. So if I add them and subtract them, you can see that it works like this. So when I add them, we get the counts added up like this, and when we subtract, we get it subtracted as well. Now, some of you might be wondering here why we don't have the elements B, C, or D shown in our counter, and that is because if the element count is less than 0 or equal to 0, it's not going to be shown in our counter when we do these operations by adding and subtracting. So because of that, you can see like the why that happened, because B is 2 here, and we have 2 B's, so that created 0, C is already 0, and D was -2. So when we subtracted, it's not going to bother showing those in our new counter. Now, the next operations that we can do is something called union and intersection. So the first one, I guess I'm going to show is intersection. And the way that you can think of intersection is like the minimum elements in each of the lists. So we're going to have C intersecting with D. In this case, we should get A equals 1, B equals 2, and C equals 0, D equals -2. So let's just see if this works. And there we go, we get B is 2, A is 1, and we're not showing the other ones again because they like they're equal to 0 or less than 0, so they're not being shown. And this is the and sign, is what I'm doing to do this intersection between the counters. The next one that we can do is called union, and this one you can think of as the max elements shown in each of our counters. So it's going to take A equal to 4 because that's our max. It's going to take B equal to 2 because that's the max between here. C equals 1. And then again, it shouldn't be showing us D because that's -2. So there we go. We get A is 4, B is 2, and C is 1. So this is pretty much going through, looking at the counters, and just taking the maximum element, whereas before, when we did our intersection, it's taking the minimum shown of all those elements. So that has pretty much been it for this video and counters from the collections. There's a few things that you can do with them, as well as a few other methods. If you want to learn about those, just look up collections, counter, Python. You can read through the documentation, and you can look at some more examples that I didn't show here specifically. Other than that, I hope you guys enjoyed the video. If you did, please make sure you leave a like and subscribe, and I will see you again in the next one. Hey guys, and welcome back to another video. In today's video, I am going to be continuing with my intermediate Python tutorials, and we're going to be moving on to something called named tuple, or tuple, whichever one you prefer, which is a part of the collections data type, or module, class, whatever you want to call it. So in the previous video, I introduced you to kind of to the collections module in Python, and I showed you counter, which is really useful. Today I'm going to be showing you named tuple, which is another data type or class, whatever you want to call it, within that module. And pretty much this is the description of it. I'm just going to read it right off of the documentation here because it explains it better than I could come up with. So let's go ahead and do that. Named tuples assign meaning to each position in a tuple and allow for more readable self-documenting code. They can be used wherever regular tuples are used, and they add the ability to access field by names instead of position index. So you should understand a bit of that, but if you don't, obviously I'm going to go through exactly how this works and how we can use it. So the main difference between a named tuple and a regular tuple is you can access things by element, and it's just a lot nicer to read in your program. So they might come in handy if you're coding large things or if other people are going to be reading your code. So let's go ahead and first off start by importing collections like this, and then we're just going to from collections we are going to import named tuple. Oops. Okay, so now that we've done that, what we're going to do down here is I'm just going to create something that I'm kind of going to go and show you what exactly this does. So I'm just making a new variable point. I'm going to set it equal to a named tuple with name point, and then it's going to have fields X, Y, and Z, and I'm going to show how this works. Okay, so what I've just done here is I've said point is going to be equal to a new object, which is a named tuple or tuple. The name of the tuple is point, and it has fields X, Y, and Z. Now, this looks a little weird. You might be confused. What we're going to do whenever we want to create a new point that is in the form of this named tuple is we're going to treat this like a class, and we're going to do something like this. We're going to say new p is equal to point, and then we need to give our parameters, so in this, or arguments, so in this case an x, y, and z, so I'm just going to say 3, 4, 5, like so. Now, you might be looking at this to be x, y, z. This is one string. This might be the name of one parameter. The way that this works, and it's actually really useful, is that it's automatically going to break up this string x, y, z into 3 different parameters. So I'm just going to print this to the screen to kind of show what I mean here. So I'm just going to print new p, and you can see that we have x equals 3, y equals 4, and z equals 5. Now what happened here is when we gave an iterable object as our different parameters, you can see that we get, it just breaks it up by space. So I do something like gy, and then I run this here. You can see now gy is equal to 4. I can add another one on the end, like h. Oh, and then we're just missing one argument, so I'd have to add another number in here so that we get h is equal to 8. I can also do the same thing with a list per se. So if I have a list and I want all of these to be the names of like something like x, y, and let's just do like l, and we run this, takes 4. Okay, I keep forgetting to fix this. Anyways, you can see we get x, y, l. Any iterable object will work. I'm not exactly sure how a dictionary works, but I'm pretty sure it takes the keys. So let's just go ahead and have a look at this one. We'll just say x, 0, y, 0, z, 0. Now this might crash, but I just want to see if this actually works. Oh yeah, it does work. So it just takes the key names, ignores the values, so we get x, y, and z. And then I guess you can do the same thing with any other iterable object, but those are the only ones I can think of that are useful right now. So anyways, when we want to create a new tuple or a new named tuple, what we're going to do is just say whatever the name of that's going to be is equal to point, which we've set up here to be this type with these like parameters, attributes, and then we just give it those parameters. Now, there's a lot of really cool things and methods that go along with this named tuple, and that's why it's useful. So first of all, you can do something like this: new p.x, new p.y, and new p.z, like so. And now what this is going to do is it's going to allow us to access each element by its index, so by its name, which you can't do with a regular tuple. So you see we get 3, 4, 5 to the screen like that. And we can use the same operations that we use on basic tuples. So I can do something like new p0 like that. And oops, my mod thing just popped up somewhere else. And you can see we get 3 because that's the first one that shows up. We can also print this so it looks in the form of a dictionary. So I'm just going to say underscore is dict like this. I believe this is the method, or not is, as, sorry. And when we print this to the screen, you'll see what shows up. and it says an order dictionary, and it gives us a list, and then it gives us all the tuples within. So x3, y4, z5, kind of a different form if you wanted to play with that and use that. We can also print out all the field names, which is useful. Say you forget the fields, you can do new p dot and then fields, and it gives us a tuple with those fields in it. The next method that we can use is the replace method. This one's pretty straightforward, but all you have to do simply is type, I don't know, let's see here, new p dot underscore replace, and just make sure you guys remember to put these underscore here. All the methods pretty well for this require an underscore. Don't ask me why, but that's the way they're written. They need an underscore. And then you're going to put a key name. So say I want to replace y, I can say equals to 6. So we'll run that. And then if I just go here and just to show you that we did change that, let's print new p like that. And you can see, oh, y did not change to 6. That's weird. Let me just see if I print this to the screen, if this is going to change. It should have worked. New p like so. Let's check, and y is not changing to 4. That's very interesting why that is not working. Okay, so I just had a quick look at the documentation, and the reason why I can't do what I'm trying to do here with this replace is because this replace doesn't actually change the tuple object. It's not capable of doing that. So what we have to do is we have to assign a new variable or a new object to that. So pretty much what this does is it returns a new named tuple, which we then can set to, in this case, the same name. It's going to do the same thing that we tried to do, except we just need this new p equals to. Hope that makes sense. So now if I run the program, we can see that finally this is working. We are changing x, or I was trying to change y before, but I switched it to x to see if there was an issue there. And you can see that that is working like that. So anyways, that is pretty much it. I'll show one last method here if you guys are still watching. So pretty much we can do something like a new point. So say p2 is equal to point dot underscore make. And then I'm just going to put a little list in here. I'll just say like A, B, C. Now what this is going to do is a similar thing to up here, is it's just going to automatically grab all of these elements in our list and assign them to x, y, z accordingly in our named tuple. So you can see if I print p to the screen now, and we give it a run, no errors, everything's working fine. X equals A, Y equals B, Z equals C. Hey guys, and welcome back to the 8th video in my intermediate Python tutorials. In today's video, I'm going to be continuing with the collections module, and we're going to be talking about a data type known as the Deque. So yes, this says Deque right here, and the title of the thing is spelt Deque, but the way that you pronounce it is Deque. And I just found that from reading the documentation. Otherwise, I was going to go through this whole video saying Deque. Anyways, Deque is the proper way to say this word. So if I do end up saying Deque throughout the video, please don't leave an angry comment about it. I don't know why, I just keep saying it. But anyways, Deque is the proper way. So why would we want to use a Deque over a typical list? So pretty much it kind of looks the same as a list, and I'll show you in just a second. But the reason why we'd use a Deque is because it's faster in terms of adding elements to the end and the beginning of a list. So rather than using a list, you want to use a Deque because it's going to be faster. Whereas if you're trying to randomly access elements within a container, so a list, then you're going to want to use a list over a Deque. And if that's confusing, don't worry, I'll kind of show you how we, as we go through. So let's start by creating a Deque and see how that works. So I'm just going to say D, and it's going to be stand for our Deque is going to be equal to a Deque. And then this just takes an iterable argument. So in this case, I'm going to type in hello, but I could give it something like a list, a dictionary, so on. So anyways, D equals Deque, hello. Now if I run the program, press F5, and I simply print D to the screen here, you can see that we get Deque, and then H-E-L-L-O. It just split that up into what looks like a list, but it's actually a Deque. Okay, so now let's go through a few methods that we can use on this. So obviously we can use something like append. So we can append an element to the end. So I can append something like 4. I can append another element, do something like 5. And if we run this and then print it again, you can, oops, didn't mean to do that. Then you can see we get hello, and then 4, 5, so on. So you can append. A nice thing is you can actually append to the beginning of the list as well. So I can say append left,
instead of just regular append. And now you can see when we run the program and we print D, don't know why that didn't work. Let's see here. We get 5 and then hello 4. So that's a nice method as well. We can do the same thing with popping, which is removing elements from the deck. So I can do pop in this case, and I'm not going to do 4 in here, so I can do d.pop. And then I can also do d.pop left. And what pop left is going to do is it's simply going to remove the first element in our deck rather than the last. So pop, this works on lists as well. And dictionaries and stuff, you can remove the last element or whatever index you type in here. So like 5, 2, whatever, that's the one it's going to remove. Pop left simply removes the first one. So I'll do this and then print D, and you can see that we are left with ELL because we removed O and we removed the H. Okay, another method that we can use is clear. This one is simply going to remove everything from the deck. So that's pretty standard. If I print D again, then you can see that we have an empty deck now. Okay, the next few that I'm going to talk about here, I believe you can use on some other containers in Python, but they do work on this deck as well. So let's go through it. So now that we already cleared our deck, let's just go ahead and add some more things to it. So what we can do is we can do something called extend. And what extend is going to do is it takes an iterable argument, which means anything that's a container, so like a list, a string, something like that. And it's going to put it at the end of our list. So if I have something like 4, 5, 6, and I run the program, and I print D, you can see we get 4, 5, 6 at the end of our list. Now, to show you what happens if you already have something in, I called it a list, but our deck, is if I extend again, I'll extend something like, so we can see it better, hello, then what we get is print D, we get 4, 5, 6, and then hello. So this is a way to add multiple things into your deck. So again, if I make like a list and I go like 1, 2, 3, this is going to work as well. So we should get 4, 5, 6, 1, 2, 3, and print D, and there we go. We get that as well. So if you ever don't want to run through like a for loop to add an entire list into a deck, then you can simply use extend. Extend also works really nicely with extend left, which is going to add to the beginning of our list. So now we have a list of 4, 5, 6, 1, 2, 3. Let's see what happens if we extend the word hey to the left side of the list. So I'm going to print that, and you can see we get YEH 4, 5, 6, 1, 2, 3. You might say, well, why didn't we just get H? Well, it's because we're actually extending to the left, so we're going to add this in the reverse order. And that should make sense because if you're extending this first, and then you extend this, and then you extend this, Y should be the first element on the left side of our deck, like that. Okay, so now we're going to use a few other methods. So this one is probably the most useful one that the deck has, and the reason why you would use it, especially if you're going to be dealing with things at the beginning and the end specifically. And it is known as rotate. So what this does is it takes a integer in here at either positive or negative. If you put a positive integer in here, it's going to rotate all of the elements by that amount to the right. Otherwise, it's going to, if you put a negative element in there, rotate everything to the left. So just see what happens if I put -1 in here to rotate to the left, and then we'll print down here. Sorry, it's at the bottom of the screen right now. And you can see that we went from this one, which was the last D or whatever when I printed it, and now we've rotated everything over. So 3's moved over to the position of 2, and when we get all the way over to here, we've switched E and Y. So E's moved over here, and Y has been rotated back to the end of the list. Now you can actually rotate with other numbers as well, so rotate by 2, and then you can see if I print D down here, that we get it rotated 2 elements over now. And this is really useful when you're trying to solve certain problems to be able to use this rotate. Again, you can do the same thing with positive. So if I just rotate it by 1 now, and I simply print D, you can see that now we've rotated to the right side. So 3, which was originally here, has now been moved up to the beginning of the list. Okay, so now that we've talked about that, there's one last really useful thing that I left out on purpose because I wanted to show now that we can do with these decks. So when we initiate our deck here, we give it an iterable object. We don't have to give it anything. It'll just create a blank one if we do that. But there's something that it has called maxlen. Now, if I do something like maxlen 5, and I'm just going to remove all this, and I'll show you how this works. So I have a maxlen of 5, and I have a string that has 5 characters in it. if I try to add something to my deck here, so I'm going to print it here just so it saves us some time. I'm going to print D, and then I'm going to go d.append, let's do 1, and then print D again. Let's just watch what happens. So you can see we have a max len of 5, we start with hello, and then when we add 1, H is actually removed from our deck. Now the reason that happens is because when we set this max length, when we start adding things into the list, it needs to remove something to maintain that attribute of a maximum length of 5. So it removes the first element from our deck. And that's really useful as well if you're solving problems, because then you don't have to deal with removing things every time you add something to the end, or removing like a slice of, for example, a list if you're going to be adding more than one thing. So if I extend like something like, let's see here, 1, 2, 3, now we should see that H, E, and L should all be removed, and we should have L, O, 1, 2, 3. So let's try it. And there we go. We get hello, and we get L, O, 1, 2, 3. And we didn't have to deal with figuring out how many elements we need to take from the left side, from the right side, because of this max len. Now, just to note, you can't change this max len by doing something like d.maxlen equals 5. It's, or I guess we'll do like 6 because it's already 5. You can only access what the max len is by just doing simply this, print d.maxlen, and this should just give us 5. And it does. But if I try to do what I was showing you there, so d.maxlen equals 5, you'll see the error that comes up. And it says this attribute of maxlen is not writable. So we can't actually change it after we've initiated that value. So anyways, that's pretty much been it for Deque within collections. This is really useful, and you might not see a use for it now, but if you start solving some more advanced problems, using this Deque will make your life a lot easier with those methods that I went through. And I'm going to copy all of them down into like a little paste bin thing, so you can click the link in the description there if you want to see all of them in a list, so you don't have to specifically memorize that. Other than that, you can always just go to the documentation and have a look. If you just search up like Deque collections Python, it goes through what all of these do. Again, I forgot to talk about reverse, but it's pretty straightforward. You can use reverse, and if you're followed up to here, you probably already know that one. So anyways, that's been it for this video. If you guys enjoyed the video, please make sure you leave a like and subscribe, and I will see you again in the next one.
Hello everyone, and welcome to the first video in our Python expert level tutorial series. Now what I'm going to be doing in this series is teaching you about some expert level features in Python, how they work, how to implement them, and then getting into how you can actually use them and why you would use them in your Python code. Now it's worth noting that a lot of the features I'm about to show you, as much as they're very useful and complicated and advanced and expert level, you don't necessarily need to use them. There's a time and a place, and as you guys learn this, you should refrain from using these features just to almost show off, and actually make sure that you understand the purpose of using them and use them in the correct context. That's what a lot of the focus of this series is going to be, is giving some meaningful examples that try to tell you when you would actually use this feature, or at least help you understand really why it works, so that you could think about a situation when it might want to be implemented. Now, quick disclaimer here, if you guys are not Python, intermediates already, or you're not familiar or fluent in Python, this is going to be a difficult tutorial series for you to follow along with. You're welcome to, as always, but just keep that in mind. I do have a lot of Python tutorials on my channel that are more beginner level, if you want to follow along with those before maybe jumping into something like this. Now in this video, what I'm going to be doing specifically is talking about some very interesting and cool features in Python. These are not anything specific, they're nothing you may not have seen before, but it's something that you need to kind of understand before we can move into the more advanced things. So we're just going to be talking about how Python code actually runs and why we can type out some weird lines like I'm going to show you in the next few minutes. Anyways, what I'm going to do now is briefly discuss how Python code is actually ran and executed. Now, I will say right now, I'm not going to go into extreme detail. I'm hopefully going to give you enough information so that you understand on kind of a surface level. But if you do want to read into this, I would recommend it, because understanding how your program is actually compiled, interpreted, and eventually ran on your machine is very important, and it definitely helps you understand why a lot of the things in the language work the way they do. So most of you would have probably heard that Python is an interpreted programming language. But what does that really mean? Well, to understand that, we need to define the difference between a compiler and an interpreter and talk about how they work together, because although Python is interpreted, it is actually compiled as well into bytecode before it is actually interpreted. So the way that Python works, and actually we'll go back to the definitions first. So a compiler, what does a compiler do? Well, a compiler takes some high-level code, typically high-level code, and translates it into a lower level. So for example, the Python compiler that we use is going to take our Python code, which should be considered high-level code, that's furthest away from the hardware, right, and translates that into something called bytecode, which is a little bit harder for us to understand and closer to the computer's level so that it can actually be used and ran on our machine. So what does an interpreter do? Well, an interpreter takes some kind of code, typically bytecode, and interprets and runs that code. So it will read that code and translate it on the fly into machine code that can be executed by our computer, rather than doing this translation beforehand. When you use something like C, what you typically do, and depending on the compiler that you're going to use, there's tons of different versions and methods of doing this, you will compile your code directly into machine code, which means that it can be ran directly on the operating system that you're using, and you don't actually need an interpreter to interpret your code and run it. Now, I know this seems like a lot, but this is something that we kind of need to understand. So now I'm going to go into the way that Python's kind of execution chain is when you actually, press that F5 button or do whatever it is you're going to do. But essentially what happens in Python is you write your high-level code, which is going to be on your desktop, in your text editor, your Python code. And then when you press that run button or you go to execute that code, what happens is it's translated into something called bytecode. Now, this translation is simply just a tool that checks all of the syntax for your Python code and then converts it into some equivalent code that can be read by the interpreter that we're going to use. So what happens is if you have invalid syntax, like say I just type CL or something and that's not defined, or I mess up and I don't have a colon or something like that, then we get an error because the translation can't happen because the format of our code is incorrect, and hence, invalid syntax. That's the error that you would get. Now, assuming that your syntax is correct, then what happens is you'll move on to the next stage where everything will be translated into bytecode, and then that bytecode will run through the compiler, and the compiler will translate that bytecode in like a live time into machine code that runs and executes on your machine. So this is why there's a lot of issues with Python running on, say, mobile devices or on other devices that don't have a Python interpreter, because this bytecode cannot be directly understood by the CPU. You need some kind of interpreter to run it. So hopefully that clears it up a little bit on how that works. The basic summary is, you write your high-level code, translate it into bytecode. That bytecode is then translated through an interpreter in live time as it's reading line by line, so one at a time, not all at the same time, into machine code where it is executed, and that's how your program runs. This is different than a lot of other languages, and each language has a very kind of complicated process of compiling and interpreting and running code. So anyways, I hope that kind of cleared it up a little bit, but this feature of being interpreted and having a lot of things happening live is what we're really going to dig into here. So the first thing that I want to show is something that's unique in Python that's not unique in a compiled language. And that is the fact that a lot of checks and a lot of things that you typically can't even write with, you could not compile code that exists, these types of things in other languages you can do in Python. So let me just show you what I mean. All I'm going to do is create a class dog, and inside the init method, I'm simply going to call a method that does not exist called bark. So this is my file, intro.py. We have a class dog, init, and a method self.bark that's being called, but that method does not exist in the class body. Now, for any of you that program in other languages, you'd say, okay, well, this is not going to work, right? If we don't have this method, the compiler is going to pick that up. It's going to say, okay, we cannot compile this code. You need to define that method, or you need to remove this statement. Whereas in Python, we do, what was this? Python intro.py. No issues. We're totally fine. We're good to go. This is something that's unique about Python, is that a lot of the code is actually executed at runtime, not at compile time. All that the compiler really does for us in Python is just translate this code into bytecode. It doesn't necessarily check that all this code is valid. Now, it's a good thing and this is a bad thing. We'll talk about why later on. But that's something to understand, that you can make errors like this in your Python code and they will not be caught until runtime, which can actually be a huge problem when you can't test every single aspect of your application. Your app gets through, goes into a production environment, something happens in runtime, you didn't check it because the compiler didn't pick it up, and now all of a sudden your code has crashed, right? So that's something to consider. Okay, so we've done that. That's fine. That's just something I wanted to discuss and show you, and that's kind of the way that Python works. Everything is actually happening kind of live. It translates, but then the runtime environment is what picks up on a lot of these errors. Okay, so now let's get into some cooler things and talk about some strange things that we can do in Python that we can't really do in other languages. So I'm going to define a function, and I'm actually going to make this function called makeClass. So define makeClass. Now what I'm going to do in here is get a parameter called x, and I'm actually going to define a class inside of this function called dog, just like we did before. So I'm going to say class dog. Let's say define underscore underscore init underscore underscore. We'll take a self value, we'll take a name, and then we'll just say self.name equals name. Okay, now what I'm actually going to do is say define print underscore value. What I'm going to get this to do is simply print the value of x. So we'll say print x like that. And then I'm going to go down here and I'm going to actually return the dog like this. Now notice that I didn't return an instance of the dog by putting the brackets. I simply returned dog itself, which is actually a reference to the class, not actually the object. So what I'm going to do down here now is I'm going to say CLS equals make underscore class, and I'm just going to print out CLS and show you what this is. So let's say CLS, let's give the value 10 in here. Let's go and let's see, first of all, is this going to work? Does this not work? Why does this work? What is this even doing? Well, we'll talk about it. Okay, so this actually worked. So see what happened here. We had this function called makeClass, took an argument x, and then we had a class dog that we defined inside of this function. Now, first of all, this should look strange to you, but the reason we can do this is because, again, the Python compiler does not check if this is valid or not. It doesn't really care. So long as you have valid syntax, so long as the format is correct, your Python code can run and it can execute, and that's fine. And that's exactly what's happening here. We can define a class inside of a function because that's just the way Python works. We read from the top to the bottom, left to right, and that's totally fine. That's totally valid. Now, what have I actually done inside this function though? Well, I've created a class that uses a value from the actual function argument here, and then we actually return the class itself, not an instance of that class. Now, notice that's something that we can do in Python as well. Since Python code is running live, it's kind of executing on the fly, all of these things that we've defined here are actually being stored in memory. So this dog class here actually has a memory location for it. That's why we can actually see this. Same thing with this function, same thing with our variable, and same thing with anything else that we define. That's something that's true about Python, is that all these things are actually defined and stored in memory, which means we can interact with them live, which is what we're doing right now. So when I printed CLS, we can see that I got main.make underscore class.locals.dog. Now let's just translate this a little bit, although I'm sure most of you understand this. Main simply means this came from our main module, which is a module we ran. Make class is the name of the, function that we defined here. Locals defines what's inside of this function, and then dog tells us the actual name of the class. So that's what we printed out here, but now let's see how we can actually use this. So what I'm going to do is actually make an instance of this now. I'm going to say d equals CLS name Tim. And then I'm actually going to say d.print underscore value like that. And let's run this now. So now we actually get the value 10. So what I've done is I've said, okay, well, this CLS variable is actually a class. Since it's a class, what I can do is use it the way that I would typically use a class. It's literally just another name for dog. So we'll put our brackets, we'll create an instance of it, which makes self.name, equal name. I can show you that as well by just printing d.name. And then what we'll do is call the method on our object now that prints the value that we gave when we actually created this class. So you can almost think of this function that we've defined here as a, class constructor, where it's creating the class for us, then we can use the class. So I think that's pretty interesting. That's something that's cool. And again, if we wanted to, I could define another function inside of here. We can do another class inside of this class. I can make 7 classes inside of this function. there is no limit to what you can do so long as you're using the correct syntax and, you know, it's not going to crash at runtime, right? So that's something to consider. Now let's show some other weird, cool things that we can do in Python that's actually using some other kind of syntax. So what I'm going to do now is I'm actually just going to make a for loop, and you might kind of be thinking about what I'm going to do here. So I'll say for I in range 10. What I'm going to do is define a function. I'm going to call this function just, I don't know, let's do show. And all this is going to do is simply print the value I, and let's just do I times 2. Why not? Make it a little bit cooler. Now I'll call the function show here, and let's run the code. And no surprise to any of you, when I run this, that this should work fine, and we get all of our values printing out. So we can obviously do things like this. I can define a function inside of a for loop. What I've done here is, well, only one show will actually ever exist at the end of this kind of runtime, but I've defined 10 different shows that do 10 different things, and I've called them directly after, and then they get overridden, and I do them again. So that's something that's cool, and again, another feature of Python that you can't really do in some other languages. Now, what happens if I take this show and I put it outside of the for loop, so it's not running at the same time as this function is defined at? Well, let's run this. We see we just get 18. The last show that was defined is the one that exists and the one that's created. Now, why would you ever do something like this? I don't really know. Maybe if you had a lot of content inside of this for loop and you had a function, you were going to use it multiple times, but only locally, you could define it up here. Again, doesn't make that much sense to me to do that, but just showing you some of the features of the language. Okay, so now let's show some other things that we can do. I'm trying to think of something that would be cool. Okay, so let's do another one here. Let's say define func. What I'm actually going to do here is take some value, let's just say x, and I'm going to return a function from this function if the value of x is a certain value. So I'm going to say if x equals, let's just say 1, then what we're actually going to do is make a new function. We'll say define, I'll just say like rv, which will just be return value. And then inside here, we don't need any parameters. All we'll do is say print x is equal to 1. Okay. Otherwise, what we'll do is say define rv, and then we'll say print x is not 1. Okay, now we'll return this function rv. And if you guys remember from what we've done before, what I can do is say, okay, new underscore func equals func of, let's just do value 1. And then I can actually call my new function like that. Because notice, if I don't do this, right, then let's have a look at this here. Nothing gets printed out to the screen. But if I call my new function by putting my two braces outside of it here, then what we get is x is equal to 1. And we could change this, obviously. And then we would get a different value where we get x is not 1. So we can do interesting, cool kind of like paradigms like this. Again, I don't know why you would use this. There's easier ways to accomplish this, but it's something to consider is that this can actually happen. And any arguments that we use here, obviously we can use inside of these functions as well. And we can get into some pretty complicated things when we start defining functions inside of functions inside of functions. Okay, so last thing that I want to show you is just a cool thing that we can do to actually look at some of the details of our objects. Because remember that I said everything in Python pretty much happens live. This function is an object, this function is an object, our variables are an object, any classes are an object, which allows us to do what I'm doing where we're passing them through and around the program. They all have their unique memory address, and so long as we can reference that, we can use it. So let's actually see how we can inspect and look at some of our functions. So first of all, I'm just going to show you, and you've probably seen this before, we can look at the ID of our function if we'd like to, just by doing this. Now if I print this out, this should give us the memory address, the location of our function, which we can get right here. And there's a lot of other things that we can do as well. And one thing that I want to show you is actually by importing the inspect module. So the inspect module can show us some pretty cool things because of the fact that all of our Python objects, classes, all of that are actually live. We can interact with them, we can inspect them, and we can ask questions about them and get that value back from the interpreter. So what I can actually do in here is say print inspect dot, what is this? I'll do get members for now just to show you. So get members, I won't really discuss exactly what this does, but it's just going to show you some details about the function. So let's look at this here. We can see we get all of this little information, and we can obviously use this if we wanted to. Let's see if we can pick anything out in particular. that stands out. Nothing. Okay, so here we go. Function.func locals rv at this memory address location. So it just gives us all this details. That's called new func is down here, the name of it. So we can get some stuff like that. Not extremely useful. We can't use that at other times. Another really cool thing is we can actually get the source, which is the source code of a specific function, method, class, whatever you want. So here, when I do this, it actually tells us the source code of this specific Python function. Now, why would this be useful? Well, if we wanted to see exactly what was happening in some kind of thing that we were using that was maybe library code, we couldn't access that actual code, we could have a look at the source code like this. So now I want to show you another useful thing of this inspect module. If I were to import some module, and this is kind of a good use case of it, say like Q, right? Which is a Python built-in, what is it? From Q import Q, this is a built-in data structure from Python, and I wanted to look at the code of it. Obviously, there's other ways to do this, but if you wanted to just quickly do it in your terminal, then what you could do is do something like that, and now we could actually see all of the code that's been used by Python itself to create this object or create this class. So I think I'm going to wrap it up here. It's been about 15 minutes. I hope that this gives you guys a good understanding of Python a little bit more, how we can pass objects around, how we can look at their values, we can inspect things, we can look at the source code, and just remember that everything in Python is pretty well happening live. All these objects are defined in memory, and well, since they're defined in memory, we can do a lot of cool things with them, like pass them around the program, and since the Python's an interpreted language, we can do all these crazy things where we define classes inside of functions, functions inside of classes, inside of functions, and we can go crazy, and we'll continue to do that as we get further into this tutorial series. So if you guys enjoyed, make sure you leave a like, subscribe, and I will see you guys in another Expert Python tutorial. Hello everybody, and welcome to video 2 in the Python Expert tutorial series. In this video, what we're going to be doing is talking about Dunder/magic methods and the Python data model. Now, this is very important. This is something that I guarantee you've seen before, but you probably just haven't understood what it actually was or why it was working the way that it did. And this is actually going to give you a great insight into the way that a lot of things in Python actually operate, because until you see this, you kind of just take them for granted. So what I want to do is give you a very basic example of two objects in Python just kind of being used and interacting together. Then I'm going to show you how we can create the same thing with our own Python objects and even modify existing Python objects to implement implementations or operations that we want. So what I'm going to do to start is I'm going to just make two variables here. I'm just going to make a list. I'm going to say 1, 2, 3. And I'll make another list that just says, 4, 5, like that. Now we know that with lists, we can add them together by using the plus sign, right? We know that that's fine, that we're allowed to do that. So let's actually have a look at how that looks. We get that list and it adds them together. Now, why does that work? We don't really know. We kind of just assume that that's a feature in Python that we can add lists together, right? And that's totally fine for our intermediate kind of understanding. So what about length, right? I can get the length of a list. That works fine too. So if I look here, I get a length of 3, and there's all kinds of things that I can do on a list. Like I can index something on a list. I can put, x1, and that gives me some value here. And you're like, well, why are you showing me all this stuff? Because you're going to see that this kind of syntax that we're using right here on this object, because this list is actually an object, and I'll prove it to you just by printing the type of it and telling you that it is actually a part of a class. You can see class list is implemented under the hood. Now, you might not understand what I mean by that right now, but I'm actually going to import inspect and show you, and then we'll get into a little bit deeper of this understanding. So what I'm going to do is actually just say print inspect dot get source of list. Now list, this is going to be ridiculous when we look at this in the terminal. List is a built-in class. Oh, it won't let me look at the source of the built-in class. Okay, that's fine. We don't need to look at it for now. But anyways, the whole point of this is that these objects here, this is an object. This list they're both objects. We take for granted the fact that we can perform certain operations on these objects using some special Python syntax, right? Like even being able to multiply lists together. Like I can do x multiplies by 3, right? That's kind of a special syntax. Why is it that we're able to do that? Well, that's because this operation is implemented on the list object itself, and it tells the list object how to behave such that it sees a multiplication sign right after it, or such that it sees a plus sign, or it sees this index, or it sees a call. We implement that functionality, and because we can do that, we can implement that on our own objects. Now, let's do one more example. So obviously we saw when we printed out the value of this, right? We printed out x. we just printed, like, it just looked exactly like this. It printed 1, 2, 3, right? Or in fact, actually, let me show you. If I do a space here and I just print X, let's have a look at what we get here. We can see that this gets uniformly spaced even though there wasn't a space here. So it's not the fact that it's just printing out exactly what this looks like. There is something under the hood that's telling Python what this list object looks like and what to print when we decide to print it out. So let's create our own object now, actually. So I'm just going to say class person like this, and let's just define an init method. Now this is actually a double underscore method or a Dunder method or a magic method, whatever you'd like to call it. We'll talk about how this one works in a little bit, although I'm sure you guys understand. So we'll just make our object person. I'm going to say p equals person like this. Make an instance, give it a name of, say, Tim, and then if we print the value of p, well, if we were, if we looked at the list before and we saw that the list printed 1, 2, 3, 4, just printed exactly what it looked like, we would assume that when we print P, it should just print person Tim, right? It should print this. Well, when we look at it, it doesn't do that. And I'm sure you've seen this before. It prints the memory address location. Now, the reason it does that is because we have not told person what to do when we try to print it. It does not know what we should show. So by default, it shows the information that it thinks would be valuable, which is simply just its memory address location, right? That's its like representation internally in the Python program. So how can we change this? Well, we can implement what we call a Dunder method or a magic method, which is called repr. Now, I'm sure you've seen this before, but essentially what repr does is allows us to define the string representation of an object from inside of it. So what I'm going to do is make an f string, and I'm simply going to say person, and then in here, self.name. So now when we decide to print this out, what we get is person Tim, and I'll just do it one more time, instead of getting that crappy, just gibberish of memory address location. So this is the first thing that we can do, is we can implement methods such as this on our own objects to implement some kind of functionality. Now, let's show a few others and why this is so powerful. So there's actually a whole list of what we call Dunder methods. And this is what's part of the Python data model, and some people call these just data model methods. And essentially, you guys can read through this if you want. I'll leave the link in the description. Someone remind me if I forget. If we scroll down to the bottom here, we'll start to see that there's all kinds of these double underscore methods that we can actually implement on our own objects. And obviously, I'm not going to go through all of them because there's just so many to kind of talk about, but let's keep going down here. So for example, new, init, del, repr, right? We have this one here, string, bytes, format, lt, le, eq, ne, gt, ge. We'll talk about what all those are. Hash, bool, right? Get attribute, set attribute, dir, del attribute, multiplication. There's all these kind of things that we can do. So what I'm going to do is actually do a weird one, and I'm going to implement the multiplication double underscore method. So what this tells Python to do actually is what happens when we use a multiplication operation on objects of this type, on objects of type person. So what I'm actually going to do in mul here, I'm going to assume actually x is going to be some integer. And what I'm going to do is just take the person's name and multiply it by whatever the integer is. And that's the operation we'll implement when we use the star or the asterisk on the person object. So what I mean by this is I'm just simply going to say self.name equals self.name times x, and I'll even do a little just thing up here. I'll say if type x is not int, then we'll simply just throw an exception. So we'll say raise exception. We'll just say invalid argument must be int. Or in, yeah, whatever. It doesn't really matter what we put there, but that's fine. Okay, so we'll say p equals person. Now what I'm going to do is simply print p. I won't print that actually. We'll just say p times 4, and then we'll print p. And let's have a look at what this gives us. Okay, person, Tim, right? So we can actually implement whatever functionality we want using this upper level Python syntax by implementing some kind of lower level Dunder method. And that's what the whole point of this video was to do, was to show you that everything that we use in Python, all of these different symbols, can be implemented on a lower level on our own objects. And these again are like data model methods, right? So we can create objects such that we can add them, we can multiply them, we can have representations, we can do a call on them, we can do all kinds of crazy things. For example, let's do define underscore underscore call. Let's just do self. Let's take some argument. Why not? Why? And let's just print this value. So what I'm going to do is now, instead of printing p, I'm just going to do p and put value 4 in there. And now let's watch what happens. So if I go like this, we get the value 4 printing out. We could even change this, call this function, right, 4. So what happens is we can implement the fact that these two brackets, what these two brackets do if they are on an object, which is really cool. It allows us to make objects that are much more usable, much more readable, and just almost seem like they fit in with the standard Python documentation, because I don't need to necessarily call a method. I could actually just put the brackets. Now, anything you can think of with this kind of syntax, you can probably implement. For example, define underscore underscore len underscore underscore self, return the len of self.name. Maybe that's how long a person is, unless you're going to ask for their height or something like that. Then what we could do is print the len of p, right? So if we go like this, we get 3, as that's the name. So that's kind of the idea behind these Dunder methods and these data model methods. The whole point is everything that's above, even something like division, greater than or equal to, less than, whatever it is, equals, index, all of these things can be implemented. And if you want to see the implementation details of how all of these work, then you can read through this data model documentation, because there is a ton of them. The whole point is you don't need to memorize these, you just need to know that they exist. And then you can think about, for example, if I have a class and I want to implement some kind of functionality, maybe I have a polynomial class, I want to add them or multiply them together, then rather than having to make my own method called .multiply, what I can do is simply implement the mul double underscore method, and then that will allow me to use a star on it. Now notice you're going to want to make these type safe, because obviously I multiplied by an integer, but you could technically multiply two people together. You can do all kinds of things such as that. Okay, so now I'm just going to show you something interesting. This is just maybe to kind of enlighten you a bit, or to show you something that we could actually do in theory. So what I'm going to do is import, or actually I'm going to say from q import q and import inspect. Now what I'm going to do is just make a Q object. So I'm just going to say Q equals Q. If you don't know Q, it's just a built-in data structure in Python, works as a Q, pretty straightforward, and print Q. Okay, so I just want to print Q to just show you that Q does not actually implement a repr method. So let's just do this. And you can see that we're getting some random, kind of memory address printing out to the screen. So if I wanted to actually see why this wasn't giving me that representation, I could have a look into Q itself. So I could say print inspect dot get source, like that, and then I could print my just Q object like this, or not Q object, sorry, Q class, have a look at the source code, and we'll see that if we scroll through it here, we don't have any Dunder methods that are implementing any functionality. So let's say you wanted to make your own Q class that worked very similar to the Python Q class, but you wanted to do things like allow the plus sign, or you wanted to do things like allow the minus sign. Well, what you could do is you could say from Q import Q as Q, like that. Then you could say your own class Q is extends from Q, and then you can implement your own Dunder methods so that you could override this. So for example, define underscore underscore wrapper like this, and then what I want to do is maybe I want to show a Q, but I want to say how many elements are in the Q. Well, then in that case, what I would do is return Q, and then I would say Q, and then I guess in this case it's gonna be self dot underscore Q length or Q size, something like that. Now what I do if I create a Q, I say, QU equals Q, like so, and I decide to print out QU, like that. So let's have a look. And we can see we get Q with 0 items. Now, the reason I knew to use Q size is because I read through the source code and I saw that Q size returns the length of self.q. And I see here we have self.q equals Deque. What else do we have? All these other things. So this Q actually just implements a Deque object. Where's the init? It's right here. You can read through, you can understand how this works. So if you wanted to actually add something to the Q, right, using maybe the plus sign, and you didn't want to implement something else, then what I could do is say define underscore underscore add underscore underscore self item, like that. And then what I would simply do here is, okay, let's add that to the Q. So we'll say self dot put and then item. So now if I want to add something to my queue, I can say QU plus 9, and it doesn't even need to be equals. I can literally just do plus 9. And if we come here and we run this, now we have an object Q with length 1, right? And I could keep doing this. I could do QU plus 7, right? Like that. And then if I wanted to, I could literally implement a negative sign. So I could say QU minus. We have to put something here, but if I want, then I'd say define underscore underscore sub underscore underscore self item, and then all I could do is say let's just say self dot get, like that, and that's all we need to do. So now if we run this, we should see Q as length 1, and even though I just put a minus sign like this. Actually, I'm curious if this will even work. Q minus invalid syntax. So I could do like Q minus none if I wanted to. And then that still will remove that item for me. So this is the idea, right? These Dunder methods allow you to implement these kind of syntax things as higher level syntax. And this is what's called, again, the data model in Python. This is how all these different objects work. And these Dunder methods can be very useful. There's a lot of different ones. I'm not going to go through all of them, but the whole point is that you understand that each one of these kind of unique pieces of syntax in the higher level of Python maps to a lower level Dunder method that implements that operation, right? So that's the way that this works. So yeah, so hopefully that kind of cleared things up on Dunder methods and magic methods. They're really not that complicated. They're very useful, and when you're creating classes where these operations make a lot of sense to do, like adding, subtracting, multiplying, especially working with numeric values, being able to avoid having to create your own methods like define, add, x, y, and being able to just implement the Dunder method add and use the plus sign can make things a lot more intuitive and just easier to read in your programs. So anyways, that has been it. I hope you guys enjoyed this video on Dunder methods, magic methods, and the Python data model. As always, if there's anything you'd like to see in the future videos, please do leave a comment down below, like, subscribe, and I will see you in the next video. Hello everyone, and welcome back to another Python expert tutorial series. What we're going to be doing in this video is covering metaclasses, a fairly complex but very interesting topic in Python. So we're going to start from the very beginning and start understanding how classes are actually created, instantiated, the way they work on a lower level in Python, and then from there we're going to move into what metaclasses are, how they actually work, and why we would even want to use them. Now, I'm just going to preface this video by saying metaclasses are an extremely complex thing. I'm only going to be showing kind of the basic implementation of metaclasses here. If you really do want to use these, you're going to have to look up the documentation and implementation details on your own. And there's very few instances in which you need a metaclass. A lot of what I'm about to show you can be accomplished in other ways. And typically, you're going to want to use another way other than a metaclass just because these are seen as very complicated and almost sometimes bad practice, depending on what you're trying to do. So these should really only be used by experts. I mean, I'm showing them to you guys so you can get an intuition on how they work. And if you see one, you'll understand what it does. But you shouldn't really be putting these into your own code and using them unless you absolutely need to. So before we get into the content, again, a quick thank you to Kite for sponsoring this video series. They have a download link in the description down below. You can download them for free. They are essentially a very good Python autocomplete. So you can see if I start typing some things like this, we get a Kite completion thing popping up. And anyways, that's what they are. They're free. You can download that from the link in the description. All right, so let's go ahead and get started. Now, the first thing that I want to do is really discuss how classes work and what classes are. So we saw in the previous example, in I believe 2 videos ago, I did something crazy like this, right? And I made a class and I defined it inside of a function. And then in that function, I actually just returned the class itself. And this is totally fine. This is valid syntax. You can see I just ran the code down here. We don't get any errors. That's fine. The reason we can do something like this in Python and not in other languages is because in Python, classes are actually objects. Now, the property of an object essentially means that we can interact with it at runtime. We can pass it around through parameters, through variables. We can store it, we can save it, we can modify it, we can interact, right? That's what an object is. Now, a lot of people are going to say, well, how is a class an object? I thought a class created objects for us. Well, that's very true. A class does create objects for us, but that doesn't mean that it's not an object itself. And if a class is an object, if you believe what I'm saying, and I'll prove it to you in a second, then that means we must have had some higher level class that created that object for us, right? Just like if I make an instance of hi, and I do something like that, that means we must have this class hi such that we can make an object, and have the instance for it. So what we're going to be getting into here with metaclasses is The basic idea is a class defines the rules for an object, right? It defines the attributes, the parameters, the methods, the things that are allowed, the operations that can be performed. That's what a class does for an object. What a metaclass does is define the rules for a class. So when you create a class, you will use the metaclass to create it. This happens automatically. You don't need to type anything specifically, but we're going to hook into it later and see how it really operates. And that metaclass defines how this class is created. And that's the basic concept here. So I'm going to make another class, and I know this is confusing, but as we go through here, you're going to start to slowly understand with these examples. And all I'm going to do is just print an instance of this class. So let's look at it. We can see this tells us it's an object, main test object at some gibberish location. So now let's print above this just the class itself. Okay, look at that. Class main.test. Now the reason we're able to do this again is because this is an object. So I know this doesn't explicitly say object, but this class is an object. Now I want to look at something else. So we know we have this method in Python called type, and I can look at the type of a class or an instance or an object, and I can see what it is. So let's look at it. When we do the type of test, we get that it is in class main. If I were to print, say, the type of an integer, right, like the type of 2, let's have a look. That's class int, right? And we could print, you know, the type of whatever we want. We could print the type of a function. So we say define func like that, and then we'll just say pass in there, and we do func. What's that? That's class function, right? So that exists in a function. So this is an object. This function's an object. Everything in Python is an object, and that means they have a type and they were created somehow. So what is the type of a class? Well, let's look at it. So we'll delete all this, and then we'll just print the type of, and I somehow hit insert accidentally there, of test. So what do you think this type is? Is it of type test? Is this class of that type? No, it is of class type. Now I know this seems ridiculous. This means nothing to you right now. We're going to dive into what this is, but essentially this is what we would refer to as the metaclass. So this type is what essentially defines the rules and creates this class for us. When we type this class syntax, we will call a type constructor using the different things in our class to make this class object that we can then use to make objects and use to interact with in the program. So what is type? How does this type thing work? Well, if I told you that this class, all this is doing, this syntax is just calling this type class, then we should explicitly be able to create our own objects without typing out the syntax like this. We should just be able to use the type class itself, which is true in what I'm about to show you. So I've just created a class, test, it has pass, it has nothing in it, right? Now I'm going to show you how we can make this without actually having to type this kind of syntax and writing out class. In fact, and this seems ridiculous, I agree, Python should have done a better job when they defined this, but I believe it's something to do with just backwards compatibility. We can make a class by doing this, and just watch and then we'll talk about exactly how it operates. So this line of code is completely equivalent to this. These two things are completely equivalent. There's absolutely nothing different about them, and I can use test here the same way I can use test here. Just like I can create an instance of test, I can create an instance of this other test. So let's do it. Let's prove it to you. So if I print test and make an instance, boom, main test object. Works totally fine. No issues with that. What else can I do? I can print the class, and again, same thing. We have that object, totally fine. That's because this function here essentially creates the class for us using these different arguments. A name, this is the internal representation of the class. Any bases, which means anything that we inherit from, so like a superclass or a parent class, and then any attributes. So let me start showing you what I mean, and then hopefully this should make some more sense. So I'm going to set an attribute of 5. I'm going to say t equals test, make an instance, and just print that attribute, I can go like this, of t.x. So just like this works on a regular class, we can do that. We get our value 5. Now, just like in regular classes as well, I can define attributes outside of the class. So you say something like t.wy, why not? Set that equal to, let's just say, hello. Want to print wy? Sure, let's go for it. T.wy. 1 second, guys. Oh, t is not defined, so that needs to go above. So I can explain metaclasses, but apparently cannot just create regular classes. Okay, so that's totally fine. That works. we have t equals test and then t.wy equals hello. We can print that attribute. That's totally fine. So that's how we can create classes using type. Now, what about methods? What about sub? I'm going to show you all of that. So we'll do that now. And then we'll get into actually metaclasses and how this is even useful to us. So what I'm going to do is make another class. I'm just going to call this class foo. Let's just make a method in here just called print. Actually, not print. Let's do like show. And then all we'll do in here is take one attribute. We'll say self and just print hi. Why not? Right? Just do that. So if I want to now have an inheritance, what I can do is simply type the name of the class, a comma, just to make sure this registers as a tuple here. And now test will inherit from foo, which means that if I want to use the method show, I can do that and I can run that like that and we get that. Now I shouldn't have printed that out because I forgot that wasn't a return value, but you can see we get hi. That works totally fine. This is how you do this, right? Now, what if I want to add methods, right? So to add a method is a little bit different, but essentially what you're going to do is just define a function that will be the method signature. So in this case, let's say, add attribute, put self like that. And then here we just say self.z equals 9. Why not, right? We'll do that. And then in here, we'll define our attribute. So we'll say add underscore attribute, colon. Guess what we're going to do? Add attribute, no brackets. Now, make our instance. Let's call t.add attribute. And then let's print t.z like that. And let's look at this. And there we go. We get the value 9. That works fine. So this is how we use type. This is how we create a class. And this is very important to understand as we get into the next part of the tutorial here. Because if you can understand how we use this to create our own classes, then you're going to understand the next part and why, when we have a syntax like this, all this really does is pass that information to another class called type that creates the class for us and returns an object that represents that class. Now, I know this was a lot. I hope you guys understand at this point. Now we're actually going to get into metaclasses. This was just the underlying information we needed to understand. All right, so welcome to the next part of the tutorial. What we're going to be doing now is actually getting into metaclasses and showing how they work. So again, the basic principle here is to remember that a metaclass is above the classes you're creating yourself. So if you create something like class dog, right, and you do that, what's actually happening is all this information that you type out, the syntax, gets passed to some meta class, the thing above it, that actually takes that and returns to you an object that represents that class. And that's the whole point here. So what we're going to do is actually make our own meta classes. So rather than using that built-in type class, and you could see on all of our objects when we looked at the type of them, they were of type. We're simply going to make our own meta class that inherits from type, so does a very similar thing, but we're going to change slightly how objects are constructed so you can really understand how this works. Now, you might get lost a little bit at the beginning when I start typing some of this stuff out, but hopefully you should start to follow along as we go through and explain how all of this works. So let's get started. I'm going to start just by creating a meta class. I'm going to call this meta. Now, whenever you make a meta class, what you have to do is make it inherit from type. Not necessarily, but for our purposes, that's what we're going to say. It has to inherit from type to make a meta class. The reason for that is because type does some other things when it's creating an object, right? And if you don't inherit from this, well, your class is just going to be not a meta class now because it's going to be using type to create this kind of class, if that makes any sense whatsoever, but hopefully that does. What we're going to do now is I'm actually going to define a new method like this. And for those of you that don't know what new does as a Dunder method or a magic method like we talked about before, essentially this is called before the init method. So this is the first thing that is always called when an object is created or instantiated or whatever you want to call it. This is always called first. So what you can actually do here is hook into this and modify the way an object is constructed by changing what happens in this new method. Whereas the init, all the init is doing is after this new method gets called and the object is constructed, what it does is it initializes it. It changes the values, it takes some parameters in, like that's what it does, right? Whereas new is just called beforehand to modify the construction of the object. Okay, so what I'm going to do in here is I'm going to take self, I'm going to take class name, and remember, this is what's going to be called whenever we create another class that uses this as a meta class. We're going to say class name, we're going to say bases, and bases is what we put, remember in that type argument when we want to do inheritance, we have the name, we had the bases, and we have the attributes. And guess what this last one's going to be? It's going to be attributes. So essentially, we're saying, okay, when we create this new method, the construction of a class, which happens in this meta class, needs to contain the class name, the bases, and the attributes, so that way we can look at them, we can do something with them, and we can return to you a class that has those pieces of information, right, as an object. So what I'm going to do now is simply just return the type of, in this case, it's going to be class underscore name, bases, and attrs. Now, this is very simple. We're not really going to do anything other than this, but I'm also just going to print out the attributes so you can see what they look like, okay? Now, what I'm going to do is I'm going to make another class. I'm going to call it dog. This is going to have a meta class that's equal to meta, like that. And then in here, all we'll do is just say x equals 5, y equals 8, just so we can look at some things when we print these attributes out. And then we'll create an instance of dog. So we'll say d equals dog like that and run the code. All right, so look at this. What has happened? Well, actually, I'm even going to get rid of this and just show you that even if I don't create an instance, this still runs, right? You can see no instances, this is still running. The reason for this is because the default meta class of dog is type, right? That's what it runs, and that's how the class is created. What we've done is we've overridden that. We've changed it to our own meta class, and essentially we've added our own little piece here that just prints out the attributes and then returns to us an object. And remember, this is an equivalent way of creating this class by just literally typing this line, and this is what happens. This is what we get. So we can see that we have the attribute module is equal to main, the qual name dog, so that's the name of this class, right? And then we have our attributes, so x5, y8, that we've defined down below. Now, what if we define a method called hello, and we print, say, hi inside of here? Well, then you can see we have dog.hello at some memory location. That's mapped to by hello, and that's a function. So that's how this works. Now, knowing this information, meta classes can be very powerful because, for example, let's see, like I can hook into the construction of this class and I can modify the construction of it if I want. Now, this is something you would never do. What I'm going to do is actually change all of the attributes that I have here to be, uppercase. So I'm going to change this x to be a capital X, this y to be a capital Y, and this function hello to be capital hello, so all capitals. I won't bother changing, I can't change these underscore methods, but I'll show you how we do this. Okay, so let's start programming this. So what I'm going to do is I'm going to make a blank dictionary. I'm just going to call it A, because notice down here that all of my attributes are actually in a dictionary, right? So what I'm going to do is modify this attributes dictionary based on the attributes that were passed in and make them all capital, assuming that they don't start with 2 underscores. So what I'm going to do is say for item in attrs.items, and I'm not sure if the syntax is 100% correct, so there might be a mistake here. We're going to say if item dot starts with, and in this case, it's going to be underscore underscore. Then what we'll do is simply just add it back into the dictionary. So actually, yeah, we'll just add it back into the dictionary. So we'll say A, in this case, item equals attr's, and then item, like that. So essentially, since this is dictionary, the way this is going to work, right, is we're just assigning this item to this new dictionary. It's just literally the same thing, right? Okay, otherwise, so if it doesn't start with a double underscore, we need to change it to be uppercase. So we're going to say A, and in this case, item.upper, like that, equals attr's item. Then we'll change the attributes here to be A, which will be our modified attributes. And that means when we return this dog class, this should work, assuming I haven't made a mistake, which is likely, but let's look at it. And let's see what I got wrong. All right, so I guess I've forgotten the fact that when we do something like this, I need to actually loop through with name value rather than just item. So name will be the attribute name. Value, obviously the value mapped with it, just means we're going to have to change a few things here. So we'll say name. So if having to do that, we can change that to val. We can say name, and that's, yeah, so name here. This will be val, like that. And I think we should be good on that front. Let's run that. And let's have a look at this error. Name val is not defined, of course. I've made it value. Let's run, and there we go. We get good. Okay, so I haven't proved to you really what happened, but let's just step through this code because I did make a few errors, so it might be confusing. So we started by printing the attributes. We then made a blank list, a blank dictionary, sorry, that's going to represent our new attributes. And then we've looped through all of the attributes. So we just do dot items to get the name and the value. And we said if the name starts with a double underscore, just add the proper value back in. Otherwise, what we'll do is add the uppercase attribute with that corresponding value. So we've changed them to uppercase essentially. So let's actually print the values down here. So the new values, just have a look at the difference. And you can see if we scroll up here that notice hello has been changed to capital hello, X to capital X, and Y to capital Y. So now let's do another proof just to make sure that all of you believe me that this is okay to do. And let's go down here and say d equals dog, create an instance, and let's try to see what d.x is. So just print d.x. Well, what is the error? Let's look at this here. Dog object has no attribute x. What? But we defined x up here. That's because we've changed it to be a capital X. And notice that when I do that, that's totally fine. And same goes with hello. I can't access that, but when we change that to capital hello, we're totally fine because, again, we've modified the construction of the object. All right, so now that we kind of understand how metaclasses work, we've seen that we can hook into them, we can change the way that objects are created, we can enforce certain constraints, I can change all of the attributes to be capital, I can do whatever I want, right? I could change the bases, I could remove an inheritance if I didn't want that to be allowed. Essentially, this is why they call it magic, because with this kind of hook into the creation of classes, you can really enforce quite a bit of constraints on how classes are created. So for example, if you want every single class in a specific module to never be allowed to use a certain attribute or to only have or to have that attribute, you could set metaclasses for those or for that actual specific module, which I'm not going to talk about now. And then when that module is run, it will check the metaclass, right? It will go through the metaclass. That's how we create the classes itself and make sure that all of these classes kind of conform to that structure that you've defined. Now, this is specifically nice for when you're writing kind of library code and you want your user code to be very specific. Let's say they're inheriting from a specific type. You could check if they're inheriting from, whatever type it is that you want. If they do inherit from that type, you can enforce the fact that they have a specific function or specific method in that class that's needed to make that work. So that's some of the things that you can do with metaclasses. Again, they're very complicated. There's not really like a need to use them, so you don't necessarily need to implement them into your program, but sometimes they're cool, and understanding how this class construction works to me is even a better benefit of using the metaclass itself. So I believe there was one last thing that I wanted to cover here, although it's not coming to me at the top of my head. I mean, I think that's pretty much it. I don't know what more I can show you guys. You can have metaclasses that inherit other metaclasses. You can do very, very complex things with that. But I think, honestly, for now, we're going to wrap the video up at this. I hope you guys enjoyed. I hope you understand now how classes are created, how metaclasses work, and what the heck they even are. And I hope that you understand that you don't need to use this. And the point of this video is to introduce you to the concept and make you more familiar with the way that classes and objects actually work in Python. So anyways, that has been it. I hope you enjoyed. Make sure you leave a like if you did, subscribe to the channel, and I will see you in another expert Python tutorial. Hello everybody, and welcome back to another expert Python tutorial. So in today's video, we are going to be talking about decorators, which are a pretty cool and useful tool. They're not super complex, but essentially they allow us to modify the behavior of a function without actually changing any of its code. Now this is useful because sometimes you want to be able to add and remove decorators while debugging a function, or maybe you want to change the behavior of all of your functions, and rather than going in and changing all of the code, you could create a decorator which will allow you to simply, use one line of code to change the behavior of all of these different functions. So I'll show you how this works and what a decorator actually is to start by just going through a bit of a kind of recap of how Python passes objects around and why we can actually even use a decorator. A quick reminder before we get started that Kite is the sponsor of this series. Kite is the best AI autocomplete for Python on the market, and you can get it for free in the link in the description. It integrates with all the popular IDEs and text editors, so Sublime, VS Code, Atom, Vim, you name it. Chances are Kite is, compatible with that. Again, you could download that from the link in the description. So the first thing I'm going to do is I'm going to create a function called func. Now what I want to do is just show you that if this function takes a string, I can actually return another function in here that does something with this argument. And we've seen this before in the previous expert Python tutorials, but I want to just make this very clear on how this works. So I'm going to call this function a wrapper because it's inside of this function. It's not going to take anything as an argument. And what I'm simply going to do in here is say print started, print string, and print ended, like that. I'm gonna do a capital. And I guess actually this string, does not need to be in a string. It needs to be like that. So we print the variable. And then what I'm gonna do here is simply return the wrapper function like that. So if I do this, now what happens if I say x equals func like that, and I put in my string, let's say hello, and I run this program, you can see we get started, hello, and ended. Now the reason that happened is because we returned here the wrapper being called, right? These two brackets. But if I remove this and I do this now, nothing happens. So what we've actually done, if I print out the value of x, is you see we store a function in here that was returned from this function, which is actually equal to this. And then if we wanted to call this function, we could put our little braces like that, and here we go, we get started, hello, and ended. So I just want to show you that this is possible, and the reason this is possible is because functions in Python are objects, which means that we can pass them around, we can throw them around our program, and you can see up here that this is the location of the object, function wrapper from func.locals. Okay, so now that we understand that, let's bring it up a little notch and see what happens if we actually, instead of just passing a string in here, pass another function. So I define a function, I'll call it func2 like that. And all we'll do in here is just print something. Let's say I am func2. Why not? I'll get rid of this. And now, rather than passing a string in here, why don't we actually just call some function? So let's put f in here. Let's put, I don't want func2, I just want f. Let's call whatever function is called. So we'll do print started, call whatever function was in here, and then print ended, and then return this function. So let's see how this works. So now if I can move this down a bit, let's say x equals func2. Let's print x, and then let's call x. So what we're doing here, for anyone that's confused, is we've created this function which accepts a function as an argument, right, or as a parameter. Then what we do in here is we define a function that prints started, calls whatever function was passed in, prints ended, and then returns this function. So this is not actually going to do anything until it is called. So when we return this, we'll store it in a variable x. And then when we want to use this interior function here, we call it with this, right? The x in the brackets. So let's have a look at how this works. Control B, and you can see started, I am func2, ended, func wrapper locals, right? And the idea here is that I can do the same thing with, say, func3, right? If I print, let's say, I am func3, like that. Now, rather than passing func2, I can pass func3, and we can see now we get the same thing happening except func3. And in fact, we could do it, I could say y equals func2, and then we can do the same thing and just call y down here. And now both of them are going to work, and they're both going to be different. So started, I am func3, started, I am func2, ended. So with this in mind, we can start looking at kind of what a decorator is now almost, but I just want to show you a way that, let's say, this function right here, which we're going to call our decorator, we don't want to have to do this weird call, right? Where we use our decorator function to call function 3. We just want to call function 3 and have it do this behavior and, do whatever function 3 is, right? How would we get that to work? How would we get that to happen? Where rather than me having to call func and pass func3 and call func and pass func2, how can we do this another way? Well, what I can actually do is kind of a cool sneaky line here in Python where I do this. I say func3 is equal to func at func3. Now, this seems like a weird line of code, but essentially what this is going to allow us to do now is rather than having to call function and pass func3 in, we can actually use func3, which is a variable now, which stores the function that is returned from the call of func with function 3, which means that if we call func3 like that, then what's going to happen is it's going to run this function that was created from this call. So this is a way that we can kind of change that behavior. We can say, okay, so func3, I always want this, whatever's inside this wrapper function, to happen whenever I call it. So all I need to do to define that is write this line of code. And now every time I call func3 from anywhere in my program, it'll do this. And if we run this, we can see that happens and that works fine. And we can do the same thing with func2. Func2 equals func2. And then we'll call func2 like that, and we can see that it works for both of them. So this is where we now get into the concept of a decorator. Things are going to get a little bit more complicated, but now all I'm going to show you is what a decorator does versus what we've done. So this kind of line of code here is weird, right? Like it's not something you really want to write. You don't really know where to put it. It's like just not ideal to have to write this line of code. So Python has thought of this for us, and what they've introduced is a syntax that essentially allows us to do this just in a better way. And all it is using this @ sign and putting the name of your decorated function, so like that, just on top. So now this line here pretty much just replaces this line. Like they are exact identical copy. They do the same thing. This just looks a little bit nicer, and it's a little bit easier to understand what's happening when you have, you know, this decorator syntax above the function. And you can actually decorate your function with more than one decorator if you want. We're not going to talk about that right now, but that's something to note. So pretty much to replace these lines of code, all I have to do is put @ the name of the function that I want to run before, right? And then now if I do func3 and func2, we can see we get the same thing. So we get started, I'm func3, ended, started, I'm func2, ended. So this is how this works. So whenever you're creating a decorator function, you need to kind of implement this wrapper functionality where the first thing takes the function itself, and the second function here, well, this just takes the, or what is this? This creates the function that's going to be called when this is returned, right? Or when you actually call this function. So essentially you're changing, you're saying func2 is now going to be equal to whatever this is, and usually inside of here, you're going to use the function. Now, there's a lot of problems that I'm sure some of you can think of here. So what happens if I say func2 takes an argument x, and instead of saying I am func2, all it does is just print out x. What happens now? Well, if I run this, and let's give an argument, let's give 5 here, you can see we're getting an error, right? And the reason we're getting an error, this huge error, what does it say? Wrapper takes 0 positional arguments, but 1 was given. So the issue is that when we actually call func2, what we're actually going to be calling from this line of code is this wrapper function. So this wrapper function needs to have the same amount of arguments that function 2 has. So how can we do that? How can we fix that? Well, we could just put an x here like this, right? And then let's comment out func3. Let's run this. Oh, sorry, my bad. We got to throw an x in here. That was what the issue was before. So we have our x's there, and then this works, right? So I put an x in the wrapper. I put an x here, which means that when I call this, x will be passed to this wrapper x, and then we can use that to call the function, and that's totally fine. But what happens now when I want to use func3? And func3 doesn't take any arguments, but this takes arguments. The whole point of decorators is to be able to use this on multiple functions, and we get missing one required positional argument x, func3, there's an issue, you know, things are happening. So what do we do here? How do we fix this? Well, this is where we use what we call the unpack operator, I believe, or the splat operator or something. But essentially, you can put star args, star quargs, like this, and what this will allow you to do is accept any number of positional or keyword arguments. So essentially this says, okay, we don't know how many arguments are going to be coming in here. There could be an infinite amount. So rather than just trying to guess or figure it out or write a different wrapper function for every single amount, what we'll do is simply write star args, star quargs, which tells us accept all of the arguments that are passed in, accept all of the keyword arguments. And what we can actually do is simply pass whatever these are to this function. So let's do this here, star quargs. So now what's going to happen is any arguments passed in will just automatically pass to f. Same with quargs, and if there's none, we just won't pass anything. So this kind of handles any amount of arguments, and now we'll see that when we run this, we don't get any error, and this works fine for any number of arguments. So even if I were to add, you know, x, y in here, something like that, and then we call this with like 5, 6, and run that, still same thing. This is working. Doesn't matter how many arguments we have. We're perfectly fine. Okay. So that's good, but what happens when we return a value from function 2? Well, what happens then? So let's say x equals print x, and right now, so we can see that we're returning y from function 2, right? But if I call this and I print x, we don't get y returned to us. So how can we fix this, right? So what we actually need to do is, since we're calling the actual function here inside of the wrapper, we need to store the return value. I'm going to store that as RV so that I can return it at the end of this wrapper function. So since this wrapper function is returned from here, this could return a value as well. And well, we don't want to return immediately. So like I could just write the line return f like that, and that would work fine. But we want to do something after the function is called. So to solve this, we do rv, and then we can return rv. So store the return value of this function, return it at the end, and now if I print this, you can see that we get our return value of 6. So that is how we return values. That is how we pass in different amounts of parameters. And now I'm just going to show you a few actual useful decorator functions that you might want to use. So you're probably looking at me like, well, what's the point of this right now? Like, why do we have this? Well, a good example is, say you want to validate input. Say you want to have a bunch of functions that accept some numeric input, and that numeric input is always going to be between the value 1 and 10, right? Rather than checking the parameters every single time inside of your function, what you could do is you could use a decorator that checks them for you, right? And then all you would have to do every single time you want to validate that your input is correct is throw a decorator over top of your function that says validate input, or whatever it's called, write the appropriate code inside of a decorated function, and these kind of functions like this, and then you're good to go. So that is kind of the idea behind decorators, that you can modify the behavior of a function, add functionality to it without modifying the code. And sometimes you don't want to touch the code of a function because you want to make sure that you're not breaking anything. You don't know how it's been written, but you want to add something on top. For example, maybe timing how fast the function runs. And this is a very common example. I'll show you this as kind of our last example to using decorators. So yeah, we'll do a timing one. So essentially, if I want to time how long a function takes to run every single time, right, then I can create a timer decorator. So you know what, actually, let's do it from the start. Let's erase all of this and do one from the beginning. So I'm going to say define timer, which is the name of my decorator. It's going to take in a function. We'll define a wrapper. This will take star args, star quarks, like that. Again, quark stands for keyword arguments. What we're going to do here is start by importing time. We're going to say, let's say start equals time.time, like that, and then we'll just print started. Or actually, we could do something else. Let's do this. Let's say rv equals func, like that, and then let's say end, or we'll say total equals time.time minus start, and then we'll print time, like that, and we can put total, and then we will return rv and return wrapper, like that. Oops, I did not mean for those. Okay, so now that we have that, let's create a function. Let's just say defined test, and then here we're just going to say for underscore in range 1000. Let's just say pass, and there we go. So now if I want to decorate this function, I can say at timer, and what this will allow me to do now is when I run this function, have it tell me how long this took to run. So let's go ahead and just actually call test, like that, and see it ran in 0.0 seconds. So I guess this rounded for us, but I guess, would I be able to do this, make it take any longer if I add any more zeros? There we go. So we can see that is how much time this function took to run. And if I wanted to add timer on another function, well, then I could do another one, say test2, like that. And we could even just say time.sleep. Why is my capitals on? 2 seconds. And we'll decorate this one with at timer as well. And now when we call test2 and we run this, give it a second, and we should see that this takes 2.001 seconds. So this is how decorators work. Again, useful when you want to modify the behavior of a function without actually touching it, without changing it. You can add other decorators on top of an existing decorator. I'd urge you to see, how that actually works, how you'd be able to do that. You can test that out for yourself. But for now, that's pretty much it. And a really useful example of decorators is a timer decorator. When you're debugging, you want to check what is really slowing down or how long something's taking. Another good example is having a logging decorator. So having a decorator that essentially logs the calling of functions or what's happening in the program, that's a good one to add here. And then obviously validating input and checking return values and stuff like that is always a good example of when you might want to use a decorator. So with that being said, I hope you guys enjoyed. If you have any questions, as always, leave them down below. And with that being said, I will see you in the next Expert Python tutorial series. Hello everyone, and welcome back to another Expert Python tutorial. So in today's video, we're going to be talking about generators. Now, generators are a pretty straightforward and actually very useful expert level feature in Python, and chances are you've probably seen them before. Now, before we get into generators, I do need to quickly mention that this series has been sponsored by Kite. So Kite is the AI autocomplete for Python that I've been using throughout this entire series and just through my daily coding. You can see that when I actually start typing something, we get these nice suggestions popping up from Kite with the little kite icon here. It is just the best Python autocomplete. It works very quickly and actually saves you quite a bit of time and works for other modules that aren't just built-in Python things. So it's pretty useful. If you guys want to download it, there's a link in the description and it's free. So, go ahead and do yourself a favor if you do want that autocomplete. Okay. So now let's get into generators. Now, actually, before I discuss generators, I want to show you the problem that generators help us solve. So we should understand that in our computer, we have a finite amount of memory, a finite amount of RAM. And when we run a computer program, our program is loaded into that memory. And when we're storing things, manipulating variables, lists, all of that, that's all stored in our computer's memory. That's because that is the fastest way for us to retrieve and write data while we're in a program. We could put some things on a hard drive, but that's pretty slow and it really depends on what we're doing, but most of the time we're working in RAM. And what that means is that we are limited to the amount of RAM that is in our physical computer when we're writing a computer program. And in fact, most of us will never even see the error that I'm about to show you, but it is possible to actually fill up all of RAM, right? To use all of RAM, to have nothing left. And in fact, that's what I'm going to try to do right now. So if we look at the example on the screen, and I've just started running the code, you're going to see this takes a second to run. What I'm trying to do is generate the sequence of all of the squares from the number 0 up until, I want to say this is like 100 million or 10 million or some number like that, right? And then what I'm going to do is loop over all of those numbers and print them out. And you're going to notice that very shortly, yes, and there we go, we get the error. We get a memory error, which essentially means that, nope, we can't do this. These numbers are too big. We don't have enough room left in memory. We're not allowed to use that much space. No, that's not allowed. So how do we go ahead and how do we fix this? Well, this is where we use a generator. Now, before I actually create a generator, I want to look at something here. If all I'm doing in this specific application is just printing or processing, say, one value at a time, which is what I'm doing when I'm looping over this list, right? One value at a time, I'm processing it. I'm not accessing other values. I don't need values that are in the future. I don't need values that are in the past. Then is it really necessary for me to create a list like this to loop through? And the answer is no, obviously, right? In fact, what I could do is replace this for loop with just a print statement, right? So I could replace this entire thing. Actually, we'll just do it down here. So let's say for I in range, and then we'll just type that same number, whatever, that's close enough. And then what I can do is print I the exponent 2 like that, right? And this is the same thing. And this is the idea behind generators. This is not what we're going to do precisely to generate this sequence, but generators allow us essentially to look at one value at a time and to not store the entire sequence of numbers when we don't need to do that. And I'm actually going to code out our own kind of generator pattern here that just uses a class and some Dunder methods to illustrate what's actually happening inside of a generator when we use it. Now, I understand that most of you probably still don't know what a generator is, but after I write this class and start showing you, hopefully this should make sense. So what I'm going to call this is just gen, and what I want this to do is the exact same thing that we did before, where it's going to generate a sequence of all of the squares up to some number. Let's say that number is n. So in this case, I'm going to say, let's define underscore underscore init underscore underscore. Let's take self, let's take n, let's say self.n is equal to n, and then let's say self.last is equal to 0. So this is going to be the last number that we generated the square for, and we're going to use this variable to keep track of the last number we generated the square for so that we know which next number to use, and I'll show you how this works. We're going to define actually, in this case, we're going to do a Dunder method, so underscore underscore next. It's going to take self, and what it's going to do is return self.next. Now, I know we haven't defined self.next yet, but we're going to do that now. So define next self. And in here, what I'm going to do is generate that sequence that I did before, except I'm just going to do it using these two variables. I'm not going to do it using a for loop like we had before and storing everything in a list. So what I'm going to say is rv equals self.last to the exponent 2. So this is saying our return value is going to be equal to whatever this last number is that we have to the power 2, right? So we're going to find the square for that. Then I'm going to say self.last plus equals 1. We're going to say if self.last, and in this case equals self.n plus 1. Actually, what I need to do is, put this at the beginning of my loop. So if self.last here equals self.n. Then what we're going to do is say raise stop iteration. Stop iteration is just an error that we can raise that essentially tells us, hey, no, we can't go any further. And then what we're going to do is return this RV. Okay, so now I'm going to show you how we can use this. So this we can actually use in a very similar way that we were kind of looping through the numbers before. And we're going to say, in this case, g equals gen. Let's say we want to loop up to, you know, some massive number like that. And now if I want to actually loop through this entire sequence, what I can do, and I mean, some of you are saying, oh, this isn't big enough. Okay, let's go bigger. We'll say while, in this case, true, we're going to say try print the next value of g, right? And what this underscore next is allowing me to do is call this next function or method or whatever you want to call it on g here, and we can print the value. And then I'm going to say except stop iteration, and then we're simply going to break this loop like that, and we should actually be good with that. Okay, so what this is going to do now is loop, and I'm just going to make this number smaller just so we can see that it does actually just go up to 100, but I promise you this does work with an infinite sequence, and we'll watch and we can see that this works just like we would have before, and we can generate all of the squares for these numbers. Now I can make this number absolutely massive. I can make it, you know, that super long number, and this will be totally fine. And in fact, that's because we're not storing all of this in a list where we're storing all of the previous values. All we're keeping track of is kind of the internal state of the next number we need to generate. And this is the idea behind a generator, is that we don't need to store every single value. What we can do is just store, you know, almost the last value that we generated, and then using that, we can generate the next one, right? Or we can figure out the next number to generate. And obviously this kind of pattern, like you can write this if you want, but what Python has done for us is kind of come up with a pattern that makes this a little bit easier called the generator pattern. So what I'm going to do now is pretty much take this class and I'm going to convert it to a generator, and I'm going to show you how this works. So I'm going to say define gen, and here this will just take the value n. And what I'm going to say in here, say for I in range, and in this case we'll say n. Then we're going to say yield I to the exponent 2. Now, I know this seems weird, but essentially the way that this works is instead of using this crazy pattern that we had before, we're going to use the yield keyword. Now, what the yield keyword does is as soon as we hit this, it returns this value to wherever this was called from or wherever we were looping through, and then it pauses this function. So rather than stopping the execution of this function, which is what a regular function would do when we hit the return keyword, it just pauses it, which means we actually keep track of what I was, so we still know what that number is, we still know, you know, what n is, we still have all of the internal information of this function stored in memory, we haven't gotten rid of that, but we're just pausing when we hit this yield keyword. That's what that means. So think of yield as like a pause, whereas, for example, return would be a stop of execution. So we can use this generator by doing something like this. G equals gen, give it some number like this, and then what we can do is say for I in G, and then what we can do is simply print out I. Now this is going to work the exact same as all of the other examples I've shown you before, and you can see that indeed it is working, and we could run this, you know, infinitely, and we're not actually going to ever run into a problem. And in fact, I probably should have made this number a little bit smaller because I feel like this is going to run for a long time, but anyways, that can go down there. So this is the point of a generator. And I know some of you are still confused, but the way you have to think about it is we create this generator by creating this function gen with, what do you call it? You know, 100,000 or whatever it is, whatever this number is, 1 million. And then what we can actually do is loop through this. And what happens when we loop through this is it runs this for loop up until it sees this yield keyword. So it sees this yield keyword, I to squared, right? And then as soon as it sees that, what it does is it pauses the function and says, okay, we don't need to run this anymore. And then it waits until it's called again. So until we loop through it again with this for loop, the next method on it is called, and then it returns to us the next yield. And because it's pausing rather than stopping execution, this is totally fine. And in fact, we can actually look at how much memory this function is using versus if we were to do the same thing, say with a list. And we'll do that in a second, but I want to show you that to use this generator, I don't have to just loop through it with a for loop. I can use that next method that I showed you before. And if I do next G and I run this, you can see we get 0 because obviously the first answer is 0. And if we do this a few times, we get 0, 1, 4, 9. So this is how this works. When we call the next method or the next function on our generator, we get the next value, so essentially up until it hits the next yield keyword. And in fact, we actually can use more than one yield keyword in our gen if we want, and I could say yield 1, and we could do as many yields as we want, so let's do this. And then let's actually show what happens when we go past how many yield keywords we have. So if we look at this here, we can see we get 10, 100, 1,000, 10,000, and then we actually end up getting an error. And there was a 1 up here, just so you can see. And that error is actually a stop iteration error right here because we don't have any more keywords yield inside this generator, so there's nothing more to return. So this works the exact same way that I showed you with that class that I did before, where it keeps track of the internal state. It knows what line it was on when it paused, and then it goes to the next one until it hits the next yield keyword, and that's when it pauses again. And that's how a generator works. And they're pretty useful. There's some other things that we can do with them. And in fact, I'll show you comparing the size of, say, a generator like the one we just created versus actually generating an entire list. So you can see in memory how much this is actually using. So if we want to generate the sequence, right, we know this generator works, we can use that now. So let's run that. And what I'm going to do now is import sys. I'm going to actually make that list that I did before. So we're going to say x equals, and in this case, we'll say I to the exponent 2 for I in range. And we'll just do, let's say, 10,000 like that, and we'll replace 10,000 here. And now what I'm going to do is just print out the size of both of these. So I'm going to say sys dot get size of, and in this case the first size we'll look at is x, which is that list, and then we'll get the size of g, and I'll show you the difference in memory. So what this does is tell us how many bits, or actually I believe how many bytes, are being used by whatever object is we pass in. So in this case the list, and in this case the generator, and you're going to see that we have a substantial difference. So this first list is using 43,816 bytes to generate and store the sequence, whereas our generator is only using 64. So you can see that this is really a crazy optimized way to be able to generate, say, infinite length sequences. And when we don't need every single value in the sequence at once, we just need it one at a time, which is what we're doing when we say loop through something, then it's much better to use a generator to generate this sequence for us. Now, there's a lot more that I can show you with a generator. We can close a generator, we can stop a generator, we can send values to a generator, but I'm going to leave that for people that are a little bit more advanced. The point of this is to introduce you to this concept of the generator, whereas when you're programming, think about, say, if you're going to make a massive list like this with a bunch of values, do I need all of these values? Am I using one value at a time? Am I looping through? Am I printing it? Am I adding it to something? Or do I only need, say, the last value and this value, or a few values? And obviously you can make your generators more complicated than a simple for loop. You can do some more complex computations. You can store variables inside of here, because remember that this yield keyword just pauses the execution when this generator is called. And what that means is that I can loop through this first generator, say, 5 times, and then somewhere later in my program, continue looping through it, and it will, resume where it left off. And that's a useful kind of construct. It's hard to show any examples in this, short amount of time, but hopefully this gave you an idea of when you would use a generator. So with that being said, I hope you guys enjoyed. If you did, make sure you leave a like, subscribe to the channel, and as always, let me know if there's any other expert level features you would like to see in the comments down below. Hello everyone, and welcome to another Expert Python tutorial. So in today's video, we're going to be talking about context managers. Now, context managers are definitely one of the more useful topics that we're going to be talking about, or that we have talked about so far, and you'll find yourself using them a lot, especially as you get into more advanced programming and dealing with things like shared memory and shared resources and unlocking and locking, and it just all those kind of things. Context managers come in very handy, essentially. Now, I'm actually almost certain that all of you have seen context managers before. In fact, I'll show you a few examples here of times when you've used them and just not known that you've used them. And that's kind of a common trend here that I'm hoping you realize is a lot of the stuff that we're using, it's not completely new to you. It's not something you've never used before. You just never really understood how or why it worked. And that's what the point of this series has been, is to give you that appreciation and understanding of how these lower level things work, so that you have more control over your code. And if you need to change them or write your own versions, you now know how, or at least have the intuition to do so. Now, again, this video is sponsored by Kite. A big thank you again to them. You can see whenever we start typing, we get these little Kite keywords popping up. It's just a really good autocomplete. And again, it's free. If you want to download it, it's from the link in the description. You can find that. Okay, so let's go ahead and get started with context managers. Now, the first thing that I want to do is show you what problem context managers solve to us. So I'm going to start, or solve for us. So I'm going to start by showing us the problem and then the solution with a context manager. So essentially, let's say we have some file and we want to open a file, right? So I want to open, say, file.txt. We'll open it in write mode, which just means create a new file if it doesn't exist yet. And then what we'll do is say file.write. Let's say hello, and then we'll say file.close. Okay, pretty straightforward, pretty basic. This will work. Run this code, nothing wrong with it. But what actually is wrong with what I just wrote? Well, looking at this at a surface level, it seems like everything's totally fine. I mean, we've opened the file, we've written one line to it, in this case, hello, and then we've closed it. Now, the issue occurs in this code if this line here, so this file.write line, doesn't work, or it doesn't happen. For example, like if I just error this line by putting an X here, and then we run this, we can see that we don't make it down to this file.close line because we had some error on this write line. So say we open the file and we start trying to write, something happened, something else had the file open, we couldn't access it. Well, now we've opened the file and we haven't closed it, and that's an issue. We need to make sure whenever we open a file or have some shared resource that we work with, that we close it afterwards. Now, a better example would probably be if I open this in read mode, as opposed to write mode, because that would mean that this file already exists on the system. But hopefully you get the point that the issue occurs when we open the file, we do a bunch of stuff, and we don't reach that file.close. So the point is, how can we make sure that we reach this file.close no matter what happens in between the open and in between the close? Well, the way that we could do that is we could use a try and a finally statement, right? So we could leave what we have right here, and we can just add a try like that, and then we could add a finally down here, if we indent that properly, for the file.close. So what this means is regardless of if this works or not, we will eventually or finally close this file. So that's good, and we've just kind of fixed our error there, and that's totally fine. But there's an easier and better way to do this that allows for a little bit more functionality. And what that is a context manager. Now, this code right here is completely equivalent to what I'm about to write. So with open file.txt, we'll open it in R mode again. We'll call this as file to be consistent, and we'll just simply say file.write, and in this case, hello. So these two kind of blocks, so this block up here and this block, actually do the exact same thing. And the way that this works is this open method here actually defines what we should do when we use it as a context manager, when we exit, and when we enter. So when we enter, what that means is, okay, when we open this file, when we write this code, what's the first thing that needs to happen? Well, the first thing that needs to happen is we need to open the file, and we need to return that so we can store that as the file object. That's the thing that's happening when we enter this context manager. And we can tell we're using a context manager because we're using the with keyword, and that's the most common way, and kind of the only examples I'm going to show you here is using the with keyword in Python. Then what we do is we do something, whatever we have inside here. We could print something, we could, file.write, we could do a for loop, doesn't matter. And then when this is done, so all of the code in here, regardless of if there was an exception or not, we will call the exit method. And what the exit method does is some kind of code that allows us to close our file properly and make sure that everything works. So essentially, the context manager is kind of like a hidden way to make sure that whenever we do one operation, we do another one, regardless of what happens in between. And again, that's really useful for things like opening and closing files and for locking and unlocking shared memory. So now I'm going to show you how we can actually write our own context manager that does the same thing that we've just shown here. So we have this open function, and we say with open file.txtr as file.write hello. We understand that after this runs, regardless if there's an exception or not, we close the file. But how does that actually work? Well, let's try to do that. So what I'm going to do now is I'm just going to make a class, and we're going to write this context manager. So I'm going to say class file. I'm going to say define __ init. And since we just want to do the same thing we did before, we're going to take a file name and a method in our init, and we're going to say self.file equals open file name method. Now, it's important to note that when we make a context manager, we don't necessarily need to use it as a context manager all the time. In fact, I'm going to start writing a context manager here and show you the methods we need to implement to do that. But right now, the function that we have here, we can use this fine, even though, it's going to be a context manager. We can instantiate it and we can use it as we usually would. We just aren't going to call these special methods that I'm about to write. So we have the first method, which is called enter. Now remember, enter I told you is the first thing that happens. And what this function needs to do is return to us some value that we're going to use in the context manager, right? When we wrote, for example, with something as, f, then this something is going to call this enter method. So we're going to store whatever's returned from enter in f. So that's what we should get there. So here, what we're going to do on the enter is simply return self.file. And again, that should be the open file object. Then what we're going to do is define an exit method. So underscore, underscore, exit, underscore, underscore. And notice these are special Dunder methods because they're going to be called in a special way automatically from Python because we're going to use the context manager syntax. So here actually takes 3 arguments. And the 3 arguments or parameters, I guess we have our type. I believe we have, I'm going to look to make sure I haven't messed this up. We have value, and then we have traceback. So essentially what this does is regardless of whether or not we get an exception between when we open, or so between when we enter and between when we exit, if we get an exception, it's actually going to call this exit method with that exception so that we can handle the exception in here the way that we would like. And I'll talk about how that works a little bit more in a second, but let's just do what we wanted to do, which is self.file.close. So for now, we're actually going to omit the fact that we're going to deal with these parameters, although we'll talk about them later. So in here, I'm actually just going to write some code, some print statements so that we can see what happens when we enter and when we exit these methods. So print, enter, print, exit. So now what I'm going to do is I'm going to set up the same thing I did before, except this time instead of saying with open, I'm going to say with file. And the reason I'm allowed to do this is because I have this enter and exit method defining that this is a context manager. And I'm going to say with file, we have, let's say, file.txt. Let's put that in, say, read mode. Actually, we'll put it in write mode. And then we'll put that as f. We can say f.write hello as the classic example that we've been using. And now let's actually run this code and let's look at these print statements and make sure this works. Okay, so we get enter and exit, and inside of here, I'm actually just going to put a print statement that says middle, just so we can see how this works. So even though I haven't explicitly called this exit or this enter method, we can see that they do get called. So enter, middle, exit, and they get called in the appropriate timing, right? So this stuff happens in between the enter and the exit. And now what I'm going to do is simply put an exception in here. So I'll say, put some letters here just to make sure this crashes. Let's run this. And actually, sorry, that's going to be a syntax error. See if there's any way that I can get this just to crash. Let's just say raise exception like that. And now let's see if we still get yes, we do. So we can see we get enter, middle, exit, and then we get the exception raised afterwards, even though we raised the exception before we got to this exit method. So what this essentially says is regardless of if there's an exception or not, we're going to call this exit method. And the point of this is so that we can actually handle an exception inside of our exit method if we need to. So I know this is kind of confusing to see in my trace down here because there's all this text, but look what's happening, right? We can see that in line 17, an exception was raised, but the thing is we still called this exit print and we still closed the file, even though that exception was raised, which again is the advantage of a context manager. Okay, so what I want to do now is show you what this type, value, and traceback actually is. So we notice that what happens is essentially any exception that's raised inside of here actually gets sent to this exit function where it can be handled. And that's why we see this exit popping up here, because we enter, we do this middle stuff, some exception was raised in the middle, that's fine. So we immediately go to this exit function where we pass that exception and we wait to see if it gets handled. And that's why all of this code in the exit function runs before we decide that we're going to crash the program or that something's going to happen. So what I'm going to do now is show you how we can actually handle an exception inside of this exit function, and again, what type, value, and traceback are. So now we'll keep printing exit, but we're also going to print all of the different values that are here. So we'll just use an F string, and we're just going to do a bunch of commas so that we can see what all of these are. So type, value, and in this case, traceback. So let's run this now. We're still going to get a crash in our code, but now we can see that we have a class exception, none, and then a traceback at some location. So if we wanted to, we could look at this traceback, we could look at the type of the exception, and we can actually handle it. And in fact, the way that we handle an exception from our exit is if we determine that this exception is fine, that we shouldn't crash the program, that all is good, what we're actually allowed to do is return the key value true. So if we return true from this exit method here, that's going to tell Python that we gracefully handled this exception, which means we don't need to crash the code. We don't need to run or, see all this traceback in the output here. We're fine and we're good to go. And in fact, if I run this, you can see that by simply adding this return true here, we no longer get a crash in our program and everything is fine. Now be careful with this because you don't want to just add return true if there is actually exceptions and they need to be handled properly. In fact, a better practice would probably be to do something like if type equals and then whatever type of exception you were looking for. Maybe I raised like a file not found exception or something and we were looking for that specific one. Then what you could do is handle that exception inside of here and then return true in that instance. And in fact, this still works because the type was exception, but I'm trying to see if I can raise so let's say file exists error. Let's do something like that and run this, and you can see now, because that wasn't just a regular exception, this crashed because we didn't handle that properly. So that's how we can handle errors inside of this exit function. You just return true if when you check through this error that's passed in here, you get some valid stuff and you can handle it, right? And if you don't return true and there's no error like we've seen, that's totally fine. So if we don't raise some exception, regardless of if we return true or not, everything works fine and we're good to go. And that is one of the massive advantages of context managers. Okay, so now I'm going to show you how we can actually create this same context manager, because this seems a little bit complicated, using a generator. So we've talked about generators and we talked about decorators. And what we can actually do is import something called context lib. So we can import context lib like that. And from context lib, there's actually a decorator in here that allows us to decorate a generator that becomes a context manager. And I'm going to show you how that works. Okay, so let's do the same example we did before with opening a file, but now using a different kind, well, not really different kind, but just a different way of creating this context manager. So what I'm actually going to do is I'm going to write this decorator, and the decorator is context lib dot context manager like that. There's no brackets at the end. And in fact, what we could have done is said from context lib like this, import context manager, and this is a built-in library in Python, and that will just allow us to do this rather than having that dot beforehand. So let's do that. I'm going to say define file like this, and what I'm actually going to do is take again the file name and the method, and inside here I'm going to say, okay, file equals open, and in this case we'll say file name method. Then I'm going to yield, because again this is a generator, the file object, and then I'm going to file.close. So what this means essentially is that the first thing we're going to do is say file, we're going to create this file object, we're going to yield this to wherever we're being called from, and then when this function resumes again, you can think of this as the enter, right? And this as the exit, we're going to close the file. And in fact, in here again, we can handle some exceptions, we can do things like that, and this is a quicker, easier way to actually make a context manager. So now I can say with file, and in this case, let's just say, well, what have we been doing? I don't know. Let's just say text.txt. Let's switch it up here. Let's go W mode, and we'll say as F. And we can say f.write. Let's say hello like that. And if we run this code, that's perfectly fine. That works. And now when we add our print statement, so we'll say print, enter like that, and we'll print exit like that, and then we can print middle, and we can see how this is actually working. Okay, so enter, middle, exit. So this decorator allows us to turn this generator object into a context manager. It works pretty much exactly the same as I talked about before. There is more to go in and kind of dive in with this this syntax right here. I typically recommend to people just to use the class syntax, just because it allows you to do some more things and is something more people are familiar with. But if you want to use this context manager decorator and do some things with this generator kind of syntax to use a context manager, you're more than welcome to, and that's why I showed you. So I think with that, I'm going to wrap the video up here. An interesting idea, though, if you guys want to mess around with context managers, is to think about locks in threading. So actually from the threading module in Python, I can't remember the syntax right now off the top of my head, you can have shared memory, and you can have locks and like memory locks, which essentially allow you to wait for another resource to give up this lock so that you can access a resource. So the point is, like, say we have one variable x here that's going to be accessed by 2 different threads. Well, we can't access and change x at the same time, so we create a memory lock. And what one thread will have to do is wait for that lock to be available before it's able to access the object. And you can actually implement this functionality with a context manager so that your threads, you make sure they unlock the resource before they finish changing it. So that's something that's interesting if you wanted to mess with that. I don't really have that much time in this video, so I'm not going to do that. But yeah, so with that being said, this has been Context Managers. I hope you guys enjoyed. If you did, make sure you leave a like, subscribe to the channel, and as always, let me know if there's any other expert level features you would like to see.